Where's the sun? Okay, welcome to day 2 here of the AIAA Design, Build, and Fly competition. I'm EJ, your Master of Ceremonies, here today with Meredith from the AIAA. How are you?
How's it going? Great. How are you?
I'm doing just fine. So, day 1, weather wasn't really cooperating with us yesterday. What happened?
Oh, man. So we did have a little bit of weather, but we did have 89 teams check in. We have more than 1,100 students here, and we had 20 teams fly. So I think overall it was an awesome day.
Yeah, I mean, so the missions that we saw yesterday were the teams going up and flying down and around, right? Like they were just going out and doing the test flight. That was mission 1, correct?
Yep.
Yeah. So we're supposed to see more of those types of missions today. Yeah.
Yeah. So I think we'll see a lot of mission 1. We still have a lot of teams that are left to fly. A lot of teams have passed tech inspection. So I think we're gonna have awesome flying out today. But we might also see some mission 2s, and that is our ducks and pucks. I actually even happen to have one of our hockey pucks here in my pocket. Right here. You can see that. So with Mission 2, they are trying to build a banner towing bush plane. And so they're loading these ducks as passengers and hockey pucks as cargo. So they're trying to maximize their income for their new business that they're starting.
Cool. Now, in terms of the weather today, I mean, we definitely got the sun in our faces today. So
Yes.
what do you think? The weather's going to cooperate a little bit better today?
It seems like it is. I mean, it is an absolutely beautiful day for flying. I know yesterday there was a lot of wind, a lot of teams, really struggling even to just put the plane down nicely.
Yeah, that headwind yesterday was terrible.
Oh my gosh, it was a true testament to their engineering capabilities and those planes. It was awesome to see them, struggle through but make it. It's awesome.
Cool, great. So hopefully the weather's going to cooperate with us a little bit later. Wait, hold up. Come here. Wait. I need you here. Hey,
good morning.
We got the big dog here.
Man.
This is Clay Morey right here. He's the CEO of the AIAA. So, Clay, we didn't have much trouble. We had a lot of trouble yesterday.
Yeah, yesterday was sporty. We are in Tornado Alley here, as they call it here in the Great Midwest. 60-mile-an-hour winds. There were some places in the state had golf ball-sized hail that came down. I think overnight, as that huge cell passed through, there were some tornado warnings across the state. 3 of the witches, I think, west, south, and east got taken out. There's ruby slippers out there somewhere. But Glinda remains unharmed.
So you're telling me we are in Kansas still?
We are definitely in Kansas. Look, we're here. It's amazing. We're in the air capital of the world.
Yep.
This is home to Textron Aviation with Beechcraft and Cessna Aviation. This goes back more than 100 years, this site.
Yeah.
So it's an historic place to be flying planes. I mean,
Absolutely.
Look, they don't call this the Great Plains region for nothing, right?
That's right.
Yeah.
That's right. Actually, Clay, I wanted to pick your brain a little bit. We have this competition. You guys throw this event. What's the value of it? Like, why do we do it?
AIAA is an organization of 33,000 engineers around the world, mostly in the United States. And we have 264 student branches around the world. So we like to attract all these branches to come and for the students to get practice building something, designing, flying it, breaking things, learning how to raise money, build a team, fly that team in or from around the world, or in some cases driving across the country, getting that spirit of teamwork together, learning how to engineer a product. And I'll tell you, I worked in industry for 20 years before I took this role, and we always looked for those team competitors. It was a very important thing. All the students that are watching on this live stream, you want to join a team because companies look for this when they recruit.
That's the key.
We want people that have that kind of practice, that real world experience, and so your resume automatically goes to the top of the stack.
That's probably a good thing. And we got teams coming from all over the world here, right?
It's amazing how far. We've got two teams from Bangladesh, 2 teams from Australia, we've got teams from India, all across Europe. 15 countries are represented here. So it's amazing that they come from all around the world to come and compete here. Last year, top 2 finishing teams were not American teams. Yeah, Santa Clara was in the lead last year till the very final end of the competition, last like 3 flights. And it was Graz from Austria, the Seeschwagels, the Seagulls. They swooped in right at the end and took the...
As a seagull does.
As a seagull does.
Right?
Yeah.
That's awesome. Okay, so You said that students are going to get their resume to the top of the stack, right? We got sponsors for this event, right? And they're here supporting this event as well, yeah?
Oh, absolutely. And Textron Aviation is a huge supporter for this. RTX, Raytheon is a huge supporter. We really can't do what we do without the help. And also our volunteers. Let me just say, there's about 50 volunteers on site here, and they drive this forward. I'm at the headquarters. Our staff is here, but it's really the volunteers that make this thing work. And a lot of these folks have been doing this, EJ, for 30 years. They've started this, and I got a little of that history yesterday. Right. We're actually going to try to do some filming, I think, on that, to talk to some of the people that were at the very first DBF.
Yep.
This is our 30th anniversary. That was held, by the way, on a small island in the Chesapeake Bay off the coast of Maryland. And somebody volunteered a little private airstrip. We had 10 teams. They were all in this big house on this island, and that's how the thing got kicked off 30 years ago.
Speaks to the iteration of the process from what we got now from that small island. That's great. That's great. So, we got day 2. That's Clay Morey here, the CEO of the AIAA. Hey, thanks for popping in.
Thanks, man. We're excited.
I kind of just grabbed you from
we're excited. We're getting ready on the flight line here. It's a gorgeous day. I think the weather is picture perfect.
Yeah. We got that sun in our eyes today. That's good. That's good. And the wind is definitely better. So, let's kick off day 2, 2026. AIAA Design, Build, Fly competition. We're going to go down to the flight line here, and flight should be starting very shortly.
At General Atomics, not only do we make remotely piloted aircraft, we engineer innovation. For over 30 years, our Predator, Reaper, Gray Eagle, and Avenger aircraft have offered long endurance, flight-proven performance, and versatility. Today, we continue to develop and manufacture state-of-the-art, remotely piloted aircraft, tactical reconnaissance radars, and surveillance systems for the U.S. Department of Defense and many of its allies across the globe. Electromagnetic Systems is a world leader in applying advanced technologies to launch and recover aircraft aboard carriers, as well as transforming innovative concepts in breakthrough surveillance and electric weapons systems. Our scalable satellite platforms support defense, civil, commercial, and academic mission requirements. From underwater to space, we support the future warfighting force. Since the dawn of the atomic age, General Atomics has advanced the full spectrum of science and technology. From nuclear energy and defense to medicine and high-performance computing. Because of our people, we continue to leave a legacy of exploration and innovation. Tasked to produce the center solenoid for the International ITER experiment, General Atomics has been entrusted to develop the world's most powerful superconducting electromagnet. Perfecting nuclear fusion in this lab demonstrates the feasibility of fusion power, a potentially limitless source of clean energy. With the freedom to explore, General Atomics delivers transformational technologies for the world. Innovation made real.
So my main project this summer has been working on interceptor reliability. What we're doing is we're trying to make it so that the battery on our interceptor can be hot swapped in the field without requiring additional calibration. So this is our flight cage. This is where we do all of our testing and preliminary flights for the drones. This is our dyno. This is where we secure the drone so that when we spin up the motors, it doesn't go anywhere. All right, so I'm running our interceptor on the motor dyno. What we're doing is it spins the motors, which spins the propellers up, and then from there it collects the data of what the motor offset values are, and then it calibrates it so that our interceptor can have its optimal performance. Working at Anduril is different than working at any other company, mainly because of the autonomy I have as an intern. I feel really empowered by my mentor and my manager to kind of do what I need to do in order to get my work done that week. It's also a lot different than other companies because I can see how my work as an intern over the summer directly impacts the company as a whole.
In aerospace, losing a major contract doesn't just mean missing revenue. It can shutter an entire division. Billions in potential business, gone. Because you don't get second chances to prove your design works. Traditional advanced design forces you to choose between speed and fidelity when both are critical. NTOP changes everything. Explore hundreds of design variants with high-fidelity physics in the same time as it used to take for basic estimates. With implicit modeling, you can create robust parametric models that never break, so you can quickly generate any possible configuration of your design and get near real-time performance calculations that enable deep trade space exploration and generate high-quality performance data at a pace aligned with project timelines. Arrive at design reviews with comprehensive trade-off analysis instead of rough approximations. Because in a world where billion-dollar contracts are won on technical credibility, low-fidelity insight isn't good enough. When you're asked tough questions, you'll have real answers backed by real data. NTOP, design with confidence.
We are scientists and engineers. We are technicians and thought leaders. Collaborative, inspiring, innovative. Advancing aerospace and defense with a bold vision for the future. We are here to connect and protect the world, powered by purpose and driven to make a difference. We believe no challenge is too great, no question too big, no answer out of reach. We believe in pushing the boundaries of known science to meet the needs of the future. We believe in the power of people, the strength of community, and the importance of freedom. With passion and purpose, we shape the next era of aerospace and defense to create possibilities for better tomorrows. Collins Aerospace, Pratt & Whitney, Raytheon. We are RTX.
What school is this? University of Maryland. University of Maryland.
Group behind the table, please. Guys, stay together. Anywhere you want. Alright, when I go, start timer, please. Alright, Sockets, ready? Okay, Army. Sorry, left down, Army.
Where'd he go?
Come on, baby! Let's go. Let's go. Alright, disarm.
Okay, Gatry DOS. Cameras.
Runway, we got another team.
Sorry, I couldn't talk while doing that. Yeah, it's very difficult with the sun in my eyes, and I don't know what happened. The camera just literally started freaking out, and I don't know. I've never seen that happen before. No, it was not an autofocus. It was not an autofocus. It was like physically making noises I've never heard before, so I don't know what that was about.
You don't have to worry about that. This is my job. That was what they were landing on. So you just need to...
No, it was not an autofocus, I'm telling you. It was in manual focus, and it just was doing that without my control, so...
But you don't need to be concerned. Appreciate it.
Can I grab a tool to pry the fuse out? Socket, we're good. Socket, we're good.
Judd, do you want bigger tape or anything? What? Ah, yeah.
for DOS.
Saludemos a la familia. Hey guys, just take your airplane out here on the yellow line. Yes, sir. Thank you, sir. So bring your flight sheet. No airplane record.
Thanks for Ryan. Keep them in just a second. Okay, Ryan, I'm good. Page for DOS, cameras.
No, no. As long as you know this is the start finish line, you're good. Anywhere else.
Ready to arm?
Okay, and we got the score sheet.
And I can stay next to the pilot.
Stay next to the pilot. Where you are. Awesome.
Yes.
Okay. All yours.
Once again, the course is reversed. It's reversed from yesterday because the wind is pushing in the opposite direction. And we had yesterday winds are coming out of the north today instead of the south. We got to do 3 laps here for this mission. Mission 1 is like 3 laps going around the track and then going down the landing. Now you have a certain amount of time to do it. About 5 minutes. Get this done. In order to meet the flight criteria for mission 1 success. Going into turn 3 and turn 4. Now the winds aren't as bad as we had yesterday. We had maybe not wind coming out of the south. Today, the wind's a little bit lighter coming out of the north. It's not too bad. All right. Going through turn 1 and turn 2. Once again, it's not too bad. Not too bad winds today. Going through the 360-degree turn on the back stretch of the track.
Are you guys too forward staging, or do you want to?
MIT opted for a tail dragger design here, meaning you got 2 main gear up the front, forward wing up the front of the plane with the engine, and then a long tail. That favors a little bit more stable flight. What you should do is just circle around for an approach. And they completed the 3 laps. Right? Bringing it in for 90.
right, good job. See you back.
See ya.
Mission 2. Watch all the cables. You can actually go on the concrete. All right. How'd you feel? How'd you feel? You okay? Go all the way wide.
You guys, score sheet. We're just going out the center right here.
Yeah, keep it in my pocket.
Good job, guys. I'll take it from here. You want to power on the transmitter so I can switch it to everything?
Where do I stand? You can be anywhere, but this is the start-finish line.
Okay.
Do we need to wheel it up to the start-finish line, or is here
You
fine?
don't have to. You can fly from there.
Jeff.
Okay.
What's up? We're going over here.
No, this is the start-finish line.
And then when we land, I might run this little thing down here so I have.
Bernie, is the transmitter on?
Yes, sir.
Okay. Alright, turn these off. Alright, throttle put on?
Throttle is cut.
Can we put fuses in? We're good?
Yep.
All right.
Ground crew back here, please. Stay on the pavement, please. Stay on the pavement.
Rochester Institute of
What?
Technology.
All right, team.
They're flying their plane, the Carbon Tiger.
Okay, team 39, Rochester Institute of Technology. All right,
Good.
Go for it, man.
here we go. All right, they've opted for a tricycle design here, twin engines on the side here. Easy rotation up there, right up into the wind, heading into turn 1 now. Oh, 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 oh. Looks like the wind's taking it a little bit, but pilot is turning it around here. Okay, now onto the back stretch of the track. Oh, trying to do the 360-degree turn that's on the back stretch here. All right, completing the 360-degree turn, going into turn 3 and turn 4. All right, bringing it around a little bit of.
Safety line. Over the runway. Over the runway. Over the runway.
Okay,
One warning.
you got a first warning there for going outside of the flight corridor. You got to stay over the runway here. That's the ultimate objective for mission 1. Mission 1 entails doing 3 laps around our track, which is more or less an oval, but on the back stretch of the oval, you have a 360-degree turn. This is to prove out that these planes are capable of doing mission 2 and mission 3 here. But it's important, with the exception of the 360-degree turn, to keep that plane over the runway. Okay, did 360-degree turn. Planes turning around through 3 and 4. Right.
43. Okay, that's what I thought.
Seems like the winds that are just a little bit off the runway are a little bit more intense than they are down here on the surface. But we got a little bit of winds coming out of the north here down on the ground, but here we go, 360-degree roll. Or turn, excuse me. Okay, right turn through 3 and 4 here. Oh, a little bit of roll,
We land or one more? Okay.
Okay, coming in for the 3rd lap. Okay, crossing the line there. Now I'm trying to bring it down. Wind's really blowing that plane around. Lot of roll. Okay, pilot's bringing it around, come in for a landing now. I'm not sure if
It seemed very chaotic this morning.
Okay, they chose to bring it down. Oh, a little bit of a rough landing down there at turn 3 and 4. Looks like may have lost the nose gear. Not an ideal circumstance there, but still a landing. Any landing you can walk away from. The plane still seems to be in one piece there, but it is way down there at the end of the competition area. So I got Chris back with me. Chris, what was the which team was that? That was 39, right? The Rochester Institute of Technology, right?
Playing the Carbon Tiger.
The Carbon Tiger. All right. Who do we have next on tap?
Up next is team number 40 from the University of Illinois Urbana-Champaign, and they're flying their plane Quill.
Quill. All right. So that's the next plane coming up. We're just going to have to wait a second there for them to clear that, though, right?
Yes, it's going to take a few minutes.
That's the idea. All right. So while the RIT go fetch the Carbon Tiger from the end of the runway, we'll be right back here in a moment.
Get the next team up if you're ready, just to
pick a place and stand on one place.
Get set up over here.
I can always change it, but I'm going to probably announce it when we take off. ENATOR. I just need it phonetically so that I don't mess it up and go Duckinator. Okay, does the plane have a name? Okay, you're right. Yeah, thank you.
We got the next team coming up here. This is team number 40 getting ready to fly. What we had going on down there on the at the other end was team number 39, where they made a little bit of a weird landing down there. Looks like the wind took it. The wind's kind of picking up here. Once again, the winds are coming out of the north. So we'll see what happens as the next team gets ready. So if you guys don't know me, I'm EJ. I'm the master of ceremonies here for flight commentary today. And I got Chris Horton with me from the AIAA. He's telling me what team we have coming up next. So this one is team number 40, right?
Correct. And they are from the University of Illinois Urbana-Champaign, flying their plane Quill.
All right. We got the Quill on the runway ready to go.
So damage.
So we're just waiting a second while they clear the last team, and we should get ready to go with the next team here in a moment. Now, Chris, we had a little bit of windy conditions yesterday, to say the least, right? We had a 20 knot wind coming out of the south. The wind's a little bit calmer today, and I think the weather is cooperating as far as we can tell, but it still looks like these planes are getting blown around a little bit up there, right?
It's been blown around quite a bit, yeah. It's and the cold too. I don't know.
That's a little
the plane, but it's chilly out here.
It's a little chilly. It's a little chilly.
Better than the rain yesterday and all the wind.
Yeah, I'll take that. Yeah, yesterday the weather got a little sketchy.
Sketchy.
Yeah, it got a little sketchy. You know, you hear the sirens go off, you're like, wait, what? You know? But, all right, truck is vacating here. We should be ready for the next team to fly. So you said this is the University of
Illinois Urbana-Champaign.
Illinois Urbana-Champaign. Team number 40, right?
Team number 40.
With their plane Quill. Quill is going to take to the skies here in a moment. Team's getting off the runway, ready to fly. Okay. We're waiting with anticipation here. There we go. The engine is on. Quill takes to the air. Okay.
I knew that was going to happen today.
All right, through turn 1 and turn 2. Plane looks pretty stable in flight.
No, actually, the camera's already off him anyhow.
Okay, going through the 360-degree turn on the back stretch of the track. Once again, we see another tail dragger design here. That's where you have the main gear up at the front under the wings, with the front wing, with the main wing in the front of the aircraft. Okay, going through turn 3 and turn 4 onto the front straight here. 1 lap completed. This is part of the Mission 1 criteria of the competition. Mission 1 entails teams doing 3 laps around our course to basically flight test their planes to make sure that they're good to do Mission 2 and Mission 3. Mission 3 entails loading ducks and pucks into the plane for cargo and passengers, and then Mission 3 is towing a banner around. We should see some of those missions today, but for now we're still doing Mission 1 here. Okay.
Lap 2, 48.
Judges announce lap 2 here. Mission 1, like I said, entails 3 laps, but you are also timed. You have a time criteria here. Timing is part of it. You have to do the 3 laps and land in 5 minutes. Okay, coming around turn 3 and turn 4. Lap 3 completed. Pilots circling around to try and come in and land. Okay, obviously want to land with a headwind, so they're turning into the headwind now. Wind's coming in the opposite direction of where it was coming in yesterday, so we're flying the course in reverse today on day 2.
Cool.
Coming down, nice approach. Little bit of a crosswind on the runway, little bit, but he's able to nail the landing. There we go. Great job. Very good, very good.
I'll get my steps in today.
With that tail dragger design, you have your stabilizers and control surface far away from your center of gravity. It makes for really stable flight. Now, once again, that was the University of Illinois Urbana-Champaign with Quill. Who do we got coming up next?
Up next is the University of Colorado Springs. That's team number 43, and they're flying their plane, the Duckinator.
Team number 43 University of Colorado, Colorado Springs, flying the Duckinator. I love these names. These names are great. And this plane's definitely a looker. It's beautiful. Beautiful. Yep. Especially the note on the tail. I love it. That's the truth is out there. Let's go. Okay. Teams are out on the runway positioning the plane. This is probably one of the more refined planes that we've seen. We got a front engine, tricycle landing gear, and they even had the time, UCCS had time to put windows on this plane for their duck passengers to get a window seat. I don't know about you guys, I like the window seat. That's really good. Okay. Yeah, there are no ducks inside on this flight. That's right. This is just mission 1, so there's no passengers on board. But if they complete this test, then we'll start loading up some ducks. Ducks will have a really nice window seat view. Okay, flight control surfaces are checked out here. Once again, that plane is a looker. It's really, really nice aircraft. Let's see how it performs. Let's see if it performs as good as it looks. Okay, pilots ready, standing by. The fuse is in for the plane. These planes, part of the rule criteria is that you need a blade fuse to be able to lock out the plane. The plane can only turn on the engine when the fuse is in. And the fuse is in, and there they go. UCCS takes to the skies. Team number 43 here. Okay. Showing a good signal from the judge down through turn 1 and turn 2. Circling around for the 360-degree turn here on the back stretch of the track. The plane's really, really nice. Looks really stable. Wind's still doing their thing though up there. It seems like the wind's a little more rowdy up there than it is down here. Coming down on the back side of the track, going through 3 and 4. All right. Now back through onto the main straight. Plane flying real nice and straight. Little bit of wind's blowing the plane around, but it looks pretty good. Okay, there we go. Back through turn 1 and into turn 2. Out of turn 2 looks really good, really good. Circling through the 360-degree turn on the back stretch of the track. Coming out of the roll down to turn 3. Into turn 3 and 4. Pretty smooth flying from what I see here. Pilot's doing a really good job. Looking real good, real good. Turning through 1 and 2. This is mission 1 for the University of Colorado, Colorado Springs, team number 43. They have to do 3 laps here as part of the mission 1 criteria, but you are timed with your laps as well, so you do need to get it done relatively quick here. It seem to be having no problems here from what I'm looking at. Wind seems to maybe take the plane a little bit in one direction, but other than that, looks real good. Okay, pilot's circling around for the landing. 3 laps completed. Once again, we have the winds coming in the opposite direction, so we're flying the track reverse to how we were flying yesterday. Wow. Coming in on approach. Let's see. Oh, look at that. Look at that. Beautiful. Wow. Straight pillows. Pillows. Grease the landing. Very nice. From the University of Colorado, Colorado Springs, team number 43. showing everybody how it's done there. Very, very good.
Next up.
Okay. Chris, who do we have up next?
Up next is Team 46 from the Indian Institute of Technology in Kharagpur, and that's in India, and they're flying their plane, the Push Puck.
The Push Puck. All right, so team number 46, Indian Institute of Technology. There we go. Waiting for them to get up onto the flight line here.
Next up.
It seems like the winds are picking up just a little bit here, Chris.
It's still chilly.
Yeah, yes, you are not wrong. You're not wrong. Okay, teams are over there in a staging area. That's what, if you see, it's like, What's going on is they have 4 staging pits over there, and the staging pits are where the teams are gonna get ready, and they basically do their pre-flight checks over there. We can only have one team going on the track at once for pretty obvious reasons. You don't need 2 planes hitting each other, right? Same reason as a real airport. You only really want 1 plane on the runway at a time, right? Here we go, rolling the plane out. Okay. Looks like they've opted for another tricycle design here with a forward wing though.
Base, you ready?
Okay. Okay, ground crew's getting ready. Okay. A little bit of communication from the judge there. Flight control surface checkout. Okay, inserting the fuse to prime the engine. There we go. We have alert siren from the airplane indicating that it is powered on and ready to go.
Okay, I'm just trying to get. I've already been here once, right? No, I have not. What's your team plane? Yeah. Okay.
Engine is going. Prop test is complete.
Cool. Thank you.
Control surface checkout.
You have to get back first.
And I think we're good to fly. Here we go. Plane's got a lot of power to weight. Zipping down the runway, heading towards turn 1. Okay, we got a good flag from the judge, turn 1. 3 laps is the goal here.
Right?
Circling around turn 1 from turn 2 into the 360-degree turn on the back stretch of the track.
Hey there. Good.
Everything looks good. Pretty straight design here.
They're not
Okay.
telling me to shut out. And they hear, and I'm over there. So
Have the flag turn 3 into turn 4. Uh-oh. Pilot turning around here. Oh, they're way out of the track here, trying to right the course.
I got wool socks on.
Okay. Back on track here, coming out of 4. They took turn 3 into turn 4 really wide. I'm not sure if that was wind. Okay, come through on the main straight. All right, passing through the sun here. There we go. Just as a reminder, we have, this is a mission 1 mission. There's 4 types of missions that are flying, well, in the competition. right? Mission 1 is just a test flight. It's just a test flight where they make sure that the plane can do mission 2 and mission 3. Now, mission 2 involves cargo, putting rubber ducks and hockey pucks as passengers and cargo onto your airplane, but you're not going to get to mission 2 unless you complete mission 1. And then mission 3 involves towing a banner around. Oh, geez. Little bit of wind took the plane there for a second. But pilot did recover. Everything looks real nice. The wind's starting to pick up. Definitely starting to pick up here. Seem to be dealing with it well though. Going into turn 1. Okay, they got a flag at turn 1. That's a good thing. That's not a bad thing. Okay, 360-degree turn. Negotiated real well, real well. Okay, coming around to 3 and 4. Now, once again, coming out of turn 3 into turn 4, that's where you got the headwind, because the wind's coming out of the north-ish today. So the plane appears to be going a little bit slower as it comes through the main straight. It's because the wind's trying to take it. Now they've crossed for their third lap. Pilot's going to circle around and try to land this plane. As you turn around, now they're heading south, right? You have a tailwind here. That tailwind's going to accelerate your ground speed. It's going to go a lot faster. So it's a little bit of a challenge when you negotiate in the course. It's not just, oh, hey, go up there, turn left, turn right, you're good to go. You have a little bit of wind, but wind happens. Pilot coming in for a landing. Touching 2 gears, nose gear down. Great landing. Very good. Very good.
Yep.
Now, Chris, which team was that again, just for the people at home?
That was Team 46 from the Indian Institute of Technology, Kharagpur, in India.
Cool. They did a great job.
They did a fantastic job.
That was really nice considering the wind.
Really nice.
Yeah. Beautiful, beautiful. All right, Chris, who do we have coming up next?
Next up is Team 47 from the Johns Hopkins University. They're flying their plane, the Peking J.
The Peking J. Okay. They should be rolling up in the staging pits behind us. Once again, behind Chris and I we have 4 staging pits, and that's where the teams basically get ready to go. We can only really have 1 team going at a time, but they are timed when they're doing mission 1 right now, so. Okay, so once again, this is the AIAA 2026 Design, Build, and Fly Competition. I am EJ, I'm doing the commentary here with my associate partner in crime here, Chris Horton.
Right.
There you go. Chris is actually going and getting the team names. He's talking to the teams, and he's coming back giving that information to me, and I am doing the flight line commentary for today. But here we go. We got Johns Hopkins rolling out here. Okay. They look to have a tail dragger design here. So the wings up front, engines up front. Tail dragger designs tend to be a little bit more stable. The reason why, you get a longer fuselage and your rear control surfaces and your rear stabilizers are further away from your center of gravity. That gives you a little bit more stability in flight, but once again, a little bit of trade-offs. With tail draggers, they're a little bit more tricky to take off the ground here. But that's not all that's just feeding into the design. Once again, the design requirements, you got to do the flight test. Plane obviously has to fly. If it doesn't fly, we're not getting anywhere, right? But you also have to consider cargo loading. You have to consider being able to tow a banner. These are all attributes that are at play when these student teams are considering building these planes. Okay, so once again, this is Team 47. This is Johns Hopkins University. All right. Ground crews putting the fuse in. Flight control surfaces are working. Okay, once again, that fuse is there to safe and arm the engine, their propulsion systems. The reason why they do that is a little bit of a safety concern. They don't, you don't want these engines going off when they're in the hangar or anything, right? So you have a detent in there. They have a blade fuse, just like you'd find on a car. All right, whoa, that plane really took to the skies. A little bit of pilot-induced oscillation there, PIO for short, but seems to be just getting the feel. Plane's flying real nice now. Going through turn 1 and turn 2, they got the okay from the judge that they made it through the gate. Doing the 360-degree turn. Now, I'm not sure if the wind took that plane, but Johns Hopkins is way up in the air. Okay, going through the 360-degree turn. Now, you got a tailwind going into 3, and then when they turn around, you're gonna get a headwind. So your ground speed is going to decrease going through the main straight today. Okay. Lap 1 is cleared. From turn 1 into turn 2, got it okay from the judge down there. Okay, 360-degree turn for the second lap. Looking real good. Okay, circling around. We got an okay from the judge, 3 and 4. All right, seem to have decreased the altitude a little bit closer to the ground now than they were through lap 1. But they got a good okay from the judge, turn 1 into turn 2. All right, looking real good, looking real good. Through the 360-degree turn. All right, got a good flag from the judge, 3 into 4, into that headwind again here. These planes are really gonna have to power through when we're going through the main straight. There we go. Looks real good though, real good. Oh, a little bit of windage taking the plane. But, that was 3 completed here. And now the pilot will circle around, get a good approach for landing. Oh, turning into that headwind it's proven to be a little tricky going through turn 3 and 4. Okay, pilot coming in on approach for landing here. So again, into that headwind makes pushing the throttle up and down a little bit tricky here, but a little bit of a bounce, but a very good landing. Very good. Very good. Ground team's going to get the plane. That was great. That was great. Chris, once again, that was
a team from
John Hopkins.
Yeah, Peking J.
Peking J.
47.
Number 47. Okay, who do we have coming up next?
Up next is Team 45.
45.
From the Case Western Reserve University. And they're flying their plane in bathtub.
The bathtub. All right. Okay.
Good job.
So as John Hopkins gets off the runway here, we got the next one coming up. So if you see us keep looking behind us, we have the staging pits there. That's where the teams get ready to fly. So we're looking back to see if they're ready to go. Looks like bathtub is coming up onto the runway. Okay. Teams are moving. So Case Western here's decided to go with a little bit of an interesting design here. They have 2 sets of main gear. They have, I don't know if we should call this like a tricycle plane, but it kind of is gear that's more or less reminiscent of like a B-52. You have 2 sets of mains. B-52s, the real plane, have 2 sets of gears in the front, 2 sets of gears in the back. That seems to be what they're going for here. But they have it more in a tricycle configuration. Now, once again, they also have a low wing, right? Fuse is in and ready to go. And yeah, a little bit of a unorthodox design here by like regular plane standards, but hey, if it does the job, it does the job. Let's see.
Double check. Like, are you flying for somebody else?
All right.
Full of interest.
Okay, the engine is on. And bathtub takes to the skies. We got it okay from the judge. Through turn 1 and turn 2. Now, once again, coming off of 2, you're gonna get, that's when you got the tailwind going into the 360-degree turn. That's when the ground speed of the plane's really gonna increase. So these planes, when they're on the main straight, they're going into a headwind, so the ground speed actually slows down because the wind is pushing over the wings at a higher relative speed, so you're gonna generate more lift. But when you turn around onto the main straight here, you got that headwind, right? The headwind is going to decrease your ground speed. You're going to generate more lift over the wings, excuse me, instead of backwards. But,
thank you.
Sorry, that beautiful plane flying through the sky is kind of distracting me. Okay, turning around through turn 1 and turn 2. Looking real good. See, now you have that tailwind. Your ground speed's going to increase. The wind is going to basically push the plane faster.
He hasn't come by yet, has he? No. What's your team number? Okay, and then does your plane have a name?
Okay, going through this 360-degree turn down
Hail Mary?
to turn 3 and 4. Got a good okays from the judge there that they've cleared the gate through 3 and 4.
50, right? No. 51, thanks. I'm just trying to get myself together.
All right. Plane's flying beautifully. They're going through the gate towards 1 and 2. Pilots circling around. Everything real professional from Case Western here. Real good. All right, doing the 360-degree turn. Everything's looking real good. Okay, clearing 3 and 4. Now back into that headwind. All right, they've completed their 3 laps. Now to bring the bathtub back in for a landing. Pilot is circling around for an approach. Okay, once again, this is team number 45. This is Case Western Reserve University flying their bathtub, circling around in for an approach here and landing. Let's see if the double main gear works for them here during the landing. All right, nice level approach. And a great touchdown. Greases the landing. Okay, that was Case Western Reserve University. All right, so as they vacate the runway, Chris, who do we have next?
Up next is Team 48. They're coming from the University of Texas at Austin, flying their plane Peacock.
UT Austin. All right, here we go. Team number 48. Waiting for them over there as they get out of the staging lanes.
Call the flags, count the laps.
All right.
Whatever the pilot needs or asks to do.
So, actually, the wind's kind of died down a little bit here for a second. Yeah, it went down for a second, but there still is probably it's somewhere between 10 and 15 knot wind coming. It's coming that way, going that way. So that's opposite to what we actually had yesterday. Yesterday the wind was blowing that way, and it was blowing that way pretty dang hard. All right, here we go. UT Austin coming up onto the runway for their attempt at mission number 1. All right. Good flying, guys. Let's go.
So you can put your stuff down on the ground.
Okay, so this is the Peacock from UT Austin here. They've opted for an overhead wing design, which does favor a little bit, makes the plane a little bit more stable, a little bit more easy to control with your center of lift, main center lift being over the center of gravity on the plane. And they've opted for tricycle landing gear, which means a little bit easier to land and rotate the plane for takeoffs and landings. And teams are getting ready to go. They're doing the flight surface checkout on the vehicle. Okay. Ground team's putting the fuse in to arm the engine. A lot of these teams, when they put the fuse in, they have a chime on their plane to indicate that the engine is powered. Once again, teams have to use a blade fuse to make sure that their engines are not running in any particular area except for the flight line here. Whenever the plane leaves the flight line or the staging lanes, you got to take that blade fuse out. That's actually part of the rules. Now, a blade fuse is just something that you'd find, it's basically an automotive fuse. It's the kind of fuse that you'd see in a car. But they do have the fuse in place. Doing another flight surface control checkout here from the airplane. Okay. Pilot's checking the skies, making sure he's got his bearings here. All right, here we go. Power up. Okay. UT Austin takes to the skies, going into the first turn here on the first lap. This is a mission 1 for them. So mission 1 is just a flight test. Make sure that the plane can fly the course. Make sure it can fly the course well. You can take off and land, all the control surfaces work. Going through the 360-degree turn here on the back straight of the track. All right, looking pretty clean. For mission 1, teams got to do 3 laps, but they have to do it in a certain amount of time. Coming through turn 3 and turn 4 into that headwind, this is really where you got to power up that plane. You got to go against the wind. Not sure if that's a pilot decision or the wind's moving that plane way up into the air through turn 1 and turn 2. Okay, 360-degree turn. Okay, turn 3 and turn 4. Once again, UT Austin has a lot of altitude here as they're coming through. Oh, judges are warning of an altitude limit. They got to bring that plane down. Okay.
Okay, I already
going
talked
through.
Right. Okay. I'm just
turn 1 and into turn 2.
Bounce
This is where you get a tailwind. Tailwind's going to push the plane. Ground speed's going to increase.
We can all start wearing numbers like on the back or something.
On the back section of the track here.
That's what I was kind of like.
360-degree turn. And then into the tailwind again, pushing the plane down to turn 3 and turn 4.
It is 40 A&M U.
Okay.
Then guys on the end.
Right-hand turn through 3
That's
and
why
4.
I gotta remember like what I'm doing.
Yeah, they're way, way up there. Okay. 3 laps completed. Pilot circling around.
Do you know if they have a plane name? That's what I figured. Okay, I'll catch up.
Coming in on an approach.
I got plenty of time. So.
All right. It's really where that tricycle gear is going to pay off. All right, great landing. UT Austin completes mission 1 there. Fantastic. Look, we even got a little bit of taxi coming back. That's great. Okay, so that was team number 48. That was University of Texas at Austin flying their Peacock. Chris, back with me. What do we got for the next team?
Up is Team 49, and it's another team from Texas. It's from Texas A&M University in College Station, and they're flying their plane Aggie Bullet.
Aggie Bullet from Texas A&M College Station. So it's one Texas team vacates, we got another one coming on. All right.
Go ahead.
Good flight from UT Austin there, really good, really good.
Go ahead, Dawson.
Texas A&M College Station coming up here. So just to remind everybody, they got the teams, there's 4 staging pits. The teams have 4 staging pits back there. And with those staging pits, they basically get the plane ready to fly here. We stage the teams because we can only really have one team going on the runway at a time. Here we go. Texas A&M College Station coming on. All right. Pilot and ground crews moving the plane out onto the runway for their mission 1 attempt. Okay, so they are using tricycle gear again too. They have an underwing design, and the wing's about mid-wing down the plane. Engines up at the front. Single engine design here. All right.
Done timing and everything? Oh, okay.
Ground crew's calling arm. Engine is armed. Once again, they have to use a blade fuse to make sure that the engine is armed only on the runway, and to do a flight checkout at the staging tents that are behind us. All right, we got movement from the prop.
I'll get on the radio.
Texas A&M College Station, taken to the skies. All right, going through turn 1 and turn 2. They got to complete 3 laps here. This is lap 1. On the back straight of the track, going into the loop. Not an actual loop, just a 360-degree turn. Okay, coming out of the turn, we got to clear from the judge through 3 and 4. All right, now once again, coming out of turn 4, you're going into a nasty headwind. But that doesn't seem to be a problem for them here. 1 lap completed, 2 more to go. Judges give the clear through turn 1 and 2. Turning around, now you got the tailwind. The tailwind's really where your ground speed for the plane's going to increase because the wind's blowing behind you. All right, going into the 360-degree turn here. Seems to be pretty smooth sailing, or should I say flying, I guess. Okay, clear through 3 and 4. Coming back down through the main straight here. Plane's flying real straight. Not a lot of, doesn't seem to be getting a lot of turbulence. Just nice, clean flight here. through turn 1 and turn 2. Now, once again, they're on lap 3 of 3 here. The wind has actually died down a little bit here. All right. Looking really clean flight here from what I'm seeing. Okay, clear through 3 into 4, turning around. All right, coming through the start-finish line. Seemed to be a pretty spotless flight here from Texas A&M College Station. Yeah, through, completed the 3 laps. Pilot is now going to circle around here, come in for the landing. All right, bringing it in. Okay, a little bit of wind, Oh, a little bit of a bounce. Oh, a little bit of wing contact there, but plane is down in one piece. Very good. Ground crews are moving to safe the plane, take the blade fuse out, shut the engines off. That was Texas A&M College Station. Looking to be a pretty spotless flight there from what I could see. That plane was flying perfectly straight. Really good, really good. So we have the staging lanes over here, but also there's an area that's just a little bit behind us over there where all the teams can actually watch. You can only have 3 people out on the runway and into the staging pit. But that doesn't mean that there's just 3 people on this team. These teams are, you could have, it's really anywhere between like 5 and 10 from what I've seen, right? But not the whole team can come actually out onto the runway. You can only get 3 people out there. So we have a spectator viewing area behind us that's actually, you may have seen it on the other cameras, that's actually where the teams can actually watch their planes fly. Now, we just had Texas A&M College Station head off. Who do we have next, Chris?
Up now is Team 50 coming from the University of Central Florida, and they're flying their plane Albee.
Albee. So we got UCF coming on here. Team number 50.
Hello, good morning.
All right. Now this plane is definitely a little bit, I'm not gonna say an unorthodox design, but that is a big fuselage. Now, they're probably carrying a bigger fuselage there because for the later missions, they want to be able to put more cargo in there, Chris, you think?
Well, possibly, but I think the largest cargo we've got is 151 ducks, and I'm not sure how many they're carrying. We'll find out in the next mission what they're up to.
Yep. All right. UCF's opted for a tricycle design, and they have an overhead wing. So we got something that's kind of similar to maybe a Cessna, I'd say. Like, you know, your engine's up at the front, you got tricycle landing gear, the wing's up above you. That makes for it's really stable that way when you're going through the air. But their fuselage does seem to be a little bit shorter, so I'm not sure if that overhead wing is really, you know, your control surface is very close to your center of gravity. If you like think about a Cessna, the tail is way into the back. I'm not sure if that's what I was asking about the fuselage. I'm not sure if that kind of condensed fuselage is really going to pay dividends here, but we'll see. Yeah, absolutely. Okay, ground crews putting the fuse in and arming the engines. Control surface checkout. All right. Okay, so once again, this is Team 50. This is the University of Central Florida, UCF, with their plane Albee. I'm gonna watch Albee spread its wings here in a second. There we go, the engine is on. Okay, Albee takes to the skies. So they have to complete 3 laps here. Okay, through the 360-degree turn. Okay. All right, turning through 3 and 4. We got a clear from the judge. Like I said, that stability's paying off for him.
Okay, so who's going after this guy's? This one or this one?
Okay,
That one's next.
1 lap completed from Team 50. This is University of Central Florida with their plane Albie, clearing through turn 1 and turn 2. Taking a little bit of a wide berth coming out of 2 there. Into the turn. So the criteria for completing mission 1 is to do 3 laps in 5 minutes. This is not necessarily like judging who can do it faster, who can do it slower. I mean, faster is obviously good, right? But this is more of a control checkout here and a flight test. So you're not necessarily judged with this, but
Yeah. That's why I'm trying to
you do have to complete it within the mission criteria. Then once again, you have to do 3 laps and you have to do them in 5 minutes. All right, Albie circling around here. Wind's picked up again. Okay, going through the turn there. 360 degrees around. Okay, coming through the turn, got a flag up, going through 3 and 4. All right. There you go. That was the 3rd lap. So the pilot's going to circle around for a landing. You obviously don't want to land with a tailwind. So I'm going to see a 180-degree turn here and then another one to get into that headwind. Makes it a little bit easier to land on the runway. Okay, coming in for a landing. We got a good approach, Oh, a little bit of a bounce, another bounce. Oh, little bit of nose into the ground. May have had some damage to the prop, but Albie looks to be pretty intact. Okay, and as they land, guys, we're gonna take a quick break from the commentary. Once again, that was Team 50, the University of Central Florida, flying their plane Albie. We will take a quick break from the commentary and we will be back in a moment. Once again, this is the 2026 AIAA Design, Build, and Fly competition. Talk to you soon.
Yeah, go get that.
We do need that, don't we?
Carl, what? Right here. What?
Okay. Beautiful landing there. We're back here momentarily here. Once again, that was Embry-Riddle Prescott there. Flying, they're playing Hail Mary. Seemed to be a pretty good flight going on there. Ground crews are going down the runway to go and get that plane. Okay. So Chris, what team number did we have there? That was 51.
51, and that was from Embry-Riddle Aeronautical University in Prescott with the Hail Mary.
Yep.
They're playing.
Cool. So who do we have coming up next?
Next is Team 53 from the National Cheng Kung University, and they're flying their plane NCKU Ironman.
NCKU Ironman. National Cheng Kung University. All right, here we go. Then there it is right there. Moving out to the pad. So we got, looks like you've got a twin vertical stabilizer there on that plane. Overhead wing, tricycle gear. All right, looking good. Embry-Riddle's bringing their plane back. That's Embry-Riddle Prescott. There actually is two Embry-Riddles here, I believe. I think we have Daytona and Prescott here, but that was the Prescott team. Now we have National Cheng Kung University here. Just waiting a moment here before the other crew gets off the runway. All right. Oh, wind's starting to take the plane. Oh no. The wind's picking up again. The wind's kind of off and on today. The wind gusts are definitely a thing. All right. Okay, putting the blade fuse in, arming the propulsion system. Thumbs up from the ground crew. All right. Okay. We are ready to go.
Does your plane have a name? Parent? Thank you.
All right. Team's just waiting to get ready. The plane is armed. There we go. Engine is on. Good rotation. They're up in the air. All right, flying down to turn 1. So once again, if you're just coming in, this is mission 1. Mission 1 flight is a test flight for your airplane. They're gonna fly around our track. And the track here that we have out in the runway is more or less an oval. You go down one end of the runway, about 500 feet, turn around, and then on the backstretch, you have to do a 360-degree turn. I would say a loop, but a loop, we're in 3 dimensions here. A loop would be going upside down. I mean, that might happen, but that's not ideal. That's not what we want here. So, and you come down on the back side of the track there, that's 3 and 4, and now you're back onto the main straight. Teams have to complete 3 laps in 5 minutes for mission 1. And mission 1 qualifies you to be able to do, well, mission 2 and mission 3. Mission 2 is moving around cargo in passengers in the form of the rubber ducks and hockey pucks. I'm hoping to see a mission 2 today. Hopefully. And then mission 3 is being able to drag a banner around. But mission 1 right now, we're not doing any of that right now. These are just mission 1 flights. Mission 1 is just a test flight of the airplane. See how she handles. All right. Cleared through 3 and 4. Now, the other thing to take into account today is that we have winds coming out of the north. So the plane is actually facing north right now. Our main straight is going from south to north. So you got a headwind, a little bit of a headwind going through onto the main straight, and then conversely, you have a tailwind going on the back stretch of the track. All right, turning around through turn 1 and turn 2. Now you got that tailwind again. The ground speed's really going to increase. Oh.
Go, Force? Go, okay.
All right, that was the roll for the backstretch. Not sure if the wind took the plane there. Cleared 3 and 4 from the judge. Plane seems to be performing pretty well. Pilots completed 3 laps, now circling around to land. All right. Heading alignment there to the runway, coming in on approach. Headwind's getting a little tricky there. But no sweat. No sweat. Great job. All right. Ground crew's going to safe the airplane. Chris, once again, who do you have just flying? That was National Cheng Kung University with their plane NCKU Ironman, making it look easy out here. Okay, who do we have coming up next?
So up next is Team 54. They're from the University of Massachusetts Amherst, and they're flying their plane, the Minute plane.
All right, Team 54, UMass Amherst. That's a local team for me.
Somebody has to get the score sheet, please.
UMass, right? Gotta make sure.
Good job.
Good luck, good flying, guys. All right, once again, we have UMass Amherst taken to the skies as National Cheng Kung University vacates the runway. If you see,
recognize you. Like some kind of
okay. So as UMass Amherst is getting ready to take to the skies, I'm actually going to go off commentary for a little bit, and we will bring you some interviews with Clay Morey from the hangar where the teams are actually getting ready to fly. We're going to do some interviews, but don't worry, we will still give you all the action here on the flight line, just with the interview in a double box. So once again, I'm EJ here. I'm down here commentating on the flight line. I will have no commentary during the interview because that would be weird. But this is the 2026 AIAA Design, Build, and Fly competition. We'll be going over to the hangar to get some interviews. Stay tuned.
Oh, they're switching.
We're here with the University of Southern California Trojans. Tell us who you are and what your plane is all about.
Thank you so much. My name is Brendan. I'm the pilot of this great team, and this is my team right here.
What's the name?
We got the Trojan Horse, actually.
The Trojan Horse, all right.
It's called that because the ducks are kind of disguised in the wing. It's a very creative payload system. Most teams have their ducks in the fuselage, but we open up the top of our wing skin, and it allows us to have about like 100 and something of these. I'm not gonna say the exact number, but
wow,
all that volume uses extra lift, which is a lot better than having the fuselage chunky and causing a lot of parasitic drag.
Wow, that's fantastic. So what was your biggest moment in terms of designing this? Was there like a moment of epiphany moment of trying to like put this design together, put all these ducks and pucks inside?
It was such an exciting moment. I think our performance, our analysis lead, L. Laverdiere, came up with this idea to put these ducks in the wing. And when we first heard that, we thought it was the craziest thing we'd ever heard. But when we did the math, it was just such a good idea.
Well, I love the Trojan Horse analogy. That's fantastic for the name. I don't know who came up with that, but it's pretty good.
Because you don't expect them in there.
No, you don't. You do not. They're kind of stealth in there. And the design, you got a lot of carbon wrap on here.
We do. That's all in-house layup.
Yeah, nice. And tell us a little bit about the prop and the motor. That's a pretty looks powerful.
Yeah, it's an agricultural drone motor. It's built by T-Motor, and it's very low kV. We use a high voltage battery on that, which gives us still a pretty low RPM, but it's very efficient with that large propeller.
And do you guys drive here? Do you fly here? How'd you get here?
Both, actually. Our team split in half and drove 24 hours from Los Angeles, and then half our team got to fly.
Oh,
They
fantastic.
gave me an airline ticket, which was nice
That's
of them.
right. And how are you enjoying it so far?
It's just been the most fun ever.
Yeah.
It's just such a joyful time to celebrate what everyone's been working on
Yeah.
for the past almost full year. And it's just such a privilege to get to compete and celebrate with all these teams.
That's amazing. How many people on the team?
Oh, we brought about 25 here.
Wow, 25. And I love the hat. Whose idea was the hats?
Oh, we
Look
went
at
to
these
Walmart.
great hats.
I'm not sure who invented that, but Walmart really provided.
Walmart provided. You got to have a good hat. Well, this looks like a lot of fun. I'm excited for you guys. So far, you're doing well. You feel like, is there a team to beat, by the way, or you feel like you're in the thick of it?
Well, we're here to beat our own expectations. We're here to try as best we can, and we're hoping to get a victory, but we're just here to enjoy ourselves and to really just pay our tribute to this great competition.
Fantastic. Well, that's University of Southern California with their Trojan horse. Thanks for talking to us.
Thank you so much for coming by.
All right.
That's a bummer. That plane flies so well. But they've got the wrong battery.
Get here back there. Make sure Chase gets a score sheet.
You get the score sheet. Me.
right, so back in the hangar, just talked to University of Southern California. Now we're here with the University of Illinois, the Flying Illini, I guess, yeah? All right, so introduce yourself, tell us a little bit about your plane.
All right, I'm Tyler. I'm the chief engineer of the aircraft. This is
Professor Jason Merritt. I'm the faculty advisor and pilot.
This is our aircraft, Quill. It's a single prop, very small fuselage. We're trying to carry min payload because our optimizer basically said it's a trade-off. You're either going to optimize for ground mission or you're going to optimize for mission 2. So we optimize for ground mission, and then we also tried to and minimize payload or minimize fuselage area so that we can try and minimize drag on the aircraft so that we can carry more drag with the banner, basically.
And this prop design and motor, where did this come from?
So we've been running hackers basically my whole life on the team, and we tried to we ran some propulsion sims, basically try and estimate what we needed to run the big banner that we're actually running. So we always run APC. We basically ran through different like 19, 20, 21, 22 different size props, different pitches, trying to see we're trying to optimize current capacity and then thrust basically for the banners.
Fantastic. What do you think of this team? I know you guys have competed many years here. How's this team stack up?
Since day one, they are doing well. They did all the work. You can see they can build really quick, which is better. This is our third prototype. Makes a huge difference. We need to get out there and fly and practice. And they've learned a lot in the practice. We've broken a few airplanes along the way, a few banners. But that's part of learning. That's why they're doing it.
Exactly. That's why we're here.
Design, build, crash is important, right?
Design, build, crash. All right.
It's critical to that learning, and it's in the safe environment for them to make the mistakes now in school.
Did you guys road trip to get down here?
Oh, yeah.
Yeah?
Good
And was that a good experience?
9-hour trip. I was one of the drivers. It was a fun trip.
That's nice.
I had radios going the whole time. It's this one.
If you were going to describe this competition in one word, what would it be?
Ooh. That's exciting.
Exciting. That's great.
Yeah.
Special.
Yes. Yeah. It's a great time of year. We're excited to have you. Thank you guys for talking to us. This plane looks fantastic, and best of luck.
Thank you very much.
I'm going back over there once I put the fuses in.
You can go ahead and turn on when you're ready. We'll have to wait till he's after whenever you're ready. It's all yours.
Ready to arm?
Waiting for Dust to tell me when he wants to do that.
You are live.
Okay, Chris, what team do we have up now?
We've got Team 56 from Worcester Polytech Institute. Worcester, sorry.
No,
Polytech Institute, flying Goat Force 1.
All right, Goat Force 1 is taken to the skies for WPI here. Circling around. Once again, this is another Mission 1 flight. I'm sorry, the name's getting me, Chris. Oh no!
Oh!
Saved! Yeah! All right! He fished it out. Goat Force 1's still going. He fished it out through the 360-degree turn, now down to turn 3 and 4. Okay, all right. Oh. Save number 2. All right, 1 lap down, 2 laps to go for Mission 1 here. They're turning around here. Come on. Here we go. Now WPI has a little bit of an interesting design here. They have a twin tail similar to like a P-38 or an OV-10 Bronco here. but they're using a tail dragger design with that. It's very, one of the more unorthodox designs we've seen, but it seems to be paying dividends for them. All right, circling around off 4 for lap 2 here. Going into lap 3 as they cross the start-finish line. Got a lot of altitude here, a lot of altitude. But they're making it work. Turning around, 1 into 2. Okay, now you got to do the 360-degree turn. All right, we do have a little bit of a wind. We do have a little bit of windage, but otherwise we have a perfectly blue sky out here today. But that wind is a little bit tricky to negotiate here. Once again, WPI coming through turn 3 and 4 here. All right, back onto the main straight. Okay. Oh, the wind's really blowing that thing around. Okay. Pilot's circling around for a landing here. Okay, on approach, the wind picked up. Okay. Here we go. And we got a good landing. All right. Goat Force 1 back down onto the ground for Worcester Polytech. The team's going crazy back there. It's really funny, actually. All right. As they pull Goat Force 1 off the runway. And we got cheers from the crowd. There we go. So once again, that was team 56, Chris, right?
Right.
All right, so Worcester Polytech. Who do we got coming up next?
Up next is Team 58 from Columbia University, flying their plane Mallard.
All right, 58, Columbia University flying the Mallard. Woo!
Good job.
As WPI vacates the runway. There we go. Okay, we got Columbia with the Mallard here. Okay, Columbia University is opting for a T-tail, but they have a T-tail with a tail dragger here.
Oh,
very, very interesting design decisions. I'm trying to make sure nobody trips on the cables. I'm like, ugh. But if you do see me looking behind me, what you see is that.
Do me a favor, just watch these cords. Watch these cords.
Okay, there we go. No one is tripped on the cables. That is good. Safety is key here, right? Safety is key. We're on the flight line, right? So if you see me looking behind me, that means we got 4 staging pits back there where the teams are basically load up the batteries and get ready to go. But they're only allowed to do a final pre-flight check when they're actually out on the runway because they have to put a blade fuse into the plane to get the motor running. You can only operate the engine when you're in the staging pit for a second and then fuse out and then fuse back in when you're on the runway. So once it... Okay, and as Columbia University takes to the skies here with Mallard, we're actually going to tee up another interview here momentarily. Once again, this is the AIAA 2026 Build, Design, Fly competition here. We will keep showing the flight line, but we will go back into the hangar with another interview. Stay tuned.
Back on the hangar floor, I'm Clay Morey, CEO of AIAA, and I'm here with a team from Argentina in their first time competing at DBF. Why don't you introduce yourself and tell us a little bit about your plane?
Yeah, well, hello, my name is Francisco. I'm in charge of the media part and the sponsorship of this project. And here we can see our project is named Condor. And well, it's a flying wing. And well, it's our first time in here for the ITBA, as the same as for Argentina. So we're really proud, and we're really looking forward for this competition.
Well, we're excited to have you. How long did it take you to get here from Buenos Aires?
Well, first, like 10 hours into Houston, then 5 hours, 6 hours of layover in Houston, and then 3 hours into here. So we flew a lot, around 11,000 kilometers more. So
was it hard to get with this wing design to get the aircraft here?
No, because we were, as I said, we were really looking forward for being here. So we designed the aircraft in particular to assemble the aircraft and that it fits in a 24 kilo baggage. So we only have to pay the oversize of the baggage and nothing else. So it was not a problem.
So your design philosophy was maximized for duck capacity, ducks and pucks.
Exactly.
So can we take a peek inside here?
Yeah, of course. Well, in here we could take up to 151 ducks and 4 pucks.
So you have like a honeycomb design.
Yeah.
With the duck can just nestle right in there.
The ducks have to be. We thought, well, if they're going to make 20 hours journey, they have to be in first class. They have to be well comfortable seated, and
I love it.
And everything.
I love it. That's fantastic. Whose idea was it to come up with this flying wing design?
The idea was made by one of the head of the aerodynamics, which is not here. That is Matias Felicia. Which made a great job with the aerodynamics team, but I think that this project was a great opportunity to show how the mechanical. We are all mechanical engineers. All the engineers of the group, the 13 people, made a great job in this 6 months project. So we are very proud of all of them and all the ones that are in here.
Well, we're proud to have you here. If you were going to sum up this experience in one word, what would it be?
Unexpected.
Unexpected.
Yeah, because we, again, our first time, we really do not know what we will encounter, the teams, everything. So we're really excited. We're really proud, and we are very grateful with you and with all the teams, the other organization, because we're not expecting this.
We're excited to have you guys here. Do you know that your plane has a nickname now? Have you heard this on the floor of the hangar? What people are calling it?
No.
Do you want to know?
Yeah.
They're calling it the Flying Dorito.
Okay.
Because it's in the shape of a Dorito.
Yeah. Thank you.
That's awesome. Well, thank you guys for coming, for making the journey all the way from Buenos Aires. We're excited to have you here. Thank you for being part of AIAA.
Thank you, guys.
Okay. Welcome back, everybody, out to the flight line here. We have another team ready to go. Actually, well, not ready to go. They're already flying. Okay. They've completed their first lap. Going into the second lap now. This is the University of South Alabama here, going through the 360-degree turn. Wind seems to be staying steady here, but the wind's going in the opposite direction as it was going yesterday. It's 180 degrees in a different direction. Winds was coming from the south before. Now it's coming from the north. So we're flying the course in reverse today, as opposed to what we saw from the Mission 1 flights yesterday.
I'm going to go SLDPK.
Now, where I last left off here, guys, we had Columbia University out there with the Mallard, but they seem to have had some problems with their plane. So the next university is up. We got University of South Alabama here, doing their Mission 1 flight. For the people that don't know, the Mission 1 flight is a flight where you just basically test fly the plane. You have to make the plane fly around our imaginary short track here, which is more or less an oval with a loop. An oval with a loop on the back stretch of the track. Now, not a loop like going upside down, just a 360-degree turn. There's a loop if you were looking at it from the top down here. But actually seems to be a pretty good flight here from University of South Alabama.
I'm looking for my backpack, but
turning the plane around, coming in for a landing.
Thank you.
Okay.
Oh.
Over wing design with tricycle gear. Oh, she's shimmying a little bit. That wind's trying to take it, but
anything will work.
But we have a good landing from University of South Alabama. That's fantastic.
Yes.
Ground crews going to safe the plane. Okay.
She's welded in there.
All right. Who do we have staged up next, Chris?
Up next is Team 60, and they're coming from the Hong Kong Polytech University, and they're flying their plane, the SLDPK.
Okay, that is the name of all time. Hong Kong Polytechnic University, team number 60. As South Alabama, University of South Alabama takes their plane off of the runway. Here we go, Hong Kong Poly. So they have an underwing design from what I can see here. You'll see it in a moment. Underwing design with tricycle gear.
Yeah, let me know.
All right. Sorry. One of the teams just walked by with the plane. I got a good look at it. I was like, huh? You know, me and myself, a little bit of a plane nut too. So I never see it. I don't know if anybody else out there watching. You guys let me know in the chats here. You know, you see a plane flying by, you're like, huh? Yeah. Wait, where's that? So apologies about that. One of the planes went by, and I'm like, It's good to know that that happens with RC planes too, I guess, right? Okay. Judge is now briefing the team from Hong Kong Polytechnic here. Once again, it's important to understand that when I say Hong Kong Polytechnic, I mean Hong Kong, like on the other side of the world, Hong Kong. This is an international competition. We have teams from 15 countries here. 89 teams reporting in throughout the weekend. So this is a truly international. Truly international competition, but as Hong Kong Polytechnic takes to the skies, I'm actually going to turn you guys right back into the hangar here. Let's see. We got more interviews coming from the students that are getting ready to go through the flights in the hangar. So once again, this is the 2026 AIAA Design Build Fly competition. We will double box it, so you will have a shot of the flights and a shot of the interviews. So we'll be right back. Going into the hangar.
Mine's cutting it out too. Yeah. It's a Starlink handover.
This is Clay Morey, CEO of AIAA. I'm back on the hangar floor here with a team that came from a long ways away. It's their second time competing, but you guys came all the way from Bangladesh.
Yes, we did.
Why don't you introduce yourself and tell us a little bit about your airplane?
I'm Tasdeed. I'm from the AIAA DBF team, and I'm the chief engineer. And we have our team lead back in our country, so huge shout out to him. He sacrificed all the time, all the effort for this team to come here. We couldn't bring him here, so shout out to him. Secondly, this is our professor. He's our faculty advisor and chief, and he helped us a lot throughout all the budgets, all the logistics, and all the admins. And for the plane.
So what's the name of the plane?
The name of the plane is Phoenix.
Phoenix.
Yeah.
Okay. And what's the philosophy behind this airplane?
Yeah. So the philosophy behind this airplane is we try to make it small because we're coming from Bangladesh, where we're traveling a lot, and there's war zone in the Middle East, so we didn't want to give the plane in the cargo because we might lost it, right?
Yeah.
Yeah. So we brought it in our luggages, in teeny tiny luggage. So this is a fully modular design. You can swap the wings, you can remove everything, divide the empennage and the fuselage. This will fit inside a suitcase then.
So how many ducks and pucks can you carry inside?
Okay,
here?
so we focused on third mission and the ground mission. So we're not carrying much of ducks. So you can see here, we're only carrying 4 ducks here and 1 puck, and that's all.
Duck for scale.
Yep.
There you go. All right.
And it's a pretty comfortable seat for them.
Yeah, very
also,
comfortable, padded.
Yeah.
It's first class. Yeah. How long did it take you to get here from Bangladesh?
That's a long story. It took more than 50 hours here.
50 hours.
And
to
we
get
took
here.
16 hours transit in Qatar.
Wow. So you had to avoid some airspace.
There was some unusual airspace here.
A lot of conflict.
Yeah.
How many people here are on this team?
11.
11 team.
Yes.
Yeah, please go ahead, Professor.
Okay. So I want to especially thank AIAA. The concept of towing a banner, we have used it for inviting or basically welcoming the newcomer freshers. So in the last week of March, our new batch of students joined the university, and we had a long banner of 15 feet with this UAV saying "Welcome class of 2026."
That's fantastic.
So
I love it.
You get it also. Okay, we actually took your idea.
Yeah.
The second thing, we are also thinking to use this idea to use this aircraft with this banner mission with small messages in our Bay Area, where people come for tourism, and they can actually say they are welcome some message to somebody, or produce message, or they love someone, they want to express this thing. So we have in our mind also to make it sustainable business project also after this.
That's fantastic.
Okay.
That's fantastic.
And I also thank AIAA and DBF, everybody. Last year was the first time that actually I brought this group of people, and from there actually we have started making our own UAV lab in the university, and then this is the second one, and we have got a national project also awarded, and it's a pretty well. It's a $500,000 in Bangladesh perspective.
Wow.
It's very good. And these boys and girls are actually working with me for doing that thing, and we are making the first one. It is a 20-feet UAV. Hopefully it will come up in next 3 months.
That's amazing. Are you guys having a good time here in Wichita?
Yes.
Yeah. If you were to use one word, what's one word that you would use to describe the event, DBF? What do you think? Put the mic up close.
So this DBF event inspired me to how to build a UAV. Actually, I am a newcomer here, and I get the chance of my passionate work here. So that's it.
Thank you, Isabel. That was fantastic. Well, this team, I got to give these guys credit for coming all the way from Bangladesh to compete here. What a great looking airplane, and I wish you all the best in this competition.
Thank you very much.
Thank you.
Okay, we're back live down here on the flight line here at the 2026 AIAA Design, Build, and Fly competition. Once again, I'm your commentator down here on the flight line. I'm EJ, and we have the next team up. The team where I last left you guys off, we had Hong Kong Polytechnic do their flight. Flight seemed to go off without a hitch. Now we have San Diego State University out here, ready to go. But there seems to be some communication issues going on here. But Okay, they're getting another one of their teammates out there. You need 3 people
with the pilots.
to battle on the flight line. Now, these planes don't have guns or anything, just to be sure. But you got to have three of the team members out there. You got to have a ground crew, you got to have a pilot, and you got to have somebody that's behind the judge's table here. All right, San Diego State looking to arm the plane. We have a tone from the plane indicating that the propulsion system is ready to go. Now, once again, if just anybody that might get confused, like, wait, what do you mean arm the plane? Well, the planes have a D10 on them. You need to use a blade fuse to be able to make sure that the plane engine doesn't go anywhere but out here on the runway. So one of the last things they do while they're doing their pre-flight checks out on the runway is make sure that that blade is in and that the engine is ready to go. Now they're taking to the skies. They're going through turn 1 and turn 2. Doing the 360-degree turn here. San Diego State's opted for a tail dragger design, but they have a really, really, really long tail that should make for really, really stable flight. This plane should cut through the air real nice. Coming through turn 3 and 4, it got a lot of altitude there, a lot of altitude. Once again, they have to complete 3 laps for the mission.
I don't need that. I'm not
criteria fulfillment. But the flip side of that is you got to do 3 laps. You got to do it in 5 minutes.
Okay. Good luck with everything.
All right, going through 360-degree turn on the back of the track. Okay, see how straight that plane flies? That's because of that long tail. Really good design decision from that team there. We'll see if it'll pay off for the next missions, because once you complete mission 1, you need to go on to mission 2. Mission 2 is loading cargo and passengers in the form of rubber ducks and hockey pucks. And then mission 3 is towing a banner around. So the design might prove for nice stable flight, but let's see, we won't know until they go again for mission 2 that if it provides additional stability with cargo or the banner. I'm inclined to say yes, but we'll see how that transpires. Going through the loop there, down into turn 3. Got an okay clear from the judge that they've gone through the gate. There we go. Beautiful. All right, completed 3 laps. Pilots circling around, coming in for a landing.
Some of these will keep coming more further. This guy right here on the end, especially. Here he goes.
Good approach. Oh. Bringing it down. Oh, nice landing. Very good landing there. That was fantastic. That was, it was a little far down the runway, but that landing was greased. Like landing on some pillows. Very nice. Ground crews are, but now you gotta run all the way down there and go and get the plane. The San Diego team enthusiastically cheering on the ground crews to run down to the plane. Good stuff.
Sorry, man.
All right. So that was San Diego State University. Chris is back with me. Who do we got next?
Up next is Team 62, coming from West Virginia University, flying their plane, the Golden Goose.
Golden Goose, coming to the runway.
There you go. Should have everything you need on it.
From West Virginia University. Once again, that's San Diego State University there with Hutzkelin. Guys, if you're watching, San Diego guys, if you're watching it, I'm sorry, I don't know how to pronounce that. Hutzkelin, you got it? There we go.
I had to ask like 3 or 4 times.
Hey, it's a creative name.
It's an Indian name, is what he was telling me.
Really? All right. Excellent. Good stuff. And now we have next team coming up here. Once again, that is Team 62, West Virginia University with the Golden Goose. Ground crews moving the plane into position for takeoff. Go that way a little bit.
Frame.
Yeah. No, they want you in the frame. They want you right here.
Okay.
Okay. So once again, Chris, what team do we have here? Just for clarity here, we have West Virginia University with the Golden Goose. That's team 62. Cool. Chris, how many flights do you think we've gotten throughout the week? Or weekend, I should say.
I think we're up to about 30, 32 right now so far. We had about 20 yesterday, and so we've got a good probably 20 that have come up this morning.
All right, we're making good progress here. Okay, 34 successful flights. Not bad, not bad. All right, here we go. Golden Goose. Team number 62, West Virginia University. Okay. Cleared the first gate, through turn 1 and turn 2. Gaining a lot of altitude there. Now you got to go through the loop here. Loop around on the back side of the track. Actually looking real stable in flight. Coming through 3 and 4. Real good. Got to do 3 laps. This is a mission 1 flight, test flight of the vehicle. Okay, circling around. On to lap 2 here.
Make any assumptions, but I'm going to get
going through the loop again.
Project comeback.
Once again, the loop actually isn't a loop. It's just a 360-degree turn.
It could be.
We have more or less an oval track,
Get it wrong.
but you have
Suave.
you have a little bit of a you have a 360-degree turnaround on the back stretch of the track. Now, once again, the winds are coming out of the north today. That means when you get onto if you're on the main straight like right now, you're gonna have a little bit of a headwind. Now that will kind of favor stability here. But that means on the back stretch of the track, the planes do get a little bit unstable because the wind is at the tail. But the Golden Goose doesn't seem to be having any problems with that. You know, more or less just a little bit of a ground speed increase, a little bit of a tailwind going through there. But looking real sharp, real sharp. All right, plane's cutting through the skies. Looking real good. That was 3 laps down. Pilot is circling around for an approach. Looks real good. Okay, turning in. Once again, turning into that headwind. Much easier to land when the wind is at the front of from the front of the plane going back. Oh. Okay. There we go. All right, good landing. Good landing. We got a good landing there. Very nice. Once again, that was West Virginia University, team number 62 with the Golden Goose, making it look easy. Now, as they get off the runway here, who do we have next, Chris?
Up next is Team 63 from Missouri University of Science and Technology, flying their plane Pelican.
Okay, Pelican from Missouri University of Science and Technology, team number 63, getting ready to go. All right, so once again, you see us looking. Okay, we got the next team up. Now, look at this. This is a little bit of a different design. It looks like we got a contra-rotating propeller up there. It's where you have two props actually right behind each other up at the front of the plane, if I'm looking at that right. And once again, we got a contra-rotate, a flight control surface check out there. And we have a lot of control surface authority on the rudder, but you see the two propellers spinning back to front. That's cool. Listen to the noise. Oh man, that plane is making the weirdest noise ever, but that's what contra-rotating propellers do. You have one propeller spinning clockwise and then another one spinning counterclockwise behind it. The idea there is, I mean, it's a little technical, but for the most part, the front propeller feeds the rear propeller. And that can give you a lot of thrust, but you gotta make sure you have the power to be able to turn both of those props. But it does give you a little bit of an unorthodox sound. There we go, through turn 3 and turn 4. I love the noise. Not sure if that's coming through on the stream, but that is certainly a noise. Yeah, the contra-rotating propellers definitely, because you have one blade spinning right in front of the other and they're spinning in opposite directions, they do tend to be a little bit louder, but they do make a sound that generally you don't see. I mean, most planes are not using contra-rotators. My mind is immediately going to like prototype designs from the US from the Cold War era, like the XF-84 Thunder Screech, which is basically where the Air Force figured out that you have a jet engine turning contra-rotating blades. If the blades go past the speed of sound when they're spinning, it makes a really, really strange noise. Now, once again, that's not what we see here, but it definitely is making a noise that's a little bit different than the other planes. But the plane seems to be flying real well. Pilot's doing a great job. Once again, this is a Mission 1 flight, where it's basically just to test the vehicle, running it through the track that we have here out on the runway. All right. Okay, they completed their third lap. Bring the plane around in for a landing here. Pilot pulling back the throttle, and of course we can hear it. It's very audible here. Oh, nice landing. Very, very good. Very good. Pilot taxiing the plane around. Once again, see the two propellers moving against each other. That's really cool. That's a really cool design. All right, blade fuse is out. Plane is safe. So I got Chris back over here with me. Chris, which team was that again?
That was Team 63 from Missouri University of Science and Technology.
They're flying the Pelican. All right. Great job, great job. Who do we have up next in the staging
lane? Team 65 from James Madison University in Virginia, JMU, and they're flying their plane, the Duke Duggernaut.
The Duke. These plane names are fantastic. All right, so that's James Madison University coming up. Here they go. Good luck today, guys.
Thank you. Yeah, that works. Tell her I said thank you very much.
All right.
Welcome.
Shit. Actually, Jerry, you're just
what?
You can tell her take the surprise.
What did we forget? Score sheet? Details. Yeah. I'm like, score sheet? And it's like, oh, shoot. Yeah.
You want the same thing you had? DJ said yes.
Were you ground crew?
Okay, so we got James Madison University here. Ground crews have put the fuse in. The engine is armed and doing a control surface checkout. Ground crew vacating the runway here. Okay. Oh, there we go. Plane leaned a little bit, but it did get up in the air. There we go, down to the first turn. Turn 1 into turn 2, turning around. Looking real stable, gaining a lot of altitude there. Doing the 360-degree loop. Everything's looking good. They're cleared through turn 3 into turn 4. Once again, JMU got a lot of altitude there, way up in the air. Plane seems to be flying real nice though. I'd say with the wind's dying down a little bit, we really can see the planes flying a little bit straighter today. Yesterday they were all over the place, but I mean, we still do have some windage here, but not nearly as bad. Okay, going through the loop, looking real good. This is lap 2 of 3 laps here. Okay, coming back through the main straight. Everything's looking good. Okay, moving into the final lap through turn 1 and turn 2. Everything looks real good here. Once again, they got a lot of altitude. That plane's way up in the air. I'm not sure if that's choice or if the wind's just putting it up there. Okay, turn 3 into turn 4, coming around to complete the 3rd lap. You know, I'm out here doing the commentary. You know, I suppose for the vast majority of these flights, I really have nothing to talk about except planes flying straight, planes doing the track really well, and I suppose that's good. I think that's a testament to the caliber of students that we have here from all over the world. They're making some really nice plane designs, and that's cool. That's cool to see. Cool to see people getting into it, having a good time with it, and competing in this great competition here. Okay, touching the plane down, watery landing. Woo, that was nice. Again, James Madison University there, making it look easy. Now the taxiing, oh look, we got some taxiing here. It's very fancy. Taxiing the plane back so the ground crews don't have to run out and grab the plane. Okay. Judges indicated them to stop. Ground crew's gonna go get it.
The first lap was scared.
Okay, ground crew's out there, pulling the switch. Propulsion is offline.
Back to position 2.
Okay, next team moving out. Okay, so one team moving out, we got the next team moving on here, getting ready to get their plane ready to go. Once again, the team that just flew is James Madison University. They made it look easy. They made it look easy here. All right. So once again, this is the 2026 AIAA Design Build Fly competition. I am EJ, Flightline commentator here, providing hopefully insightful commentary as to what's going on, but I'll tell you, it's been pretty uneventful thus far. And I'm not trying to jinx anything. I'm not trying to jinx nothing, but I think it's a testament to the talent of these teams. Now, hey, Chris is back with us. We have Chris. No, it's no problem.
So we've got team number 66 from the University of Sydney. in Australia, and they're flying their plane Project Humpback.
Project Humpback. So what Chris is doing here is he's going and talking to the teams in the staging lanes that are behind us, and he's getting me the information for the team so we can announce it, so we know who's coming up next. This is good. We got Project Humpback. Once again, what's the name of the
University of Sydney in Australia.
University of Sydney in Australia. Showing us international competition. That's pretty cool. All right. Ground crews are away from the plane. Plane propulsion is in. The blade fuse is in and ready to go. Project Humpback's ready to take to the skies. Yeah, this is a Mission 1 flight. They need to do 3 laps around our track. Okay, propellers on, here we go. Nice. Thing went right up in the air. Now, Project Humpback here, the University of Sydney is using, like, once again, another tail dragging design here, where the tail is actually on its own little mini gear at the back. Main gear is underneath the main wings, with propulsion up at the front of the airframe. Coming through the 360-degree turn. Everything's looking good there. Okay, they got a flag 3 and 4. Once again, a lot of altitude here. A lot of altitude. I'm going to go ahead and guess that that's probably the wind doing that. We do have a little bit of a headwind, so the way the plane's flying right now is that it's flying north. The winds are coming from that direction. So that means when you get onto the main straight of our track here, you got a little bit of a headwind. You got to have to increase power, right? Because your ground speed is going to be decreased. You turn these planes into the wind. Ground speed's going to go down. You're going to need it unless you have more power. And then conversely, when we're flying right here, you have a tailwind. Ground speed's going to speed up. The speed of the aircraft relative to the ground. But that doesn't seem to be a problem here for Project Humpback from University of Sydney. They seem to be doing a pretty good job here. That plane is flying dead straight. All right. Coming through off of turn 1 and 2 into the loop. Once again, a loop's not actually flying upside down. It's just a 360-degree turn. Okay, judge calling flag cleared through 3 and 4. Out of turn 4, once again, back into that headwind. Oh, is this showing off? Showing off a couple of aileron rolls there. The pilot's now going to circle around and come in for a landing. All right, Project Humpback, doing ahead in alignment. Pilot lining up with the runway, bringing it in. Oh, look at that. Look at that, making it look easy. Oh, stopping right where the plane took off from. Very, very good. Ground crew's moving out, pulling the fuse, deactivating the engine. They're going to be pretty happy with that one. I'd expect that was really good from University of Sydney. Project Humpback there. Okay, Chris, you're back with me. All right, so who do we have next up?
Up next, we've got Team 68 coming from Rutgers in New Jersey, and they're flying their plane, the Dragonfly.
Okay. University of Sydney off the runway. Rutgers coming up next. Okay, so sorry. Like when they bring the camera back over to me, I'm looking at the planes. I would expect everybody here that's watching this, if you're outside, you see a plane flying over, you go, huh? I know I do that, but yeah, University of Sydney is coming up. We got Rutgers coming up next. Now, if you see us kind of looking over there, obviously we're looking at the planes, like I said, but Chris, that's where we have our 4 staging pits, right? Like that's where the teams are getting ready, and that's you go over there and talk to them,
I go over there and talk to them, get their plane name, and just talk to them and wish them good luck. And fill up a little time.
There you go. Excellent. Oh, well, look at this. Look at this. Rutgers has a biplane. They got a biplane with tricycle gear. That's cool. Look at this. So biplane, you have two main wings. You have one over the other. Design that was really, really popular at the dawn of aviation. Now it still is. There's still biplanes that are around. But it's very, very cool design here. Okay. So we do have tricycle landing gear too, which means your main gear are underneath the biplane wings here, and then you have a gear up at the front underneath the engine of the front of the vehicle. They're moving up to the runway now. Uh-oh. I'm not sure if they're having a little bit of trouble with the front gear.
It's pretty big.
That front wheel doesn't seem to be cooperating with them. Yeah.
That'll be a problem when you land.
Yeah. Yeah. Let's hope. And they're pulling that plane around on two gears, or on the main gear only, not with the front gear. Now, let's just for the people at home, you need the front gear to steer. The front gear is the one that turns you. So let's see if that could be a burden or not here. Rutgers getting the plane ready to go on the start-finish line.
Okay, pilot? Yep. Who's the observer? Who's the observer and your ground crew? So we just need you behind the saber. Thank you.
Okay.
Okay. RX switch. RX. Yep.
Blade fuse is in.
Is that good control surfaces?
Flight control surface checkout. Looks good. Ground crew's reporting. Arming the vehicle. Now, once again, there's no weapon systems on these. These are just RC planes. When they say they're arming it, they mean they're turning the engine on. They're using a fuse to make sure that the engine doesn't inadvertently turn on in a place where you don't want it. The only place where we really want engines going here are on the staging area and on the runway. Oh no, that front gear. Oh no. Yeah. Oh. Judge is telling him to pull the fuse. Oh no, not what you want to see from Rutgers here. That's not great. Fuse is pulled, plane's off. It looks like they had their front gear fall off. Like I said, they seem to be having trouble with it. Oh no. Not what you want to see, but with the exception of that nose gear, that plane is in one piece. They'll be back.
Grab the score sheet when Eddie's done. Guys back out here.
They'll be back.
Try to get the visual on. All right, bring the aircraft back to the van.
Okay, so we just had Rutgers go, but they had a little bit of trouble with their front gear.
Thank you.
And as they come off the runway, we got to keep the system rolling here. We got the next team coming out. Ooh. Yeah, once again, when we saw them pulling that thing out to the runway, I noticed the front gear was a little wishy-washy. I mean, I don't think I could say anything as the commentator, but okay, Chris is coming back telling us who is ready for the next flight. Who do we got?
So up next is Team 73. They're coming from the University of North Carolina at Charlotte, and they're flying their plane, the Nemesis.
The Nemesis.
Score sheet.
UNC.
Do you have the score sheet?
There we go. All right, UNC Charlotte coming up here, putting their plane out onto the runway, getting ready to go. Okay, so UNC Charlotte is opting for a tricycle design as well, but they have kind of a shorter fuselage. That shorter fuselage should make the plane a little bit more nimble. You should be able to fly around and be a lot more maneuverable, but that shortened fuselage is going to mean that the plane's going to have it's not going to be the best stability cutting through the sky here. You know, longer fuselage, having your horizontal stabilizers and your vertical stabilizer further away from the plane center of gravity is going to make the plane fly straighter through the air or be more stable. You know, if you have a smaller, nimble design like this, just shorter fuselage, that means you're going to be a little bit, the plane will be very maneuverable, but it won't be as stable going, okay, a little bit of wing scrapes, little buff out. There you go, UNC Charlotte up in the air. A little bit of a rough takeoff, but they got it, they'll manage. Okay, going through turn 1 and turn 2. Yeah, there we go. Plane looking really good through the loop, actually. Not bad, not bad. Oh, wind's definitely blowing that plane around. Okay, 3 and 4, looking good, looking good. Actually looking real nice. Like I said, plane very, very maneuverable. Very nimble, should be able to do pretty sharp turns, but it looks like the pilot's not opting for that there. Just keeping it nice and smooth, smooth as you can. Okay, through the loop there. All right. Through 3 and 4. Once again, UNC Charlotte here. Once again, this is their Mission 1 flight here, which means they're just doing a test flight of their plane. The test flight regime for the planes are 3 laps that goes around the course here that we have out on the runway. The track, for the most part, is basically just an oval, and on the back stretch of our oval, there's that 360-degree turn that I'm calling the loop here. All right, there you go, through the loop, looking good. Now the team's got to do, for Mission 1, you got to do 3 laps, but you are timed. You have to do 3 laps in 5 minutes. So it's, you know, you have to negotiate the course on a somewhat timely schedule. All right. Looking good, looking good. UNC Charlotte's done their 3 laps. Okay, circling around. Pilot's doing a head in alignment with the runway. Over the runway, there we go. Nice touchdown. Beautiful. The rest of the team from the spectator area, very happy with that flight. Look at them taxiing back over. They must be very happy with that. Very happy. Plane's rolling out.
Good to go.
I didn't want to exceed the critical.
Great flight there. Team's removing the fuse, safing the aircraft. Yep, tri-propeller design from UNC Charlotte there. Yep. We've seen tri-propeller designs here, but the vast majority of the planes that I'm seeing are just 2-prop design. Great flight, dude.
Thank you.
That was real good.
Appreciate it. Thank you.
Yep. And actually, you know, I might be dreaming here, but I'm pretty sure that plane is 3D printed. It looked like the vast majority of those control surfaces. I only got to look at it up close for a second, but I think UNC Charlotte 3D printed their airplane. And you know what? That's pretty cool. We like that. So as they vacate, Chris, you're back.
I'm back.
Who do we got?
We've got Team 71 from the University of Nebraska Lincoln. I'm having problems this morning.
It's all good.
They're flying their plane Quack.
Quack. All right, Team 71. University of Nebraska Lincoln with Quack.
I'm back.
Okay, ground crew's going to put the aircraft out onto the runway.
That would be nice.
Now, Quack has a little bit of an interesting vertical stabilizer and rudder. It's actually in front of the horizontal stabilizers there. Now, the design decision there, if I'm looking at this right and understanding that right, is that you're going to have more control with the plane for pitch, with your horizontal stabilizers being that far away from the center of gravity of the airplane.
So you're going to stay behind the white table?
Okay, judge is giving instructions there. Now the rudder is a little bit closer to the center of gravity, which would make the plane more susceptible to side slip. Now, I don't think that's going to happen here. They do have a pretty long fuselage, but they are opting for a tricycle landing gear, which means the center of gravity of this vehicle is underneath those main wings. All right, plane's arm, flight control surfaces are good. And just like some other teams, we do have chimes from the vehicle indicating that it is ready to go. Okay, engine is on. There we go. Great control on the pitch there. Great takeoff. Going down to the first turn. Turning around through turn 1 and turn 2. Looking real stable. Like I said, that long fuselage favoring this design. So I did say a little bit before that the plane's more susceptible to side slip. Side slip is, for the most part, if you kind of draw a line down the long axis of the vehicle, right? If your rudder's closer to your center of gravity, the plane is going to slew a little bit left to right because the rudder is closer. But the longer fuselage can help you with that. But remember, the vertical stabilizers is there to make sure that the plane doesn't slip. You don't want it to drift through the air. But they don't seem to be having too much of a problem with that. Now, once again, they're on lap 2, doing the 360-degree loop. Okay. Through 3 and 4. Yeah, everything looks pretty good here. Must be pretty happy with this. Through 1 and 2 again. Once again, they got to complete 3 laps. This is another Mission 1 flight. Mission 1 is test flight for the vehicle. Flying our track here. The track, if you're wondering, is for the most part just an oval. You go down to turn 1 and 2, turn around. On the backstretch, you got to do a 360-degree turn, and then you go down into 3 and 4, which is what you're seeing right now. Now, we do have winds coming out of the north today, so you do get a little bit of a headwind on the front stretch of our oval here, and then tailwind on the back. Okay, they've completed 3 laps there. Pilots circling around, coming in for a landing. Okay, land on the runway. Okay, bringing it in. Nice landing, nice rotation. Team's back in the spectator area. Very, very happy with that. Now, what we're gonna do is, while the next team is flying, we're gonna do more interviews back up in the hangar there. So, we will double box it here. We will give you more flight line views, but we do have interviews going in the hangar here. So once again, this is the 2026 AIAA Build, Design, Fly competition. I'm EJ with Chris Horton here. We're gonna send it up into the hangar to get another interview.
We're good? We're all good.
Hey everyone, we are back at the hangar and I am with James Madison University. They just finished Mission 1, so we're gonna hear from the pilot. What did you think? How did it go?
The first lap and the takeoff were a little nerve-wracking to where it's a little jerky, but after I got the initial loop and then started coming back around, it started feeling a lot better, and the flight went a lot smoother the rest of the way. Still a little nervous trying to keep it higher, make sure if anything started to drop, it wasn't going to crash or anything. And then as soon as the third lap was done, nerves just dropped completely. It almost felt like the landing just seemed a lot easier than I was expecting it to be.
Yeah, that's awesome. Can you tell us a little bit about your plane and your design?
So for our plane, we really wanted to try to design it around maximizing score based off trying to get all 3 missions done. We wanted to have all of our missions be completed. So we designed it a lot around that, making sure the banner was able to not be restricted at all and able to have space for not just the minimum amount of pucks and ducks, but then also not have too many to where we're just doing the 3 laps, but trying to get more laps than just the 3.
Okay.
So we went with the high wing configuration for that, and then have a little bit shorter of a wingspan, so where it's not where it's still stable, but also we can lower or maximize our score doing that too.
Awesome. So are you feeling good about mission 2?
I think so. We did a couple flights with it, and we know we can do it. So we're ready for that to happen.
Hopefully you get to fly today. And you completed ground mission.
Yes, we did complete ground mission.
How'd that go?
It went all right.
Okay.
We're not like the other schools that are just doing three ducks and 1 puck. So ours went a little bit slower. But
Okay. And it's your first time at the competition.
Yes.
So if you had one word to sum up the competition and like your experience here, what would that word be? How would you sum it up?
I don't really know.
I don't know.
It's exciting. It's exciting.
Yeah. Awesome. Anybody else?
I think we're all just proud to be here.
Yeah.
Proud being here. Everyone worked so hard on this, especially our team leads. They did so much. He's been training to fly for a long time, so we're so proud of him.
Awesome. And my last question, what's your post-competition plans, celebration plans? Do you have that?
We're going to Topgolf tonight.
Okay.
And then also an 18-hour drive home. Yeah.
Road trip back to Harrisonburg.
Yeah. But then we're going to see how fast our plane can actually go.
Awesome.
Just actually have fun with it instead of stressing about it.
Yes. Yeah, it would be like much more relaxing. Awesome. Well, it's awesome talking to you guys. Good luck in the next phases of the competition. Go Dukes, and we'll send it back out.
There was a white splitter USB-C cable that was over here. I have no idea where Jerry did with it. Is it sitting over there by the rack?
I can check.
If you got a second, yeah. If not, don't sweat it.
Okay, we're back here down on the flight line. Once again, I am EJ doing the flight line commentary here for the AIAA 2026 Design, Build, and Fly competition. A little bit of a sketchy landing there from the last one, but the crowd was indeed going wild when that plane touched down. Ground crews are up there safing the plane, and we'll get ready here for the next team. And here they are. Next team, ready to go. Okay. Okay, Chris, who do we got?
We got Team 74. They're coming from California State Polytechnic University in Pomona, and they're flying their plane, the Dreamcatcher. And they gave me some good information. For DBF, all their planes are named after a horses that are bred at the campus, and they're Arabian horses. So since they started doing DBF, they named their plane. So Dreamcatcher is an Arabian horse that was bred at the university.
Wow. Okay. All right. Cool. Cool tidbit of info there. Now they're getting ready out there, getting ready to go. And that's, once again, that's Team 74, California State Polytech Institute in Pomona. All right. Yeah. Okay. They've done their flight control surface checkout here.
Sit back, behind the table. Behind the table.
All right, and we just got word from the judges that this was flight 50. We're making some good progress. Once again, we have 89 teams here.
You're all set. All right.
89 teams showing up. We got teams from 15 countries and almost 1,200 students here. Flight 50. Making real good progress. Here we go. Dreamcatcher clears turn 1 into turn 2, coming around. All right, going through 360-degree left turn on the backstretch. Dreamcatcher going through turn 3 into turn 4. Nothing wonky to report from me here. Everything looks real good. Planes flying through the air real nice. All right, through the loop. Everything's looking real good. Not really much to report here. That plane's flying excellent. They're using an overhead wing design, tricycle landing gear. Very, very, very stable. I'd like to add that the overhead wing design is actually a little bit more stable when it comes to cargo too. I'm not sure if that's what that was the design reasoning behind them. Maybe we'll have to go ask them. But yeah, everything looking real good there. Third lap of 3 from California State Polytechnic Institute at Pomona. And it's like I was saying a little bit earlier, you know, if my job's boring, that's not, you know, I'm just sitting here watching the planes fly. I'm having a great time. But that means that's a real testament to the caliber of students that we have here coming from all over the world. They really pulled out all the stops here. It's been relatively clean on the flight line here. And that just shows the talent that that's in the works here, in the bullpen, so to speak. Now, we are in Wichita, Kansas here. We're at Textron's facilities. Pretty big name in the general aviation area here. So students are in the bullpen, but Textron's big leagues. Like I said, building these planes and making them fly like this. Look at that. It's a testament to the students that we have in the bullpen there. There we go. Oh. Crowd's going wild again. All right. Okay. So once again, if you see me, the camera's on me, so you'll be looking back at the staging pits. I'm just looking at the planes that are coming by. But as one team comes off, the next one pops back. We're past 50 flights here for Mission 1. That's pretty good. We have a little over half. Great flight, guys.
Thank you.
Good job.
Thanks.
All right. Good stuff. Good stuff. Chris coming back to me with the next team. All right, Chris, who do we got?
Up next is Team 75 from Alexandria University in Cairo, and they're flying the plane Phantom.
Alexandria in Cairo, okay. Like I said, international competition, that's great. Do they know this? Do they know that they're up next?
I think they know they're up next.
All right.
The judges told me they're up next.
Oh, okay. All right. There we go. We'll see. They're in staging 3 here. Yeah. Stage 3 with the black hoodies there. Let's see, they're moving up. So once again, this is the AIAA Design Build Flyer, DBF competition here. We're out at Textron's facilities here in Wichita, Kansas. Now, Chris, it's not always here. This is my first time actually being here. Is this competition not always here, right?
It's not always here, so it rotates every other year between here and Tucson.
Tucson,
so last year
okay.
was in Tucson.
Cool.
And then we'll be back here again in 2 years.
All right, there we go. That's great. I'd say a big thank you to Textron for letting us use their runway. We got a big old runway here. Now we're not using all of the runway. We're using about 1,000 foot of a much larger runway, but we do thank them. It's pretty cool.
Textron Aviation Employees Aviation Flying Club.
Them too, for letting us use their hangars, that's for sure. Yep, Textron Aviation Employees Flying Club is where you see those great interviews that are being done in the hangar. When we say the hangar, that's what we're talking about. We're doing a great job here. So once again, Alexandria University is teed up for the next flight here. Okay, there we go. The team's telling them that they should be up here ready to go. Okay, they're opting for, they have a front engine, so single front engine design here. They got, looks to be a tail dragger design here. Here we go. They're pulling onto the flight line here.
Go back. Just one person take the airplane out. You go.
Okay.
You're out of here. Triple pilot يا ابني. بيقول لك triple pilot ها. ولا احنا need this right? If you need to get the score sheet. Okay.
Yeah, okay. So they're sending out two. You can only have 3 people out here on the flight line. You need the ground crew, the pilot, and the observer. Okay, they're getting ready to go here.
Okay. Somebody stays with the pilot. You arm the fuse. We need you behind us. So, whenever you guys are ready. You're ready.
Okay. Pilot is ready. Alexandria University, Cairo, arming the plane. And once again, they're arming the plane not to arm any types of weapon systems. I want to be very clear. It's just to make sure that the engine works. We You want to be safe here. You don't need one of these engines going off when the plane is in the hangar or anywhere else. They do turn them on in the staging lanes though.
All taken off.
Okay, here we go. Alexandria University up in the air. Oh geez. Oh geez. Got a lot of side slip there. Oh no! That's not what you want to see. Oh, teams aren't happy about that. It seems like they may have not had rudder control there. Recovery crews are going out and getting the plane off there. Ah, that's, you know, I said I didn't want action. We had no action on the flight line, and that didn't mean that I wanted it. Yeah, that was Team 75, Alexandria University at Cairo.
They're located in Egypt, in Alexandria, Egypt. Sorry about that, I misspoke. So
Oh, okay, no problem. Yep.
Get too fact checked.
Yeah, no problem, no problem. Alexandria and Cairo are in fact two different cities.
They are.
Yeah. Oh no.
Volunteering. Do I need to help out with that, or
Oh yeah. Yeah. All right, they are removing the airplane from the environment here. Once again, you don't want to see that. You know, it's you know, you might, if you're at home watching this, you're like, it's just an RC airplane. You know what? These students put in a lot of time and a lot of effort into these designs, you know, and that's not the, you know, they do say you learn by failing, right? But you don't want to fail like that. But it does happen. So, you know, I'm sure they'll bounce back. Plane looks mostly intact. I didn't see too many pieces fly off there. They're bringing it back over here.
we talked about having a truck set aside and dedicated.
But yeah, still not an ideal result for them. Yeah. But yeah, that's it. You learn from these mistakes, you bounce back, and you nail that test flight. They'll be back. They'll be back. Okay, so who do we have next, Chris?
So up next we've got Team 77 coming from the University of Tennessee, Knoxville, and they're playing the Smoky Mallard.
The Smoky Mallard from Team 77, University of Tennessee, Knoxville. Here we go.
Do I go with you or?
All right.
Score sheet, yes, sir.
Quick things at a glance here from, what do we got? The Mallard there? Or the Smoky Mallard. Smoky Mallard has a gigantic airfoil. That's a really, and when I say gigantic, it's actually really long airfoil. Now that means that this plane is gonna generate a lot of lift, but it doesn't seem like the airfoil has a lot of downward, I'm not even sure if that's the right term, the downward deflection, but they do have a gigantic wing surface area on this thing, including stabilization. This plane should cut through the air real good. Now, you know, you got a wing that's long like that. I'm not 100% sure if, you know, you might have too much stability here. That plane might fly too well. Okay, blade fuse is in, engine is on, flight control surfaces are checked out. Once again, this is University of Tennessee, Knoxville with the Smoky Mallard, Team 77. A little bit of oscillations from the front gear there, and it looks like they got a gust of wind right when they took off. Okay, cleared gate 1, turning around. All right, coming through the 360-degree turn on the back straight. Okay, turn 3 into turn 4, coming back onto the main straight. Once again, they're looking to complete 3 laps here in 5 minutes. Whoa! Seem to get a lot of deflection from the from your elevators there. deflection is basically how much the control surfaces are moving. Okay, entering lap 2, turning around through turn 1 and turn 2. Doing the circle on the back stretch. Okay, turn 3 into turn 4. Okay, going into lap 3 here. Okay, judge cleared through turn 1 and turn 2. Whoa, okay. Okay, all right. That was another gust of wind there. Okay, going through the loop, really tight turn. Okay, 3 into 4, looking real good. All right. Completing the 3rd lap there. Okay, circling around for a landing here. Oh, wind's getting a little choppy. Okay, they're lined up for the approach here. Let's see. Oh, that wind. The wind's really taking it with those big wings. But that didn't stop them from doing a good touchdown. Great job. Great job. Good mission 1 flight. Whew. We got cheers from the crowd there. Team cheering on. Once again, they can only have 3 people from the team, a pilot, a ground crew, and an observer out on the flight line. So the rest of the team has to watch from behind us. Okay, Chris, you're back with me. What do we got?
So we've got Team 78 coming up from the University of Alabama at Birmingham, and they're flying their plane, the Vulcan.
The Vulcan, here we go. University of Alabama at Birmingham, Team 78. University of Alabama, Birmingham, putting the Vulcan out onto the flight line. Ground crews, put it in the blade fuse to arm the plane. Flight control surfaces. Bit of miscommunication with the judges there, but everything seems to be good. Once again, University of Alabama at Birmingham, arming their plane, getting ready for their Mission 1 flight. So the Mission 1 flight is more or less just a flight test. Take the plane around, do 3 laps around our track. Okay, he's having a little bit of trouble putting the blade fuse in there, but we do have movement from the propeller. Okay. Little bit of a prop test. Prop is working. The thing is, though, you got to do 3 laps of the track here, but you got to do it in 5 minutes. You are timed. Okay, there we go. Okay. All right. Ooh, I'm not sure if the wind is taking it or It's just stability in the frame. Oh, didn't cut. Well, she's coming around through turn 2. Very wide berth coming out of turn 2. All right, but we're back on track here. Next thing would be a 360-degree turn. All right. Vulcan managing that turn really good. Once again, you got to do 3 laps here. Coming through turn 3 into turn 4. Okay, crossing the start-finish line, getting ready for lap 2. Once again, it's University of Alabama at Birmingham, flying their Vulcan plane, doing mission 1 right now. Circling around through turn 1 and turn 2. Everything's looking good here. Whatever heebie-jeebies the plane had on the first lap doesn't seem to be having them right now. Going through the 360-degree turn. Real smooth, real smooth. Okay, through turn 3 and turn 4, lap 2. Completed here, going into lap 3. Vulcan just cutting through the air. Very good. Okay, down into turn 1. 180 degrees. Turn back through 1 and 2. Now, third lap into the 360-degree circle. Everything looks real good. All right, 3 to 4. UAB completed, looking to complete their third lap here. All right. Pilots circling around here to bring the Vulcan back down to the ground. Okay. Aligned with the runway here. Bring it on home. All right. Great landing. There we go. That was the University of Alabama, Birmingham, with their Vulcan. Greece in mission 1, making it look easy. Okay. So as they land and prep their plane for mission 2, I am going to be off commentary for a little bit because I'm going to go have a little bit of a lunch break here. Chris, what team do we have coming up next?
We have Team 86 from the University of Maine with their plane Barely Airborne. Barely
Airborne, University of Maine coming up. But I am going to take a second here, grab a quick lunch break. We will still be providing flight line coverage, sans commentary here. So, next team taken to the skies. I'm hearing through the loops here that we have some pretty nice camera angles of the flight line coming for you guys. Might have something to do with the drone. I don't know. We'll see. I'm going to be watching that while I'm eating my lunch. So I will be back momentarily here, but don't worry, the flight line coverage is not going anywhere. I will see you guys in a little bit.
Until they clear up the wreck over there.
They're getting staged. They're getting staged. You got some time, Gary. So stay.
Score sheet. Good sunrise.
Yeah.
Score sheet.
Crashed plane is.
You're going to go behind the white tables. And whenever you give us the all clear,
Crashed plane is coming towards the us here. You want to spin her?
He is my observer.
Bowling
Stay
or
with
axis
your pilot.
bowling?
And you are clear. Okay. It's all right, guys. Here we go.
turn. I tried to turn it.
Should I stay
bring it
here or
back,
wait?
And then a gust of wind hit it with that one.
All right. Just with you.
And
The observer.
listening team, of course,
You're the observer?
I can just do this.
Yeah.
Ground crew? Okay.
Welcome to flight line.
Thank you.
Where's the flag guy? That guy's sitting.
Yeah, so they're in there. So when I cross them, they'll raise their flags up. Yeah, just take turns. And then so we're gonna do 3 laps. That's 1, 2, 3. When I cross center line, they'll break off. I'm gonna do a short approach. Then land.
Okay, all yours.
Great. I'm good to advance the throttle whenever.
Yep.
All right. Thing off up there, right. Use blood
Ground crew. One job.
What's he supposed to do then?
Typically ground crew.
Jerry, everyone's waiting for your drone. So turn your drone around.
Okay, yeah. When you come out here, you know,
Yeah.
remove ground crew.
So he'll just stand next to me. He was supposed to do that. It's okay, but
You're fine.
just remember for next time.
The observer is ground crew.
So who is the ground crew?
Okay, ground crew back
Ground crew back here.
Sorry about that.
All right.
All right. Ready.
row.
How far do we go?
Center line.
Let's go.
Who has the score sheet?
Oh, you want it back?
Okay. I score sheet.
Pilot, you ready?
You can power on. My transfer's on after I'll set on.
Well, that's great. Come on out here. Be involved. I don't know why you're hiding back there.
Well, I don't know where you want me to stand exactly.
Oh, no, that's fine. No. Then come up and talk. You're free to... The pilot observer can be anywhere.
Okay. Okay. I think we're just conditioned.
Your power on? Your clear to power on. Just power receiver on before you put the fuse in, but just clear. There we go.
Good?
Cool, I'm good. I got signal.
Yep.
Yeah, I know. Long vents, thunder,
All right, that's in there.
I don't think you need to hold the plane. You want to do another?
You want to do this? What? You want to test? I mean, we just did.
We're
It's
good.
fine.
I think we're good.
All right.
So ground crew behind the table.
All right. Just, is it at my discretion? You can just start timing when I start taking off?
Yep. I will be where you want to say. The wheel yours.
Table.
Just stand over here.
I'm going to stand probably just like right here.
Okay. Can I just call it flag?
Yep.
Yep.
Yeah. Be careful. There's a drop off on the edge.
Yeah.
Okay, so those are my two flaggers? Yeah. All right.
I'll call
So just so I know where I'm looking.
Well, your observer should be looking. You should be looking at the airplane.
Just keep it
All right.
level until I say.
All right.
All right, Andy, you got this.
All right, taking off.
Flag. Push it too hard. Yep.
What
Flag.
the hell? Oh, I lost signal. That was fail-safe. Whoa, do you see that flip? My God, that flip was fail-safe. I fail-safe for a second.
Feel confident. I would ask you to land.
I can land it. I'll go back and land. Do you want to finish just the pattern or literally just land?
If you're concerned at all, land.
Well, I can finish the pattern if you want. Okay.
Well, that's what I want to do. It doesn't count, so I might as well.
I have no idea why it failed safe there, but it definitely did. That flip was the fail safe setting. I'm pretty sure.
Good job. Appreciate that.
Can I back taxi or do you need to walk?
Everyone's good on the runway?
You're fine. You come back
Be
here.
careful. I'm back taxiing.
Stop.
I'm back
He's taxiing back. Talk to your pilot. Know what's going on. Just communicate.
I failed safe.
Takeoff speed, dude.
I forget how powerful.
Don't stop it if it's rolling.
Oh yeah.
You can turn it. Turn it. Slow it down. Stop it when it's rolling. All right, you're good.
Thank you.
Make sure somebody grabs the score sheet.
Jesus.
Make sure somebody pulls the fuse. We will see you out here.
Pull that, turn it off. You did a good job getting the fuse in.
Yeah.
No, that flip was fail-safe setting.
Okay.
That was not me. That was perfectly level flight. He went woo. So that's yeah.
Thank you.
This is cool. Stand on a runway.
I know.
What the heck?
Yeah.
Well, nice and, all right. I can take off this direction. There's so much space.
I'll take you back in one piece, dude.
Yeah.
Back in one piece. That counts for a lot.
Score sheet, please. Score sheet. Gotcha. Mud puddle. Sorry, man.
Okay, you can be with the pilot. Don't for your sheep when you're done. Okay. Thank you.
And then when you're done out here, I just need you behind white tape.
Okay, plug that in then.
Okay, I was just making sure I didn't hear any talking.
Okay, here, tell me the flags go up, okay? Whenever y'all are ready, let me know and I can depart.
I'm ready whenever.
Judges, we good to take off? Okay, here we go. No, we're not going up. There's zero elevator. Like there's just not enough elevator. Nose steering's also a little weird, but the big problem is that there's just not enough up elevator. Like it was. Yeah. Hey Becky. Yeah, we're ready. I'm at the flight line. I'm actually on my way back now. Yeah, things I'll just come out with you guys.
Damage?
Yes.
All right, we'll just have to get that checked and
Yeah.
retake that a little bit.
Okay, got it.
Back out here. Pilot, feedback.
More control surface. Like we need more control surface. Yeah. On everything.
All right. All right.
Yep.
All right.
Good.
Thank you.
Okay. Dang it! I broke my streak.
All good.
Oh, that's all right.
A real good streak.
All right.
That's fine.
Thank you.
Thanks. All right. We need to clear the flight line here.
Oh, yeah. Hey, I just got to fix the landing gear.
Fix the landing
Line up
gear.
on center.
Yep.
Make
Yep.
control
Yep.
surfaces line.
Right here.
Okay, right here.
First sheet. Awesome.
Okay. My circular turn over then. Like the 360. Okay. Okay. Sounds good. Just checking. Does the whole plane need to be ahead of this one?
It could be anywhere in this area. We don't have to
Right here. Alright, I'm crap for you. Observers over there.
Okay, so the observer should be with you.
You need to be with me, Tyler. Where are you at? Can you stay with me at all times? You just tell me as well. Will they see the flag? Especially if I don't see it. I'll let you know at the time. Thank you. Alright, you ready? Good for arm? Receivers on? He's going in. He's in. Are you allowed to run up?
Yeah, just let me know.
Okay.
Yep, you can do it quick.
Why would you like to do a run
At
up?
the table.
Nope. Okay, we're good then.
You got it.
Okay. Yeah, ready whenever?
Yep, you're good.
Okay. 1, 2, 3. How was that full elevator ride?
All right, go get it. Pull the fuse.
Roger.
Go ahead and walk back towards the crowd and then back this way.
Okay.
Thank you, thank you.
Thank you.
No, you can walk out on the runway to get it. But on the way back, go by the crowd. Thank you. Russ, whenever anybody's ready.
So we'll see you again.
Awesome.
See you again for a successful flight next time. Thank you very much.
Good day.
You did.
So this is the fun part of the day? So it's a challenge, or they've never been here, so it's always fun when people come out and they're like, around each other like, I have no idea. Like, should we figure this out? You know what I mean? Yes. Yes. And we're like, okay, cool. Oh yeah, there's back over here. Oh yeah, the score sheet is over there. So it's fun. That was basically a year away. I don't know. It was like some of those
There was one that was positive with PIO all the way.
Okay, welcome back to the flight line, everybody. I wanted to bring you guys back in here because we have the first mission 2 of the day. The team flying is University of Southern California. We got the Trojan Horse, USC. Let's go, doing the first mission 2. Now, what is mission 2? Mission 2 is pulling cargo. You have to pull cargo and passengers. The cargo being hockey pucks, and the passengers being rubber ducks. They did that on purpose, didn't they? Yeah, they did. All right, so we have, I just actually talked to the pilot. They said they have 130 ducks on board in change. It was somewhere around there. 130 on this plane. What's that, 60th flight? We got the 60th flight too, out of 89. So we're making some good progress here. 89 being 89 teams. Now, USC obviously is going for their second flight here. But, yeah, this is the first mission 2 of the day. Now, just for the DBF competition here, let me just kind of run through. You have 4 different types of missions that you do. The first mission, which is what you guys have, everyone has seen, just these missions, unless you can count the ground mission that we covered yesterday, is just a flight test, just flying the plane around. Mission 2 is carrying cargo and passengers, like what we see here. Mission 3 is pulling a banner around, and then mission 4 is how fast you can load cargo and unload cargo and reconfigure the plane from mission 2 configuration to mission 3 configuration. Mission 4 is your ground mission. We did see that yesterday.
I'm not gonna hold it. They said I couldn't.
All right, USC putting in the blade fuse on the Trojan Horse. Once again, it's team number 1. They have tone, engine is armed. All right.
Taking off. Taking off.
Here we go. Trojan Horse takes to the air. Okay. Now, once again, this is the first mission 2 here. Mission 2 is flying the same track that was flown through mission 1, but now you got to do it with cargo. Cargo, though, okay, doing the 360-degree turn. Cargo means your plane's going to handle a little bit different. You have more mass on board. More mass can influence the design. Now, once again, it's up to the teams to get this to balance around your center of lift and center of mass. if your plane has it flies good with a good center of gravity relative to center of lift with no cargo, then you put cargo in it, it could shift that around. And that definitely can affect how the plane handles. However, doesn't seem to be affecting USC here with their flight. The plane does not appear to be perturbed from the cargo. Okay, they're doing the 360-degree turn for lap 2 here. Okay, got a good flag from the judge through 3 and 4. All right. Going through, so start at lap 3, going into turn 1 and turn 2 here. Coming out of turn 2, gonna do the 360-degree turn there. Plane lost a little bit of altitude through that turn, but seem to be working real well here. Okay, through 3 and 4. All right, coming around on the final stretch here for lap number 3. All right. Performing real good. Coming around through 3 and 4 again. That thing is just killing it. Not much to report here from me. Okay, coming down the rest of the backstretch into 3 and 4 here. Making it look easy here. Okay, doing the turn, 360 degrees on the back of the track. Okay, they're coming through on their last lap. Okay. Oh, wow. Beautiful. Beautiful flying there from team number 1, USC. Real good. What team number are you guys? Team number 2. You're going for mission 2 then. All right, cool. Good luck.
Thank you.
Yes, sir.
So, we got another mission 2 here. This is team 2, University of Ljubljana. Slovenian team, if I'm understanding that right. Very good. Very good. Team 2 going for mission 2. Once again, this is a cargo flight. Cargo flight. So unlike mission 1 flights, you have the mission 1 flight is just going up there, flying a couple of laps around, or well, 3 laps for that, and making sure that your plane can fly. Now, mission 2, things get a little bit more complicated. You load up your plane with rubber ducks for passengers and hockey pucks for cargo. Ducks and pucks. And this is the second mission 2 that we have here. You have to complete mission 1 to get to mission 2. Mission 2 is the second mission of these cargo flights that we're seeing here. So, they're arming the plane right now. Okay, there they go. Plane's up in the air. Oh man, that thing's cutting through the sky. Coming down onto the backstretch, going into the 360-degree turn. Wow, look at that. That plane is nimble. Now I didn't get to see this plane fly before. We didn't have the commentary section set up just yet, but man, that plane's cutting. Wow, that's impressive, especially with cargo on board. Looks like the University of Ljubljana, forgive me for the pronunciation, looks like they've opted for a very long fuselage, forward wing. And their control surfaces are as far away from that center of gravity as possible, and that really, really makes the plane nice and stable, really makes it cut through the air real quick. Notice how the moves with the plane, or the maneuvers of the plane are very, very deliberate. Very nice. Also testament to some pilot skill, I will say. That thing is just making a mockery of this course. That's crazy. Doing a 360-degree turn. Oh man, this is a treat to see this thing fly. Look at this. I'm almost expecting some paraffin smoke coming out the back, some acrobatics being done here. Looking real good. Not really sure I have anything to add. Pretty sure me talking over this beautiful plane flying around would take away from it. This is great. Okay. Once again, making it look easy. I am over the moon how nice that plane is flying. It's beautiful. Wow. It's just a treat watching this, I'll tell you that. And that's with cargo. Turn around through 1 and 2 again. Coming right back at us on the back stretch of the track. There we go. Doing the 360-degree turn. Coming out of 3 and 4. Once again, this is with cargo. Now, it's probably not as much cargo as University of Southern California had. They had 130 ducks on their plane. Remember, the minimum amount of ducks. The minimum amount of ducks that you need is 3. You need 3 ducks to 1 puck. That is the bare minimum. We'd have to go ask them. I'm not sure if they've opted for bare minimum here, but the way that plane is maneuvering is definitely probably indicating a lighter payload or lower mass payload than what we saw with the previous team that attempted mission 2 for the first time. Okay, circling around, back on the main straight. Oh, there we go, an aileron roll from the University of Ljubljana. Very good. Pilot circling around, coming in for a landing. Oh, he may have still been flying when he did that. He's still been completing the course. Showing off well flying the course. That's impressive. That's impressive. There we go. And a high barrel roll, an actual barrel roll. All right. Look at that. Oh, and a full loop. Oh, no, nope. Oh, not a full loop. Oh, now he's just showing off. That's great.
All right, now it's time to land.
The judge telling them that it is now time to land. Circling around for a landing here. Okay, lining up on the approach. Look at that, nice soft glide. Coming in for a landing. Oh. And the crowd goes wild. I will say, that was impressive.
You can go. Thank you.
That was impressive.
At the very end, yeah.
Yeah.
Okay.
Beautiful job
This is
from
the right
the
one.
University of Ljubljana. Doing real good. All right. There you go. I got Chris back with me. You needed to eat his lunch. Welcome back, buddy. Did you see that thing fly? Oh my goodness. That guy was just showing off. He was doing loops. He did an actual barrel roll. You know, he had elevator and aileron. That was a real barrel roll. You know, if the plane's just doing this, right, that's an aileron roll. That's different. Any plane nut's going to tell you those are two different things. And Buddy had enough guts to actually do the barrel roll, which is pretty impressive. That's really cool. Really cool. This is RMIT.
Nice work, guys. Really good flight. Thanks.
All right, so the next team coming up is the Royal Melbourne Institute of Technology. That's team number 3, doing mission 2. Okay, they're getting set for mission 2. This is the 3rd mission 2 that we've seen here.
Of the aircraft.
Morning. I said at the very least, next time you'll do a little bit better.
Yep.
Excited.
Yep.
That's the way it is.
Just telling the last team that was pretty cool.
Avionics on.
All right, here we go. RMIT.
Yes.
So the past 2 teams we've had are actually international teams. They are from Slovenia and Australia, respectively here. RMIT. Here.
We clear?
You're good.
Taken to the skies for mission 2. Okay. They are armed.
Yep.
I'll get behind the table.
Planes onboard systems communicating. Good prop. Prop being propeller. Propellers on. Here we go. Uh-oh. Plane slewed a little bit on takeoff there, but pilot's got it back under control. Okay. Now once again, remember, these cargo missions, putting cargo on the plane can affect how the plane flies. if the cargo is not perfectly balanced, your plane's going to act a little bit differently when it's flying through the air here. MIT's plane getting a little bit squirrely there, but through the 360-degree turn, once again, a lot of altitude on this one. We got an okay for them to go through 3 and 4. They're turning around. The wind has died down a little bit here. We still got a light wind coming out of the north here, but not nearly as bad as it was on flight day 1. Okay, circling around through 1 and 2. Right. Doing a 360-degree turn here. Everything looking good. Probably highest we've seen a plane up there. Pretty much all competition. Once again, this is a Mission 2 flight, so you're not necessarily just doing 3 laps, but there is cargo on board in the forms of rubber ducks and hockey pucks. Rubber ducks being your passengers, hockey pucks being your cargo. And once again, like I said, that thing, you know, you put ducks and pucks on there, it can make your plane fly different, or it might not. It really depends on how the teams are going to go about attacking these challenges. Either way, putting added mass into the airframe is definitely going to make it perform differently, whether it shifts the center of gravity or not. Plane is way up there. Altitude is the best insurance, though, right? Through 1 and 2 again here, circling around. All right, the wind started picking up again. Let's see if that's going to influence this. Wind started picking up a lot. We got a big gust coming through right now. See if that's going to affect their performance. Once again, the wind is coming from the direction that the plane is facing right now. Bringing it back down. Slow to the ground. Looks like she's coming in for a landing. There we go. Touch it down. RMIT completes Mission 2. High fives from the crew there. Real good. Okay, so that was the 3rd Mission 2. So far, the 3 teams that have competed in Mission 2, University of Southern California, University of Ljubljana, and the Royal Melbourne Institute of Technology. That's RMIT. Completing Mission 2 is pretty smoothly here. Good. Chris is back with me here. So who do we got coming up next?
So coming up next, we've got team number. Team number 4. They're hailing from the University of Notre Dame with their Duck of the Irish plane. And their payload they're carrying this time is 24 ducks and 8 pucks.
24 ducks, 8 pucks from Notre Dame. Let's see. Duck of the Irish heading out on to the runway here.
Yep. Whoa.
And once again, how many ducks did we have on?
24 ducks, 8 pucks.
24 and 8. It is 3 to 1. Yeah, you have to carry 3 to 1. So for every 3 ducks, you have to have 1 puck. So I mean, we saw planes. How much did USC had? Like 130 ducks. So that means.
Or was it?
No, I actually asked their pilot when they were out here. That's when you were taking a break. Okay. They had said they had 130 ducks. So that means they'd have to have a third of that many pucks on board too.
All right.
I don't know how they got that all in there, but they did a good job. And that's what I mean. you know, you could sit here and you could think about, like, okay, you have 130 rubber ducks. That's not too much extra mass, but that's a lot of hockey pucks, right? That's a lot of extra mass put into that plane. And that's what I mean about cargo is now going to change up your conditions here. It's going to change how the plane flies, whether it moves the center of gravity of the plane around or not. And that's what makes these Mission 2s just a little bit different than Mission 1. Mission 1 was just making sure the plane can fly. Okay, Notre Dame is arming their plane. Pilot and observer are ready. Ground crews off. There we go. Duck of the Irish with Notre Dame up in the sky for their Mission 2. Okay. Going through turn 1 into turn 2. Getting a lot of altitude, trying to do the 360-degree turn early. You could do it at any point in the backstretch. I mean, ideally you want to do it halfway. But you can come right out of turn 2 and do that if you want. And a pilot's decision, I'll say. Coming through turn 3 and 4. Looking real good. All right. Going through 1 and 2. There we go, doing that 360-degree turn a little bit early. Looks like the plane lost a little bit of altitude going into that turn. If the planes, with most plane designs, when you roll the plane, you're losing the lift that the wings generate, right? Instead of lifting up relative force of gravity, now you're lifting side of the force of gravity. So if you roll the plane too much, you tend to lose altitude. And we do see that when they go through, when they're trying to do that tight turn with this plane coming out of turn 2. It's turn 2, there we go. See? Oh man, I don't know if that's coming through on camera, but they probably dropped about 50 feet there doing that turn. Doesn't seem to be alarming the pilot or anything. That's just flight characteristics. The flight characteristics of the plane. Still flying straight as a die here. You can see that Notre Dame logo on the Notre Dame actually written on the bottom of the wings when the plane flies by. Going through turn 1 into turn 2. Now doing the turn again, a little bit wider that time, less altitude lost. All right. Okay. There we go, Duck of the Irish. Flying by on Notre Dame on Mission 2 here. Looking real good. Okay, going through the rolling. Oh, a little tight. Lost a little bit of altitude there, but gaining it back. Okay, through turn 3 and turn 4. Everything looking real good. Very nice, coming through 2. Doing the turn again here. Oh, okay. Once again, the wind's starting to pick up again. Wind's starting to pick up. It's kind of got intermittent gusts here. And you can definitely see it when it pushes that plane around. Now they're turning onto the main straight. Now we got a pretty good gust of wind. They got a little headwind here. Turn again here. Once again, this is Notre Dame's Mission 2 flight. The majority of flights that we saw yesterday, we saw in the morning yesterday, and in the morning today. We had inclement weather yesterday, so we only saw flights in the morning. The majority of flights up until this point have been Mission 1, which is just a flight test of the airplane. You got to make sure the plane flies before you put cargo in it. And that's what Mission 2 is all about. Mission 2 is carrying around passengers and cargo. Passengers in the form of rubber ducks and cargo in the form of hockey pucks. They had to have planned that. There's no way that that was an accident. Rubber ducks and hockey pucks. Okay, Notre Dame coming back around. Oh, veering a little bit off the runway. Got a warning from the judges there. If you veer too far out of the flight corridor, they will be unhappy. There we go. Pilot has declared landing to the judges. Coming around. It's coming right at us. All right. There we go. Good touch. Good touch. Oh, wing skidded a little bit, but she seems okay. And into the grass. But she's all right. That was the duck of the Irish with Notre Dame there on their Mission 2 flight. Ground crew's going to recover the plane. Chris is back with me. Who's next?
Up next is team number 5 from Georgia Institute of Technology, flying their plane buzzer rang again for Mission 2.
Okay.
And they're carrying 3 pucks and 1 duck on this.
Minimum requirements, huh? All right. Got the minimum requirements from Georgia Tech. All right. Moving out to the runway here as Notre Dame gets their plane off. Here, Georgia Tech gets ready for Mission 2.
Yeah, I think so.
Now, if we're looking at their plane out there. Georgia Tech seems to have a really big vertical stabilizer relative to the rest of the fuselage of their plane.
I went for the spoiler switch. That's what
it's coming by. Hey, good job, dudes. That was sick. Okay. As I was saying, they have a pretty large rudder on the plane, but a really skinny fuselage. And once again, they're opting for the minimum cargo and passenger requirements: 3 ducks, 1 puck, right? And let's see if that plays in there. That big rudder is going to give them a lot of stability.
The sun is straight up.
I'm good to put the fuse in, right?
That might be because, carrying differential mass because cargo versus non-cargo. But we'll see. They are arming the plane and getting ready for flight here. Ground crews getting away from the plane. Pilot is ready to go. Observer is off the on the runway. Ground crew off the runway. This is Georgia Tech doing Mission 2 here. Here we go. Plane has great power to weight. That thing took immediately off. Okay, circling through 1 and 2. Oh yeah, see what I mean about this? See what I mean about that stability? That plane's cutting through the air. Real nice. Beautiful. Through turn 3 and turn 4. Straight as an arrow, coming in for lap 2. Once again, pilot opting to doing the 360-degree turn on the backstretch a little bit earlier. Through to lap 3.
Want a jacket?
Sure.
Looks like a wind gust took that plane up into the air. Really high up there. Okay. Into turn 3 and to turn 4. This is Georgia Tech with their cargo mission, Mission 2 here. Beautiful. Okay, opting to do the 360-degree turn again. little bit of an interesting thing that I'm noticing from Georgia Tech's plane, that large vertical stabilizer on the back of the plane when they opt for a turn is generating a lot of lift. So that plane, when they enter into a turn and a roll into a turn, actually gains altitude. Look at that thing go up in the air. I mean, it's not just because of that V-step, but that is generating a lot of lift when they go to turn. I mean, this is a very, very small, nimble fuselage. Very, very thin. Minimum cargo requirements here. But just because you're meeting minimum cargo requirements doesn't necessarily mean that that your plane is bad. Those are the minimum requirements. It's up to the teams to be able to, if you want to carry more cargo, you can get more points that way. But carrying the minimum requirements means that you can trade off other areas. So like the ground mission, for instance. If you're carrying the minimum, your ground mission is not going to take nearly as long. So it's kind of up to these students to pick out where they want their planes to be quote unquote profitable here. The idea is that your bush plane flying missions here. That's why you're carrying cargo, and you can also carry a banner. Once again, Georgia Tech really, really cutting up the skies here. Looks real good. Real good. Yep.
Lap 7 done.
7 laps. Yeah. The 3-lap requirement is only for mission 1 here. Another thing to consider is that because they're carrying low cargo, they don't have a lot of cargo, that they can afford to have much higher power to weight. When you're moving less stuff, you can go faster.
Lap 8 done.
8 laps.
Turn right.
Okay. They don't have much to have. This plane's doing just fantastic.
9 done.
9 laps.
Turn right.
Wow. Yeah, you can see the plane really gaining altitude through those turns because of that large rear stabilizer. Laps there from Georgia Tech. Timer went off here. Yeah, they're cleared to land now. Okay, pilot bringing it around for a landing here. Oh. Wow. Impressive. Impressive. Recovery crews, ground crews, going to get the plane. And the crowd goes wild. All right. So that was team number 5. That was Georgia Tech there with the buzzerang. Who do we have next, Chris?
Up next, we've got team number 6 coming from the University of Kansas, flying their plane Icarus. And they've got a payload of 26 ducks and 8 pups.
Oh, all right. So, once again, we're seeing those trade-offs here. Icarus is carrying way more than the last plane here. Okay, Cruz bringing the plane up to the pad here. All right. Okay, University of Kansas getting the plane ready to go here.
Can't cross in here? Or what you're supposed to cross in here? Mission 2? Yes.
Okay.
That's gonna be my kid. Or he's gonna be my caller. Sorry.
Okay, sounds good. So if you're done out here, then get you behind the
Okay,
table.
ground crew's leaving, pilot and observer. So once again, this is University of Kansas doing a mission 2. Mission 2 is a cargo flight. Now they're carrying a little bit more payload than before. We have 26 ducks and 8 pucks. See, actually, that's kind of interesting because they have 26
So I was
and
talking
8.
to them, and so they've got a couple more ducks in there than they actually have to carry. So that'll add, I think it adds an extra point. I'm not 100% sure.
Okay, okay. Cool, cool. We'll have to check the rule book and see, but there we go. They're taking to the skies through into the 360-degree loop here. Okay, pilot's bringing it around. Okay. Judge down in turn 3 and 4, indicating through the gate. Oh, they got a warning for leaving the flight corridor there. You got to be careful on the front straight of this track. Can't go out over the grass. The reason why? We're standing here. You can't violate the flight corridor there. But on the other side, where there's nobody over there, that's where they do that 360-degree loop that you see here. Uh-oh. Okay, okay, looks like they got a little gusty up there. You can really see here that the cargo is affecting performance here. Icarus was one of the first planes that when we got the flight line commentary up and running, that was one of the first planes that I saw fly on mission 1. And there's definitely a difference in handling here from Icarus on flight day 1, University of Kansas here. Well, but it's because the mission 2 is cargo. You got to load down your cargo in there. I mean, when you sit here and think about it, you know, we say 26 rubber ducks, 8 pucks, right? 8 hockey pucks is a lot of extra mass to add to a plane this size. So the plane is going to appear to be this, and this is what I mean about cargo affecting how the plane handles. It's a lot more mass for that propeller to move, and it's a lot more load on the wings. The wings have to lift up more because there's more things to lift up on board the plane other than the plane itself. That does affect the handling here, and you're really seeing it. Oh, a little bit of a gust of wind. The wind's starting to pick up again. Again, I do believe that the pilots are flying the plane high on purpose. The reason why they're doing that is because altitude is the best insurance, as the pilots say. Okay, doing a 360-degree turn here. Everything looking good. Looking good. Windsock's really going now. We got a lot of windage coming from the north.
We're at 3 minutes and 38 seconds.
Okay. Bring the plane through turn 1 and turn 2. Yeah, see. University of Kansas got a little bit of a challenge here with that wind. Wind has picked up comparatively to earlier flights. It was pretty calm for the last hour, but now it's starting to pick up again.
4 minutes.
Okay, coming through turn 3 and turn 4, back around to the main straight. Once again, this is, if you've seen this plane flying before, this University of Kansas with their plane Icarus, they're doing mission 2 here, which is
45 seconds.
which is the cargo and passenger mission here for the competition. Mission 2
Just over 430, Daniel.
is where you have to carry, well, rubber ducks as passengers and hockey pucks as cargo. The minimum requirements are 3 ducks to 1 puck. But they've opted here with this plane to have 26 ducks and 8 hockey pucks. Here. They did put 2 extra ducks in for style points, we'll call it. Oh, geez. Okay, their timer's up. They're gonna come in for a landing here. You have to keep that plane flying for 5 minutes through mission 2. Pilot's bringing it in. A little squirrely there. Okay. Oh.
Excellent. Beautiful, Daniel.
Nice touchdown. Very good from the University of Kansas. That's Icarus. Very, very good. Okay. So as they taxi the plane back and vacate, I got Chris back with me. Chris, what do you got? Who's next?
Up next is team number 7. They're coming from the University of Texas at Dallas, and they're flying their plane Leviathan, and they've been carrying a payload of 54 ducks and 14 pucks.
Whoa. They loaded Leviathan down. It's living up to its name, huh? All right. Here we go. Coming right by us here. Good luck, boys. Yeah, no. You got this. You got this. No comment. I'm not saying nothing. Okay. Did I see that right? How many ducks do I have? 54 ducks and 14.
Yeah, sounds good. I've been listening.
And 14. That's a lot. That's yeah. Long fuselage should favor stability, and it looks like the tail on that plane too is a fin. Yeah, to give them a little more stability flying through the air. Exactly. That will help you with side slip.
Yeah.
In a little bit.
Ready to arm? Yeah, you're right.
All right. University of Kansas walking past us. Hey, good job, guys. That was good. Real good. Oh, okay. All right. Blade fuse is in. Engine is on. Leviathan's getting moving. There we go. Oh. Okay. We're good through turn 1 and turn 2. Coming around, doing the loop. Okay, into turn 3 and turn 4. Again, we got 54 passenger ducks on board. And as I was saying before, cargo does affect how the plane handles, but I'm really not seeing any sliding around or anything from this plane. Seems to be cutting through the air pretty good. Through the loop here. Once again, for mission 2, you got to keep that plane aloft. It's not just about laps. You got to keep the plane aloft for 5 minutes. Everything looking real good. Oh, a little bit of a sharp turn through turn 1 and turn 2 there. Okay. Everything seems to be good. When the team was walking by, they did express some concern with the center of gravity. I'm not seeing any of that here. That plane's flying perfect. It's pretty good. Okay, there we go. Turn on the back side there. Okay, turn wind has died down. It's not as bad. But you wouldn't know by watching that thing fly. Okay. Pretty quiet here on the flight line. Uneventful, and for what these teams are trying to do, uneventful is good. No news is good news. Through turn 3 and 4. Once again today, you got a slight wind coming from the north, basically the way the plane is flying right now. But you wouldn't know by watching it fly. Everything looking real good. Now, once again, this is a Mission 2 flight. Mission 2 is moving cargo around. Oh, it's coming right at us. And he touches down after 5 minutes. Okay, a little bit of a pucker moment there, but it's all right.
I had 6.
All right.
That got a little close.
That's great. That was definitely. I kept your.
That got a little bit close there. I went diving. That plane, I don't know if the camera did that one justice, but I went diving for the cones over there. I'm like, nope. I feel like the flag crew at a hand egg game. Like, see the football players coming at you. Just drop the sticks and go. Okay. So Chris, who did we just see fly there?
We just saw the University of Texas at Dallas flying Leviathan.
Man, they made it look easy there with all that cargo. Who do we got coming up next?
Coming up now, we've got team number 9, hailing from the University of Washington, Seattle, flying their plane Mako, and they're carrying 3 pucks and 1 duck.
Okay.
3 ducks and 1 puck. Sorry.
Minimum requirements.
There's a story to that, but he told me this long story, and I'm like, I'm not sure. It was fairly technical of why they did it, but they decided they wouldn't get as many points on this. They're going to get their big bang for their buck on Mission 3, is what they're telling me, with their deployment of their
the banner.
The banner.
Yep. Now this is one of the more unorthodox designs. Now we do have a conventional tail dragger there, but it's got a V-tail and contra-rotating propellers. That's pretty, very trick design, very nimble. Very nimble. Kind of looks like it's channeling some extra 300 there, even though this is a low wing, right? But definitely.
I'm looking forward to their Mission 3.
Yeah.
What they told me, they're going to deploy that banner from the front. So come more from the front.
Okay.
It's going to be a little different. So.
All right. Okay.
Good job, guys.
Thank you. Okay. We just wanted to say thank you very much for watching, everybody. Shout out to everybody that's watching us over on YouTube, on the AIAA YouTube channel, and people are over on Twitch watching it on my Twitch stream. Shout out to the chats. Let's get some hype in the chats that I can't see as this plane takes to the sky. There we go. Okay. Yeah, that plane's slick. Real slick. I like this plane a lot.
University of Washington, Seattle.
Okay. Mako. Once again, those contra-rotating propellers making some very interesting noises. So, just if you didn't see it, there was other planes with contra-rotating propellers, but if you don't know what that means, there's 2 propellers actually at the front of this plane. One propeller is spinning clockwise, and the other one is spinning counterclockwise. There's a lot of technical mumbo-jumbo behind that, but what that essentially means is that one propeller is feeding the other propeller, and you can generate a lot more thrust that way. There are trade-offs to this, though. You need a more powerful engine to move two propellers, but not as powerful as if you needed two separate propellers. There have been contra-rotating planes in the past. The Tu-95 is very, very well known for it. And then there were concept contra-rotating planes where one time the U.S. Air Force tried to attach a turbojet to a contra-rotating propeller, and the Republic made the XF-84, the Thunder Screech, which they very quickly realized that that may be a dead-end technology. When your propellers break the speed of sound, it turns out it makes the plane really loud. That is the other thing that contra-rotating propellers are notorious for on real aircraft. They're actually pretty loud. Once again, University of Washington, Seattle with Mako. Not seeing any of that. Their plane is performing great. The other thing to note is that their plane has what's called a V-tail. It's where you don't really necessarily have a horizontal stabilizer or a vertical stabilizer, but you have two stabilizers that are 45 degrees up in either direction off the back of the plane. That way you can control pitch and yaw with just two control surfaces instead of three, but always trade-offs here. The V-tail offers a more simplistic design. You only have two control surfaces back there, two control surfaces to control two axes. Now that's not necessarily how it works, but you're not going to get as much what's called control moment with a V-tail, meaning that because your surfaces are, the two rear control surfaces at the back of the plane are being used for yaw and pitch, right? You're not going to have as much control authority on either one rather than if you had dedicated surfaces like on a T-tail or just kind of a regular tail. Because those surfaces getting some questions here, responses coming in from the chat. But yeah, that V-tail is definitely out there in the back. So contra-rotating props was the big question here. The contra-rotating props, you have one prop in front of another. One's moving clockwise and the other one's moving counterclockwise. Like I said, there is a lot of technical mumbo jumbo behind this, and I don't know. You guys want to hear something like that? You let me know. For the plain English way of saying this is that the front propeller is breaking and feeding the air into the second propeller. The second propeller doesn't. It's basically it's getting fed the air from the first one. That does end up giving you more thrust, but you do need a little bit more powerful motor than you would have with one propeller. But you don't need as powerful of a motor that you'd need with two propellers, like say if there were two propellers on either wing. Contra-rotating will give you more thrust from one power plant, right? But once again, there are trade-offs. You do need a slightly bigger engine to move both of the propellers, but because the first propeller is breaking the air for the second propeller, right? That second propeller, I'm not going to say it doesn't need to work as hard because that's not the right way to say it, but that's the general idea. So, but once again, that shows. That's a trade-off, and that's what this competition is really all about. You see a lot of planes that look different, like University of Washington, Seattle with Mako. Very, very different design, V-tail, contra-rotating, but you've seen other planes that use tricycle landing gear. You've seen other planes that use T-tails. You see there's been other planes with two engines as opposed to one. You see some planes like that are using a twin tail, like a P-38. That really shows the trade-offs, and all of that is driving where these teams are trying to score points. Some teams opt to score points in other areas, like Chris was telling me. But there they go, they're coming in for a landing. Oh, and Mako touches down. University of Washington, Seattle, killing it. That's fantastic. Very, very good. Crowd goes wild. It's fun seeing the teams actually cheer them on. They're going bananas back there. Real nice. Real nice. Okay. Chris, you're back with me. What do we got?
So next team up is Team 10. They're from RPI, Rensselaer Polytech University, and they're flying their plane Koi. ducks and 1 puck, just a minimum.
Minimum requirements, and that's what I was talking about with those trade-offs a little bit earlier.
Right.
So here they go. They're coming up from behind here.
Again, from the camera this time, sorry.
University of Washington, Seattle, coming off
job, guys.
coming off the run.
Thank you.
Good job, guys. That was great.
Good luck.
There we go.
Thank you. It was a good flight.
We got RPI coming up here with their plane. Good luck, guys.
Thank you.
You got this.
Thank you.
Yep. Actually, if you guys didn't know, RPI is the alma mater of the recent Artemis II mission. The commander, Reed Wiseman, this is his alma mater taken to the skies here. Now, this plane isn't going to the moon, but maybe someday. You don't know. Okay, they're doing control surface check out here. Once again, this is a Mission 2 flight. Mission 2 meaning they're carrying cargo. And as Chris was telling me a little bit earlier, we have 3 ducks, 1 puck, so they're carrying minimum requirements here. Now, just because you're carrying minimum requirements doesn't mean that you won't score points. You obviously get more points for more cargo, but it's, once again, we're talking trade-offs here. Carrying lesser cargo might be on, it's obviously on purpose because they're aiming to score points in other places. Less cargo means you can get a better score during Mission 4, which is the ground mission. You can obviously load 3 faster than you can load 150, for instance, right? So we'll see how RPI does on this mission here. They have 3 ducks, 1 puck, engine is on, plane's taken to the skies. Let's see what they do here for Mission 2. Got to keep that plane up in the air for 5 minutes. Oh, doing the loop there. Lost a little bit of altitude on the backside there, backside of the track. All right. Wind has picked up just a little bit. Once again, we got winds coming out of the north. It's actually more northwest now, if I'm looking at that windsock right. So it's given us just a slight crosswind on the runway. Okay, going through 3 and 4. The RPI pilot bringing that plane through the main straight here. Again, they got to keep that plane, RPI has to keep that plane up there for 5 minutes with that cargo to show that it can maneuver around with it. Okay. Wind's kind of died down again, but it has changed direction slightly. We got winds north-northwest, coming out of the north-northwest here. Once again, introducing a slight crosswind on the runway. Oh, you saw it right there when they tried to do that turn. Stalled out some of the wings. Okay, coming through 3 and 4. Straight level flight. Playing straight as a die. Really good.
Flag up. Flag up. 247.
Okay. plane, the RPS plane used to have a lot of deflection on their rear control surfaces. Deflections meaning that the control surfaces move more. The angle relative to the stabilizer that they're attached really can move a lot. That's how they're able to do those tight corners. That coupled with a large wing surface area means you can pretty much cut through the air real nice. But as I was talking about before, that introduces trade-offs. You know, you have more deflection, that's also going to make more drag. It also will slow you down. I mean, turning slows you down too, but everything's looking good here. Going through the loop on the back part of the track. Okay, circling around onto the main straight. We got a good signal from the judge down in 3 and 4. See how it cuts through that corner? That's fun to watch, I'll tell you that. Oh, got hit with a little bit of a wind gust there. I don't know if it came through on the camera. They lost about 50 feet of altitude there through that loop. Through the back loop. Now, once again, the back loop is not actually doing a loop, the maneuver. It's just a 360-degree turn on the back part of the track. Okay. Looks like the timer's up. Pilot Ferrari, oh, there we go. Timer's up. Pilot's bringing that plane in for a landing. All right, we got a good landing there. Everything going good. Okay. As RPI brings their plane off the runway, who do we have next?
Up next is Team 11. They're coming from Virginia Tech out of Blacksburg, Virginia, and they're flying their plane Mako. And they've got a payload of 48 ducks and 13 pups.
How do they fit 48 ducks in that plane?
I mean, welcome back.
I do believe their pilot is also wearing a Bucky's Beaver coverall. Okay. All right. All right. You know, ground crew prepping the plane for flight here.
Orange flag, this line right here.
Okay, so it's okay if we turn a little bit that way. Okay, that's fine. Yeah.
Awesome.
Okay.
We got 8 beeps.
Perfect.
Here we go. Checking the flight control surfaces here on Mako from Virginia Tech here. Okay, engine is on. Ooh, the wind took it right when it took off, but I think they're in the air. Okay, through turn 1 and 2, everything's looking good. Now, Chris, once again, how much cargo do they got on this thing?
They are carrying 48 ducks and 13 pups.
Whoa. Okay, that's a lot of cargo. That's not the most that we've seen, but it's definitely up there. Virginia Tech opting for to try and score some major points here for their cargo mission. back stretch of the track. Oh, a little bit of a warning from the judge for violating the flight corridor coming out of turn 4. Other than that, Virginia Tech and Mako working pretty well here. Okay, coming through 3 and 4. Everything looking good. I think it looks real good flying through the air.
That's 3.
That's it. Okay. Mark.
As I was saying before, with these Mission 2s, no news is good news. Virginia Tech and their plane Mako just flying around, having a nice, easy flying day. Now, I will say, conditions today are a little bit less crazy than they were yesterday. We had 20 knot winds coming out of the south, gusting to 27. That was on flight day 1. Day 2, we got winds coming out of the north-northwest, less than 10 knots. Really, really nice day for flying. We got a perfectly clear sky here in Wichita, Kansas. Everything's looking real good, but yeah, it's a nice clear sky here. Plane's coming in. All right, coming in for a landing. There we go. Oh, a little bit of a bounce. Ooh, nice adjustment, nice landing.
Walk it back to the gas.
Walk it across. Okay. Yep.
So you're gonna
Am I good to taxi?
You can, but you
Yeah,
gotta
hold
come
on.
back.
Zach, come back. He's gonna taxi it back.
Taxi it back. You guys need to.
Okay, taxiing the plane back. All right, we'll stop.
Good job, so. Did we stop at Buc-ee's again on the way here?
Always.
Absolutely.
Are these new or are they from last?
This is from 2 years ago.
Okay, safing the plane.
Okay.
Where's the
All right.
Buc-ee's outfit?
And we've got cheers all around
Stop
from the
one
crowd who are
Nashville?
also
Okay,
wearing
'cause I know
Buc-ee's.
Springfield has one.
Jesus.
There's more Buc-ee's in the crowd.
I love it. I'm gonna
Well,
go ahead
there's
and
now.
guess that they stopped at Buc-ee's while they drove here.
It's like right outside Harrisonburg. Hold please.
Okay, Virginia Tech comes off the runway. Who do we got next,
big.
Chris?
It's like
Up
the-
next, you've got the
they
12
always-
coming from
they always
Embry-Riddle
are.
Aeronautical
Okay.
University in Daytona Beach
Yeah,
with
you guys are
their
good. I didn't get swim.
plane
We have to
Okay.
remember give Pups and Ducks back.
Yeah. What's up?
You're out
Let's go.
Daytona. Here we go.
And then go do ground mission before the line.
Yep.
Now, once again, we've seen a lot of cargo missions
You guys see
flying
that?
here, but this is their mission 1. This is their test flight.
Soraya. I did that on purpose. Yeah, I got the score sheet, Soraya. You got the fuse. Awesome. Donald cut on, Donald 0?
Donald cut on, Donald 0.
Let's get the score sheet. Riddle. Yes, sir.
Hey, all right. About time we make an appearance.
Yay.
Yes. Yes, Donald cut on, throttle 0.
I'll forget it.
Okay, Embry-Riddle Daytona. We did see the other Embry-Riddle Prescott fly yesterday. This is the Daytona contingency.
All right. 7-0. So we just need you behind the tables?
Actually, the Embry-Riddle Daytona is right at Daytona Airport. It's right across from Daytona International Speedway. They're all right there. So if you like car racing and planes, Just saying, pretty good time.
Mission one, gyro on, autopilot on. Telemetry looks good. Let's do deflector.
All right.
Right.
Vehicle's ready to go. Flight control surface checkout is ready to go.
Sounds good. Awesome. Cool. Ready when you are. Are we good? You're good? Sounds good. All right. I'm going to make sure it turns. Taking off right to left.
Okay. Engine start. Okay, flying around through turn 1. Remember, this is a mission 1 flight, so they got to do 3 laps. The mission 1 rules, you got to do 3 laps around the track. You got to do it in less than 5 minutes. Completing the loop. All right, coming through 3 and 4. We got a green flag down there from the judge. All right, coming through on the main straight. Winds have died down to almost nothing, but they have shifted direction a little bit. Winds are now kind of coming from the northwest here, but they're really, really low. We got pretty clear skies, pretty calm winds. Okay, circling around. Okay, circling through 1 and 2. Doing the loop, opting to do the loop a little bit early, immediately coming off 2. Okay, through 3 and 4. Okay, completed the 3rd lap. Pilot's circling around for a landing. Okay, circling around for a heading alignment. And we got a nice and easy touchdown. Oh, a little bit of a bounce. A little bit of a bounce. Crowd goes wild. Recovery team's moving out to secure the plane. Once again, that was Embry-Riddle Daytona Beach with their Mission 1. Completing it in style. Seemed to be pretty uneventful, which, once again, no news is good news in that regard. There we go. Does this look like fun? It's a lot of fun. It's a lot of fun. Even just sitting here in the commentary box. It's a lot of fun. Okay, next team out here is UCLA.
We're coming this way. There you go.
Making sure that they orient the plane correctly. Definitely want a headwind during takeoff.
Avionics on. All right, sounds good.
Embry-Riddle passing by. Hey, good flight, dude. That was great.
Got it.
Yep. Okay, UCLA coming up here. Good flight, guys. Okay. UCLA getting their plane ready.
Control 3, fuse in.
Putting the fuse in. Priming the engine.
Taking off.
All right, here we go. UCLA taking to the skies here. That wing providing a lot of lift, getting way up in the air real fast. No, no problem. It's all good.
Team 14 from the Universidad de Antioquia, flying their plane Scorpion. I'm sorry, University of California, Los Angeles, Duck Goose.
Yep, it's UCLA. Team number 13. Now, is this mission 2 for them?
Mission 2, and they're carrying a payload of 3 ducks and 1 puck.
Okay, another minimum requirements. Okay. Now, you know, it's interesting to discuss the minimum requirements here because, you know, when you're engineering, I find when you engineer planes, I find you often want to exceed expectations. But an important lesson to understand is that, you know, if your stakeholder expectation is 3 ducks, 1 puck, you don't necessarily need to add more. I mean, you do get more points in the competition, but if that's the requirement, it's, you know, it shows that a lot of teams have opted just to meet the requirement, and meeting the requirement is at the end of the day what you're trying to do. If somebody says we need a plane that can move 3 rubber ducks and 1 hockey puck, just make that, right? Now some other teams have opted to score a little bit more points. They've chosen to meet requirements in other areas and exceed requirements in other areas, and that's, you know, whoever has the most points at the end there it's really going to show. But meeting your minimum requirements is still meeting requirements, and that's an important thing to understand. You don't, in many scenarios, you don't want to try to over-deliver. 3 ducks, 1 puck is what the rules say, and if that's what you want, if that's what you got to do, that's what you got to do. Meeting requirements is actually what you should be doing when you're making a plane. UCL's playing way up in the air. Doing the loop there. Everything looking pretty good. Just pilots opting to keep that plane way up in the air. Again, this is UCLA doing mission 2, carrying 3 ducks, 1 puck, which is just the minimum requirements here. Got a beautiful, beautiful clear sky here to see their plane really flying around. They got a lot of altitude for this flight, but altitude is the best insurance. There is winds that are gusting. They are gusting from northwest if I'm looking at that windsock correctly. So gaining some altitude could be good if gust is going to blow you off course or something, or worse, into the ground. You don't want that. Pilots always tell me that altitude's the best insurance. And UCLA really utilizing that right now.
Flag.
Okay, circling around through 3 and 4. Yeah, that crosswind kind of coming into play. Our runway's going north-south here. Pilot saying, declaring a landing here. Starting to pick up again. Okay. Definitely noticing that crosswind there across the runway. Planes flying a little bit sideways coming in, but that's okay. Putting a little bit of lean into it. And we got a pretty good crosswind landing there from UCLA. Not bad. Not bad at all. Completing their mission 2 there. Got cheers from the team there. Fantastic. Good flight for UCLA. They're probably pretty happy with that result. Okay, as UCLA vacates the runway, Chris is back with me. Chris, what do you got?
Now we're at Team 14 with the Universidad de Antioquia with their plane Scorpion and their payload of 18
and 6. All right, there you go. We've seen heavy payloads. We've seen minimum requirements. This one's right in the center.
Yeah. All right, all good.
Okay, Universidad de Antioquia getting out onto the runway for their mission 2. UCLA passing us. Good flight, guys. So once again, there's no upper level of how many ducks or pucks that you can carry here. There's a minimum requirement. If you want to pull more, you can pull more. But if you move more cargo, you're going to pay for it with other missions. There's always a trade-off. And that's what I like to think that this Design, Build, and Fly, DBF for short, is teaching kids. That's good. This is good hands-on systems engineering dealing with what's called trade-offs. You can't have your cake and eat it too with physics. That never happens, ever. So this design, the DBF has been put into place to allow these students to experience what you have to do with trade-offs here. You can't do everything, can't do it all. Okay. Okay. There we go, Scorpions up in the air. Gaining a lot of altitude, just like we've seen previously from other schools. They got 18 ducks, 6 pucks on board. Now they got to keep that plane, for mission 2 requirements, you got to keep that plane up in the air for 5 minutes. Scorpion performing beautifully. Once again, the Universidad de Antioquia has a tricycle design, a tricycle landing gear design, meaning they have the small gear up at the front of the plane, 2 main gear under the main wing. They're also utilizing a T-tail, which means that your horizontal stabilizers are on top of your vertical stabilizer. Very stable design. Very stable design there. A tricycle gear allows them to rotate. It allows for a lot of rotation when you're taking off and landing, so you can get that nose up in the air. And the T-tail allows you a lot more deflection on your horizontal stabilizer, so you make the result there is really stable on your pitch axis of the vehicle, so moving the nose up and down relative to the horizon. It's very similar to, I don't know, Beechcraft King Air, same idea. Okay. Doing the backstretch loop there. Okay, coming through 3 and 4.
Coming through 3 and 4. Universidad de Antioquia is actually one of our international teams competing in the DBF. They're from Colombia here. And once again, they're on their mission too, so they do have cargo on board. Circling around through 1 and 2. Okay, on the back stretch of the track here, 360-degree turn, backstretch loop. So we're telling the pilot that they're down to 3 and 4. We got a good indicator from the judge. Oh, a little bit of roll there, a little bit of roll. And once again, I'll say this as we've seen, you know, all the other Mission 2 competitors that are, or all the other teams that have done Mission 2 competition today. No news is good news for these flights. Okay, pilot is declaring landing here. Circling around for heading alignment. Pilot feathering throttle. Beautiful rotation and touchdown. Great job. Universidad de Antioquia. Perfecto. Taxiing the plane around, we got cheers from the crowd. Okay, ground crew is not allowed to enter the runway until the plane has come to a complete stop. Keep the tray and seat backs in the upright and locked position. Wheel stop, ground crew's got the plane. Safe in the plane. Waving to the camera, let's go.
Oh, sorry.
Perfecto, amigo.
Thank you.
Good job, guys.
Thank you, guys.
Okay, as Universidad de Antioquia vacates the runway, Chris, who do we got up next?
We've got Team 15, Auburn University of Auburn, flying their plane Independence. And they're carrying a payload of 12 ducks and 4 pucks.
12 ducks, 4 pucks from the Auburn University at Auburn with their Independence plane. You're doing Mission 2 here. Okay, Auburn and Auburn, ready to go here. So this is their Mission 2 flight. They have flown before. The Mission 2 is the cargo mission. Okay, ground crews, leaving the runway. Pilot and observer getting ready to go. Ground crew is off the runway. We are ready to fly. Flight control surfaces being checked by the pilot.
Okay. Everything looking good from them here. Okay, going through the loop, back stretch of the track, everything's looking good. Okay, once again, this is a mission 2, so that means they got cargo on board. Comparatively, their mission 1 flight, the cargo is going to change how the plane flies. You wouldn't know by looking at Independence flying around. But yeah, it seemed to be doing real good. Okay, going through the loop. Once again, for mission 2, you need to keep that plane up there for 5 minutes. Just keep it up there flying the course for 5 minutes, you come back in and land. Everything's looking good here. Going through the back loop. Starting to get some cloud cover moving in here, but that doesn't seem to be affecting the plane too much. Wind is staying pretty steady at this point. Everything's looking good. See, there's that wind. There's that wind. A little tight coming off 3 and 4 there, but everything looks really good. Once again, this is Auburn University at Auburn. Looking real good on their mission 2 here. Almost done with mission 2 here. All right. Timer's going off, circling around for a landing. Coming in, good approach. Oh, a little bit of bouncing, Pilot makes the correction, brings it down smooth. Good flight there. Ground crew's going to secure Independence. Auburn University at Auburn scoring their independence for mission 3. Very good. Okay. Chris, you're back with me.
I'm back with you.
What do we got next?
So up now is Team 16 from Purdue University at the main campus, and they're flying their plane, the Quack Edie. Yesterday I said it's Quack Eddie, but the real name, they corrected me, and I want all the listeners to know that it's Quack Eddie.
Quack Eddie. All right. Here we go.
No, with Quack Edie.
Edie?
Yeah.
Quack Edie. All right. Yeah, I got you. That makes more sense. Hey, good luck. Good flight. Let's go.
Good luck.
Quack Edie from Purdue.
From Purdue.
Team number 16.
Payload.
What do we got for payload here? Okay. Once again, Purdue opted for twin vertical stabilizers and a twin engine design. A little bit different than what we've seen here. Twin engine obviously is going to give you more power. You got two engines. You got two engines. Move a lot more with that.
Auburn.
Yes.
Auburn coming off the runway. Good flight, guys.
You want to make that count, right?
Okay.
Yeah, all right, tire ready.
Okay. Okay, Quack Edie up in the sky here. This is Purdue's mission 2, so this is their cargo mission. There are 4 missions here for DBF. Design, build, and fly. We got 4 missions. The first mission, mission 1, is just a test flight. We did see a lot of those yesterday. We've seen it a little bit today. Mission 2 is moving cargo and passengers, quote unquote, around. Passengers being rubber ducks and cargo being hockey pucks. That's the mission 2 requirements. That's the majority of the missions that we're seeing today. Mission 3 is towing around a banner, or towing around a banner and flying around with the banner. We haven't seen anybody do a mission 3 yet. Purdue is doing mission 2 right now. And then mission 4 is actually what's called a ground mission. Mission 4 is kind of goes hand in hand with mission 2, but in different, I don't know, the correlation is kind of depends on what type of plane you made here. So the ground mission is timing how quickly you can load and unload cargo into your plane and then reconfigure it from mission 2 requirements to mission 3 requirements. Now, the interesting thing here is that you're not going to, you could either lean into doing cargo, you could lean into doing the ground mission, you could lean into doing the banner flight. It's really interesting to see how these design decisions are influencing, how these stakeholder requirements are influencing the design decisions of these teams. Because you could opt for being better in mission 3, you could opt for being better at the ground mission. It really depends on what you want to do here and where you want to score those points and what you think is the best way to make your plane the most quote-unquote profitable. Again, Purdue just flying the course here. Now, Chris, you're still with me here. They have a pretty sizable cargo on there, right? That's more than what we see. Not the most.
Not the most, but it is quite sizable, yes.
Yep.
The one coming up here has got 24 pucks and 24 ducks and 8 pucks. So they've got a little bit different ratio. 4 ducks and 9 pucks.
Yeah, because that's what they have on this flight. Yeah. Okay. Looks like they've completed all the mission requirements for mission 2. Now, only thing left to do is just land. Pod circling around to get a headwind during landing. You know, these RC planes as well as real life planes, you ideally want to get a headwind when you're coming in for landing, when you're coming in for takeoff. That means you can land at a lower airspeed and take off in a shorter distance. Oh no! The gear came off. Main gear came off, but he bellied straight down the runway. He was right on the center line. Not bad. A little bit of a, we're not sure if that was a hard landing or if the thing just came off.
I think the landing gear just popped off.
Yeah?
There's part of it on the runway there.
Yeah. Crew's going to pick up the main landing gear. Plane seemed really good after the belly. It did a nice belly landing. Okay. Purdue pulling their plane off of the runway. Okay. Who do we got coming up next?
We've got Team 17 coming up from the Military Institute of Science and Technology, flying their plane Heisenberg, and they're out of Bangladesh. You know, yesterday I said they were from India, but they are from
Bangladesh. Yep. There we go.
And they've got 24 ducks and 8 pucks.
There you go. So, Military Institute of Science and Technology with Heisenberg opting to try to score some extra points here with their cargo mission. Not opting for minimum requirements, going a little bit more. There's no upper limit to what kind of cargo you can have, or how much cargo you can have on these planes. You can put as many ducks as you want in there. I mean, the plane's got to fly, right? There is a minimum requirement. Right there is kind of an open-ended area where the teams have to decide where they want to score points. You want to score points in the ground missions? That's mission 4, where you're loading and unloading cargo. Do you want to score points in the banner mission, where maybe you want less cargo? Or do you want to score a lot of points for mission 2, which is what we see right now? Mission 2, you can opt for more. There's no limit. You can carry 1,000 of them if you really want to. That'd be really cool. I don't know. I think the highest one we've seen, Chris, is 150.
I think it's 150. Yeah, 150, 151.
Yes, somewhere around there. Okay.
Now it's just more aerodynamic.
Purdue crew's coming by. Good job, dude. Hey, that belly landing was mint. It's perfect. Yeah, I don't know. Yeah, right? Of course. It's not a bug, it's a feature. Hey, there you go. Hey, it saves mass.
Nice landing.
Appreciate it, bro.
Hey, there you go. All right, Military Institute of Science and Technology out of Bangladesh with their plane Heisenberg. I say that this is the best name. This is the best name that I've heard. Okay, throttling up, rotation. Okay, they're up in the air. Oh no. Oh, crew's not happy with that one. Not happy with that one. We've had an anomaly there. But hey, that's the beauty of this competition, you know? It's not how hard you could hit, it's how much you can get hit, right? That's what Rocky said. That's right. You bounce back from this, you come back, you fly again. That's how this works. Oh boy. Hey, once again, Military Institute of Science and Technology out of Bangladesh had a little bit of a crash there. They it looks like they throttled up. They went to rotate out, and then it seems like something happened with the plane just after that, and it came back down.
came back down. But once again, that's this competition. Failure's the best teacher, and I'm sure they'll be back. They'll be back, and they'll get it flying better than ever again. Okay, it's just gonna take a second here to clean up the runway, make sure you get all the bits and pieces. Okay, recovery crews are out. Okay, looks like we got help on the way. Okay. So as they pick up down there, next team coming on, I'm just going to take a quick pause here for a moment while they clean up the runway. Pause between flights, that is. Coverage is staying going here. Once again, I'm EJ, your flight line commentator, with Chris Horton here. He's kind of being the liaison between me and the teams there. Chris, you're doing a good job. He's the one that's giving me the payload numbers, the team numbers. That really helps. Really helps a lot. But yeah, we're out here at Textron Facilities, Wichita, Kansas, for the 2026 AIAA Design, Build, and Fly competition here. And it is a competition. It is fierce. Stuff does happen.
I'm going to make a plug. Don't forget to follow AIAA on Instagram.
Oh, that's good. On the gram. Remember, you got to post pictures of your planes for the gram, obviously, right? And just once again, shout out to all the people that are watching the live stream, the AIAA live stream on the AIAA YouTube channel and on my own Twitch channel over there. Thanks for watching, guys. I do appreciate it. I don't have the chat in front of me, but you're here in spirit. Thank you very much. So once again, there was a little bit of a, let's say, hiccup on the runway with the last flight. It's just going to be a second before the next flight while they clear the runway and make sure that everything is, make sure there's no FOD on the runway. So we'll take a second here to talk about FOD. What does that mean? Foreign object debris or foreign object damage, depending on what you like. Could be either one. It's basically anything that's not intended to be there, being there. So in this case, there's runway FOD. You don't want to have a bunch of bits and pieces on the runway and have the next plane go to take off and potentially run over and ingest some of that FOD. So that's why they got to take some time to clear the runway. Same is the case in real aviation, right? And now FOD doesn't necessarily mean a crashed plane on the runway, though. It could be leaves, it could be dirt, it could be if there's bits and pieces of tar, if the runway delaminates, if you have a runway in a place where it snows. Could be anything. There we go. Help a truck. Clearing the runway. I think the runway is clean. Okay, Chris, who do we got next?
We got Team 18 coming from Belur Institute of Technology in Belur, India, with their plane Maran. And this is mission number 1 for them.
Okay. Belur Institute of Technology, team number 18. All right, once again, so this is a mission 1 flight. Mission 1 is just the flight test for the plane. Some teams might take you a second to get going, might take you a second to dial in the plane. That's the beauty of this competition. You're gonna get thrown curveballs. And you see adaptation and improvisation from there. All right, here we go, they've taken off. Okay, so once again, mission 1 criteria is doing 3 laps around our track here. There's turn 1 and turn 2. The track is more or less an oval, but on the back stretch of the track, where they are right now, you gotta do a 360-degree turn. I'm calling it the backstretch loop. Now, that's not to be confused with an actual maneuver that is a loop where the plane is upside down. Backstretch loop is just a 360-degree left turn in this case. Once you come off the backstretch here, you're gonna go into turn 3 and into turn 4. Okay, and once you come out of turn 4 there, you're back onto the main straight. Now, it's important to note, you know, runways, you often have runways that go in different directions because of the wind. We do have windage today, And it is a little bit of a crosswind, meaning the wind is blowing over the runway instead of down the runway. Ideally, with the runway, you want to take off into a headwind. That's why you have numbers at each end of the runway, so you could take off in one direction or the other down the same runway. Technically, that's 2 runways, right? So we do have winds coming out of the north-northwest right now. They're not too bad. I'd say probably 5 to 10 knots looking at that windsock, the windsock that we have out here on the field. But it's important to know that when you're coming out of turn 4 here, you are going into a little bit of a headwind there. And when you're on the back stretch of the track, including doing the back stretch loop, you have a little bit of a tailwind coming off in turn 2. Okay, turning around 1 to 2 here. All right. Doing the 360 degree, the back stretch loop. Okay, turning around. 3 out of 4 here. Or 3 and 4. Ooh. Not sure if that was a gust of wind. The pilot looking to come in for a landing here. Okay, turning around, aligning with the runway, feathering the throttle. Hey, and a good touchdown, all right. And the crowd goes wild. All right, great mission 1.
Oh, good on. Pull the fuse.
There you go.
Yep, we're good.
Excellent. So Chris, just refresh my memory. We had that was the Lohr Institute of Technology in Lohr, India.
Correct.
Cool. Now who do we have coming up?
Coming up next is Team 20 from the University of Missouri in Columbia, flying their plane Bengal, and this is mission 1 for them.
Okay. So we got another mission 1 team, University of Missouri, yeah?
It is.
Okay.
Columbia.
University of Missouri at Columbia. Getting out onto the pad here.
So this is the
runway.
right here.
So once again, this is a mission 1 for this team.
That's what I found.
Mission 1 is just the flight test mission, as opposed to mission 2 requirements that we've seen from some teams today. Got a lot of mission 1 teams out here just trying to get their plane flying. Now, why didn't everybody do their mission 1 yesterday? Well, storms. It's hard to fly when you have golf ball sized hail coming down. And lightning, we're out on a very flat area in Kansas. We don't, if there's lightning even anywhere in the area, I don't know about you, I'm bolting. I'm getting out of here. Bolting out. Sorry. Oh, getting away from the lightning. But here we go. University of Missouri doing their first, University of Missouri, which campus was it? Columbia. University of Missouri, Columbia. There we go, getting up in the air for their mission 1. Mission 1 requirements are 3 laps around the track. They have to complete 3 laps in 5 minutes. Okay. Ooh. Trying to take that turn. Wind is taking the plane a lot there, but circling around out at 2, looking good. Okay, doing the backstretch loop there. Once again, struggling a little bit with that wind, but making it through. University of Missouri Columbia opted for a tail dragger design. Tail dragger with a pretty standard tail, wings forward, main gear forward, engine up front, single engine. Sometimes the old tricks are the best tricks. Coming out of 3 into 4, really battling against that wind there. Really battling. That crosswind's really starting to come into play. Pilot wisely choosing to gain some altitude just in case. Altitude often being the best insurance, like I've said many times. 1 into 2 here, turn 1 and 2. Okay.
good. Doing the backstretch loop. Looking real good. Okay. Finishing out the rest of the backstretch here. Turn 3. And turn 4. Okay. Okay. Coming through. Backstretch loop. Oh, the wind really pushing that plane up. Now the wind pushing that plane around tells me that they've opted for a very lightweight design. Lightweight design does get pushed around by wind a little bit, but lightweight means, you know, once again, we're talking about trade-offs here. Lightweight means you're a little bit more susceptible to that crosswind, but that means you got great power to weight. Or you could opt for a thruster weight, excuse me, not power weight. It's not a car. But that tells you can keep the design really light. And keeping the design really light means you could hold more cargo potentially. Okay, coming in for a landing. Okay, pilot's using to go around. Wise decision, you can always go around. Dealing with that wind again. Gaining some altitude. Okay, circling around for another approach. Once again, the lightweight design, that crosswind is really going to come into play. Wind seems to be a little bit calmer right now. Let's see if they can bring it down and grease that landing. Come on, baby. There we go. There we go. A little bit of a wing scrape, but down in one piece. Golf claps from the crowd as recovery teams move to secure the plane. Good mission 1. Once again, that was the University of Missouri at Columbia with their plane Bengal. That was Team 21. Now, who do we have coming up next, Chris?
We've got Team 21 coming up next with the University of Michigan, Ann Arbor, with their plane Frankenstein, and this is Mission 1 for them.
Mission 1 from University of Michigan. All right. Looks like we got some blue coming out. Go blue! University of Michigan with their Frankenstein plane opting for a twin engine design. Go blue! Do have a tail dragger design, but twin engine means way more power. So this is a mission 1 for them. So this is more or less a flight test here. I'm wondering if they opted for that twin engine design to move more cargo around. We'll see. I mean, it's just mission 1. We don't know, but yeah.
I see Mike.
University of Missouri, Columbia coming after us. Good job, guys. Good flight. Good flight.
Score sheet. Yeah, mission 1. Is this track here the finish line? This one? Right here. Yep. So I imagine we should be behind this one.
Okay.
But just know that this is what you have to cross.
Thank you. So this is
Okay. Pilot is getting ready.
Ground crew's getting ready
Very good.
to prime the plane for flight. Okay, ground crews are
behind
clear.
the table here. Awesome. Thanks.
Pilot and observer are ready. They have the go from the judges. 2 engines on. Okay. Looks like that left gear was struggling a little bit there, but Frankenstein is in the air. Once again, this is mission 1. They're just doing a flight test here, so it's 3 laps around the track. Okay, doing a backstretch loop right there. Coming through 3 and 4. Okay, 1 lap completed. Okay, into lap 2 on the backstretch loop here. Really tight turn through the loop there, losing a little bit of altitude. Remember, when these planes, if you take a tight turn, that means your wings aren't generating lift that's parallel to the force of gravity. So if your wings aren't generating lift to counteract gravity, gravity's going to push you down. That's why some of these planes, you see these tight turns, they do lose a lot of altitude when that happens. Okay, through turn 1 and turn 2. There we go, tight turn. Oh, losing. Whoa. Doing a corkscrew through the loop instead. Coming into turn 3. Oh. Do have some windage. Once again, it is a crosswind on the runway today. Three laps completed. And a good touchdown. University of Michigan at Ann Arbor. Blues moving on to mission 2. Okay. So they're going to take a second to go and recover the plane, safe the plane, disarm the engines, and bring it back. Okay, Chris, what do we got next after Michigan?
We've got Team 22 coming up from the University of California, Irvine with the Flying Duckmen, and they're on mission 1.
UC Irvine, the Flying Duckmen. I love it.
Okay, so hand a mic to Chris would probably be the best bet.
Just put it directly across from me. And then, like we said earlier, so every time it passes a flag, just turn. Oh, yes, for sheet.
Yes.
Thank you, go ahead. No.
Go ahead and swap out flag.
When that flag goes up, when that flag goes up, turn.
Am I good for the...
Yeah, throttle cut on, throttle 0, you can put in the fuse. Copy. And then you have to get behind the table. All right, ready?
flight 80.
Picking up right to left.
You got this? Okay.
All right. Yeah. Back out here.
Wait to arm it.
Broken. Here, I'll meet up with you guys in a second.
Have it kind of like speaking to that. Okay.
Brian, you ready?
Go ahead. Up next is Team 23 from the University at Buffalo with their plane Razorbill, and this is mission 1 for them.
If that's your concern,
okay.
You're adding to the problem. You guys ready?
appreciate that. Yep.
What mission? Mission one. Mission one? Perfect. You're observer? Yes. So once you put the fuse in, we'll have you back behind the table.
That worked out okay, Ryan.
This is flight number 80.
Oh, hold on. I'm not gonna. Yeah.
Should I take the fuse out to turn on the avionics switch?
Yeah. Yes.
Yep. Okay, we gotta communicate here.
Got it.
I mean, you can stand on the runway. It's 100 feet wide. There's plenty of room. Plenty of room.
You want me to stand?
Ground crew behind the table. Ground crew. Ground crew. That's you. Behind the table. Thank you.
All right.
Are you ready?
Perfect. Awesome.
Good. Pull the fuse.
Mac, yeah, Mac, that's you.
Well done, you guys. Thank you, thank you. Good job.
Yeah, a little bit on the tail heavy side. Yeah, a little bit. Well, I think it was.
You got a good handle on it, man.
So
up next on the flight line is Team 24 coming from San Jose State University with their plane Rack Wagon. And this is mission number 1 for the team number 24.
Score sheet, please.
Yep, anywhere in there is fine. Hi there. So this is your start finish line.
Okay, thank you. Oh, wait, can we wait 1 second? Then we got the squishy.
Whenever you're ready.
I give it to. Oh, no, okay, tell you that. Thank you.
Next on the flight line is Team 25 from Santa Clara University flying their plane Wings of Theseus. And they've asked me to give a shout out to Dr. Drazen Fabris and all of their moms. And they're on mission 2 with a payload of 3 ducks and 1 puck. Good luck, guys.
horizontally, dog.
All right.
Okay, you guys want to walk over?
I give this to him?
Sir.
Alright, you want to
There you go, sir. And just so you're aware, we are going to do a static thrust test out there before we take off. So,
just let him know.
let him know.
You go to the yellow plate so you don't walk over the cable.
So you can cross the line in the air and land. Okay. Or you can cross the line in the air.
And also, they're going to do a static thrust test before they. Okay. I was told to tell you that. Okay. That's fine. You want to turn on?
walk it back and come into the grass this way and back this way. Perfect, thank you.
So up next on the flight line is our team from the University of Arkansas, team number 27. I'm sorry, I take that back. This is team number 26, University of Kentucky, Paducah, with their plane Daedalus, and this is mission 1.
Talk to your pilot, make sure you got it ready on first.
Ice spinner's on. Turn controls on. Good. Okay. Fuse. Okay, we got throttle left. Get the jacket. Yep.
As long as you know where you wind shifts, we're basically just thermal driven. Yep, that is the start finish line, so that's fine. We cross it here. This is mission 1. We're for 3 laps. All right, it's all yours. Ready.
Think about where this goes. I think the tail's getting smoked to the right.
Stay on the side of the yellow line and head back towards the crest.
Turn.
Make it look easy.
Avionics off, Kyle.
Okay.
passed the yellow line down.
Squeezing every aspect of
Over here on the right. Score sheet over to the
So up
table.
next on the flight line is Team 27 coming from the University of Arkansas with their plane Pee Wee Piglet. And this is mission 1 for the team from Arkansas.
Okay, so hang out with the pilot. One?
Yes.
Okay, so wait for your pilot.
Where can I stand?
You can be wherever you want.
All right.
Wherever you're
Ready
most
for me to turn it
comfortable
on?
on the stage.
Yeah. Turn it on and then put the fuse in.
You're the.
There we go.
Okay, can I arm it?
Yeah.
Mission 1.
Correct.
So ground crew behind the table.
Sit behind the table.
Yep.
Yes, ma'am.
And you're all set.
All right. Just tell me when to turn. It's not trimmed. That was a right hand turn. Yep, I'm gonna take it around for the loop. I should kind of dial in the full there. All right.
taxi it back. Thank you.
He's taxiing it back.
He's been waiting all day to do it. He's been watching for him not taxi back.
We're not making anybody walk today. Alright, I'm disarming.
Awesome. Good job, guys.
Score sheet.
Thank you guys.
Good job. Supposed to be back down here for mission 2.
Dr. Holmes, right to question those elevators.
Hey, what?
With you in my ear.
See, I couldn't hear anything except for you two chit-chatting. I was like,
We need
So
to do
coming
some-
up next on the flight line is Team 28. They're coming from the University of Hong Kong, flying their plane Griffin.
Hi.
This is mission 2 for the University of Hong Kong. And their payload is 3 ducks and 1 pup.
Hello. Nice to meet you again. Yeah.
Was that the position for the airline? Mission 2.
Yeah. Alright, I don't think
This is your line.
Okay.
Yeah.
Arkansas!
You're fine to take
Arkansas!
off.
Wait, let me check the wind direction.
There's a windsock right in front of us. There's a windsock right in front of us.
Okay. 但是方向怎么样？然后离我近一点哈，稍微近一点。哦，放到这边来，然后离我近一点。
Other way.
放到这里。
That way.
放到这里。放在這裡。
放嗰條線，放呢條黑色線，跟住咧望住對呢邊。哦，係啦係啦。
Fuse 放了嗎？
沒有。
哦。Should we plug the fuse?
Yeah.
Okay.
Back here. Thank you. You're good?
Yeah.
Did not get a flag. Oh. Did not get a flag.
Did y'all get those flags swapped out earlier?
Yes, ma'am.
Thank you.
Now on the flight line is team number 29. They're hailing from Washington University in St. Louis, flying their plane side up. This is mission 1 for them. This is their second attempt. They tried an attempt yesterday. Good luck, guys.
You guys do. How many laps do you guys do?
Okay. What do I do? I'm waving.
Put
Okay.
Put the fuse in.
I can put the fuse in?
Yes.
Is it safe?
Yep.
Stay on the pavement here, please.
Okay.
Come over here. Airplane. Oh, you stay over here. Thank you.
Can we get on the film? We have a dance to do.
Okay.
Okay. Oh, wait.
Behind the table. All right. And you're up with me.
I guess we'll do it after we succeed.
Yeah.
Ryan, there's a request. Stay on my cam afterwards.
One?
After this flight. There's a request
Stay
live.
there. Everything's armed. You're good to go. All right.
They're planning on doing something like
No, I stand up just let it.
Uh-oh.
Here it goes. Call us elevator. You want to do your dance too?
Yeah, no, right.
Who's flying the drone? Jerry. Where from where?
He's over there.
Oh, okay.
Yeah, Jerry's just outside.
Yeah.
They're giving buzzes because of the wind. What side do you want to take
So do this on the, basically just a little bit that way of the center line.
and take off in that way?
Yeah, the wind is definitely prevailing from the north.
Okay.
You can get set, but no.
Actually, we don't really want to be on the track.
Pulling some propellers out. At least it went for a nosedive and just kind of.
Okay, so do we have to approach the judges for anything? The paper is already there, and they will see.
No.
M2. Yep.
Hello. Well, it's light variable right now. Good. Yeah.
How's it going?
Good. The footage has been spectacular.
Thank you. Thank you very much.
Who's flying the drone?
Jerry.
Jerry's doing some freaking amazing work on that drone coverage.
No, we're waiting for.
I was saying that when I worked for Blue Origin, we were doing the New Shepard launches out in West Texas.
It's a great system.
FYI, this mic's live. Oh, good.
Do you have a safety line in that direction?
We do not, but stay away from those buildings and facilities.
Yeah, that's because like the sun is right here. We don't want to come above the runway because when they will see the plane.
Stay in front of you.
Yeah. And it does.
Your drone crew has to be behind the table.
Yes. That's what I'm going to.
Yep. Thank you.
Over there. আজকে টেবিলের পিছনে থাকতে হবে ক্যামেরা দিয়ে ছবি টাইম লাগবে I'm getting like a nasty gust.
I've been out here. I probably walked like 7 maybe.
You know where the bad battery spot is? We do not have one assigned yet because that would be number one. Okay. We do have buckets of sand.
Say that again?
Walk behind
So,
Are those the buckets of sand?
Yeah.
Or if you want, you can link the buckets of sand.
Okay.
I believe.
I'll go talk with him.
Okay.
Good.
Wait, some stuff there.
Look up your score sheets.
If somebody can come get your score sheet?
I got it.
Oh, Greg has it? Oh, he's got it.
I'm meeting you halfway. Oh, okay.
So up next on the flight line is Team 30. They're coming from the Aviation and Aerospace University, Bangladesh, flying their plane Phoenix. This is mission number 2 for them. They're carrying a payload of 4 ducks and 1 puck. Good luck, guys.
Arming the fuse.
Okay.
The good one was this morning. Russ kind of leaned back, sunk so far he fell over.
my YouTube account. It came up.
We're landing.
Okay, thank you.
From the University of California, San Diego, with their plane Aaron. This is mission 1 for the team from UC San Diego. And they asked me to do a special shout out to Aaron, and thanks for coming back to help out with the plane. Good luck, guys.
Are you ground crew? Okay, so once you do your thing here, we'll have to get you behind the wiping. Mission 1? Okay, you guys just wait for your pilot. Back you up. You're fine.
Gage, check levels for us, please. Ryan, can you check levels for EJ? They're mic'd up now.
Check 1, 2.
You're in host, are you?
Yeah, I mean, you can get as far, and then I'll
EJ's in post if you can talk to him.
Ryan, I'm here.
Hello.
Is my audio coming in good? And I have Clay, the AIAA CEO here, who wants to commentate on some launches or flights. Is my mic working? Check, 1, 2. Okay, we're back at the 2026 AIAA Design Build Fly Competition, or DBF for short. All right. So, Chris, who do we have up here?
We have the team from University of California, San Diego, Team 31, flying the plane Aaron. This is their mission 1 for them.
Mission 1. Okay, so they're doing their flight test. Now, I do have a very special guest here to commentate launches with me. We have Clay Morey here, CEO of the AIAA. Good to see you, man. Yeah, I haven't seen you since this morning.
Yeah, well, I've been spending most of my time today in the hangar.
Yeah.
Talking to a lot of the teams and how excited they are. You know, I've been asking the teams, how do you summarize this in one word? And most of them are like exciting or unexpected or learning. It was really interesting, the responses we got back from the teams. But it's been well, first of all, let me just say, glorious day.
Oh yeah, way better than yesterday.
Just spectacular weather right now. And also let me say, I've been watching from in the hangars and talking to the teams come back. The coverage here, particularly the drone coverage, it's been really fun to watch. And so hopefully the people watching the live stream can see all the work that's gone into this, and great work by you and your team.
We certainly appreciate that.
Day.
Trying to make you look good, man, that's all.
Here we go.
All right, we got to take off. Okay, so this is the first flight, so they got to do 3 laps on the track here. Plane's up in the air. Okay, going around through turn 1 and turn 2. Uh-oh. Okay, now the next part that they have to do here is a 360-degree turn on the back stretch of the track. There we go. Negotiating it great.
Looks like the pilot's getting confidence during the course of this flight.
Oh yeah, you can absolutely see, the first takeoff it's a little shaky, but once they got, get to the 3rd lap, the grease in these landings. Okay, now we got turn 3 and turn 4. Now once again, we still got winds coming out of the northwest here, so coming out of 3 into 4, you got into the headwind here.
It's getting a little breezier.
Yep. Okay. Ooh, looks like the wind's getting into it a little bit. Okay, through turn 1 into turn 2, we got a good okay from the ref. .360-degree turn. Now, Clay, I'm not 100% sure, but I think these pilots have been bringing those planes up there on purpose. I think that altitude's the best insurance here.
Yeah, it's a little. I think the air's a little cleaner the higher up they are.
Yep.
And you can certainly see that in the performance of the control surfaces in the airplane.
Yep. Okay. Okay, it's lap 2 going on to lap 3. Once again, for mission 1 criteria, you got to do 3 laps around the test track. The key is you can't take sweet time doing it either. You have to make sure you get it done in 5 minutes here. Okay, coming around turn 1 and turn 2. Keeping the plane high there.
Last year we were out in Arizona, Tucson, for the event.
Oh yeah.
And it was dusty, it was dry, and there was dust devils ripping across the runway all afternoon.
Yeah.
So it's kind of a treat to be out here in such nice weather here in air capital of the world.
Yeah.
Just has shown their best day here.
Oh yeah, definitely. Okay. Coming around here. Got an okay there. That would be the 3rd lap. We're gonna come in for a landing here. Once again, the winds were coming out of the north this morning, but if we look at that windsock, we got northwest and almost even west. That puts a crosswind on the runway. That's gonna make landing a little bit tricky.
You kind of feel it coming from behind us right now.
Yep.
Where we're standing.
Yep.
Interesting watching that Lubiano plane earlier because the prop stopped spinning and they glided it all the way in.
That plane was something. It was definitely something. All right, coming in for a landing. Oh, pilot chose to go around. You can always go around. All right.
Perfect.
Nice, good landing. There we go. Completing mission 1 there. Excellent.
Yeah, I think that last loop around was perfect, and just stick it.
Yeah. You know, something that every pilot tells me is that if you're not comfortable with that landing, don't try to stick it. Just go around.
Exactly.
Just turn around, try it again.
Well, that's a good first flight for that team.
Absolutely.
Nice to see that under their belt.
Yep. I mean, we are seeing a lot of mission 1s today because the weather wasn't cooperating with us. Not like today. Today is great. But yeah, a lot of teams greasing these landings, greasing these missions. So, Chris, which team was that? That was UC San Diego, right?
UC San Diego, they're playing air. And now we're on Team 32 from the Hong Kong University of Science and Technology, flying their plane Twin Fury. And this is mission 1 for the team.
Okay, mission 1, another flight test here. Yeah.
Super skinny.
Yeah.
Looks like it's built for speed.
Yeah, I'm ready. They got 2 engines on that thing. They call it Twin Fury.
Clear out. Yeah.
I trust the weight on this one to see how much it darts in the sky.
Yep. Okay, just waiting for UC San Diego. Let's go. Vacate the runway. Hey, good flight, guys.
Well done, guys. Congrats.
Mission 1. 3 laps.
All right.
Okay.
Radio attack.
All right.
Okay. Plug in the fuse. Fuses.
Okay, inserting the fuse to turn on the engines.
Fuse 2.
2 engine, 2 fuse design.
Okay.
Go behind the table.
Go behind the table.
Yep. Thank you. And you're good.
Pilot and observer ready to go.
Clear.
2 engines on. Okay, they're up in the air. Once again, this is a mission. Oh, no. Well, that's not what we want to see. Oh, no.
That was unfortunate.
Yeah, that happens, but you know, that's the beauty of this competition. You know, when you get handed adversity, you power through, and they'll be back for another flight, I think.
One of the faculty advisors was telling me from a major university earlier this morning that he talks to his students about it's not always design, build, fly, but it can be design, build, crash.
Yeah.
And he said, but it's actually a good thing because you learn from those mistakes. You learn how to repair the aircraft, you learn how to rebuild, and you're learning how to improve the design of the aircraft over time. And so it's part of the process.
Yep.
And it's disappointing, I think, for some of the teams that come when that happens. But really, it is how you learn, and you know, everything. They'll say, you know, I've come from a space background. You learn more when you fail.
Absolutely.
Everything's a complete success, and so it's unfortunate. It's tough to take, but it's also just part of the learning process that these students are going through.
Yep, that's it, man. That's what it's all about. I can't tell you how many RC planes I've crashed. You know, that happens. Like, and you learn from it, and it makes you better in the end. So once again, we got recovery crews going out and picking up the airplane.
Well, there's no issue. Looks like they're on the tarmac anyway.
Yeah, it's too bad that plane got up in a hurry.
Yeah,
It looked like it had control. And then,
I think the wind took it.
Yep.
Pretty sure.
Crosswind.
That crosswind, it'll get you.
You want to be certain that it's like that. I can't. Another thing, if I'm in an SR and I can just pop up real quick.
Well, we've got a number of teams from the Asia Pacific or Indo-Pacific region that are in the competition this year. I spent some time this morning with a team from Bangladesh, 2 of the teams from India that are here, and a team from Australia. And the international teams have done historically pretty well. And I'm always amazed. Some of these guys, it took them 50 hours to get here, to cross 4 or 5 flights. The airspace is restricted right now. over several parts of the world because of wars and conflicts that are going on.
Yeah.
And so it's not an easy path. And some of the folks also commented that they design their aircraft specifically to be able to pack in a minimal container to be able to get it.
Yeah, exactly. I mean, there are definitely design constrictions that you have to deal with coming over from overseas, but it just shows the toughness of these teams that are coming from out of the country. They do a good job.
They're resilient. I think it's interesting too. Some of these teams are flying. They're out here flying without their faculty advisors or without certain team members.
Doing it by themselves.
That couldn't do it, and so it's nice to see that.
So
And
this
again,
is your start
it is a learning experience for these guys. A lot of them traveling for the first time to the United States.
Yep.
And I think they're making the most of the opportunity while they're here.
Absolutely.
It's
Absolutely.
You can stand wherever you want. Okay. He was more comfortable standing there. Some people.
Okay, so while they're going over there, getting their plane back, we got another team coming out here onto the runway. Chris, who do we have next?
Up next is Team 33. They're coming from Cornell University with their plane Duck Force 1. And this is mission number 1. This is our first attempt.
Okay.
And it's in red because they're the big red.
They're the big red. There we go.
I hail from upstate New York originally, so
okay.
A lot of my grandfather went to Cornell, and I had a lot of friends that ended up going to Cornell. Smart kids up there.
You're trying to shoot the recovery.
Yeah.
Sorry about
No,
that.
you're good. You're good.
There you go.
So what mission?
Mission 1.
I like the name Duck Force 1.
Duck Force 1 is
That's
awesome.
great.
The names of these aircraft are fantastic.
Dude, some of them make me laugh.
How about that design from that team from USC? They can put 130 ducks inside the.
What a tank!
Oh my gosh!
What a tank that was!
Spectacular. And then I had a time to talk to the team from Buenos Aires, from the Technical Institute of Buenos Aires, Argentina.
Yeah.
And they have this. This is called right now the Flying Dorito.
Yeah, the Delta wing,
big
right?
Delta blended wing design. It's a flying wing, and they can also put in, I think, something close to 150 ducks inside in these little foam containers. The design is something very unique, and that's their first time competing.
That's great.
Creative, right?
Yeah, I think that shows the quality, like the coolness of an opportunity like this. You have design requirements, you have minimum requirements, you have to move a certain amount of ducks, a certain amount of pucks, right? But at the end of the day, there's a lot of open-endedness for creativity, and I think it really gives the students the ability to kind of, experiment with different designs, see what works, see what doesn't work. I think having an avenue like that where you can really explore systems engineering is great. I love this. This is my first time here, and I'm astonished by some of these designs. They're fantastic.
Well, when you talk to the organizing committee here, again, we're powered by our volunteers. We talked about this earlier this morning. We're powered by 50 volunteers on site. But a lot of these guys are the OG, man. They started doing this 30 years ago. As I mentioned, in Maryland on an island, 10 teams. They've built in a lot of interesting aspects to the rules around this competition, and so they let the designers have trade-offs. There's a risk-reward proposition.
Exactly.
That's going on. The ratio, for instance, of pucks to ducks. And you can design, or you can design for ground, or you can design for flight. So I love the fact that they built this in. And by the way, the other hallmark of Design Build Fly, against, and I'm not trying to brag against other competing organizations. We love all of our engineering brothers out there, right?
Absolutely.
But the unique aspect of AIAA's Design Build Fly is built around the fact that we change requirements every year.
That's
cool. You cannot bring the same aircraft year after year because it's not design optimized for whatever that mission set is. And that gives us a really unique quality in what we're doing because you're challenging these students every year to up their game in design. So it's not a get in a comfort zone and tweak, right? Refine the design. It is sometimes a wholesale, based on those requirements, a wholesale redesign of what's going on.
Throwing curveballs.
Yeah, curveballs. It's more challenging for the student teams. We love that aspect.
Yeah, that's the best part. That gives you a huge diversity in your design here. It's really, really good stuff. Okay, engines powered up. Okay, Cornell's pilot. Signal is ready to go. Engine is on. Rotation. There we go. She's up in the air. First turn here. It's a 180-degree turn through turn 1 into turn 2. Turn her back around. on the back stretch of the track now. The back stretch of the track, you have to execute a 360-degree left turn here. You know, Clay, we're feeling the wind on our backs here. We're parallel to the runway. We got a crosswind on the runway right now, and that plane.
It's been picking up.
But that, yeah, absolutely. But that plane is just cutting through the air. That thing's great. Turning around through 3 and 4.
Yeah.
Firmly in control.
Yeah, absolutely. Dealing with that crosswind like it's no big deal. Okay, 360-degree left turn, the loop on the backstretch. Okay, turn 3 and turn 4 coming around.
Force 1 is showing some strength there.
Yeah, absolutely. Like I said, this crosswind has picked up. Doesn't seem to be bothering them though. Okay, for lap 3, going through the 360-degree turn, one final time for their first mission. Okay, coming through 3 and 4. Okay, cross the line. Pilot's turning around. Trying to come in for a landing here. Once again, got a crosswind on the runway. Let's see what happens when bring it around. Duck Force 1 coming in for a landing. No problem. No problems here. Crosswind landing, greased it.
That was perfect.
Very good. Very good. All right, great flight. They're definitely going to be happy with that one.
Pilot was just checking his hands, making sure he was all steady. Yeah. Hey, there was a little white knuckle on that one.
Yeah, I bet, yes.
That landing was tough.
Yeah, absolutely.
Helicopters. Okay.
Yep.
Flag.
So as Cornell comes off the runway there with Duck Force 1, Chris, who's up next?
Up next is Team 34 from the University of Akron, which they're playing the Rue Express, and they are on mission number 2, and they've got a payload of 3 ducks and 1 puck.
Okay. Minimum requirements here for you, Akron. Say their plane's built like a Mack truck.
It's all alliteration, isn't it? Max Bucks, Mack trucks.
Max truck, yeah, all right. I'm in, this sounds like fun.
Yeah.
Now see, they have a long fuselage, and they have a tricycle landing gear, indicating the center of gravity is a little bit more forward on the plane. That's going to favor them here with this crosswind. That's going to give you more stability.
I've been carefully noting the landing gear setups on a lot of these different rigs that we have flying out here today. It's very interesting to see the different design approaches.
Yep.
Lightweight, resilient, low spring.
Right? Yeah. I mean, hey, got to keep it simple, but also, once again, it depends on what type of plane you're making.
And some have the two wheels up front with the tail dragger.
Yep.
Others more like this and a more upright.
The tricycle.
Yeah, tricycle
Yep.
configuration.
Out on the taxiway over here.
Thank you.
On the other side of the yellow line, I think.
I was asking them about their propeller setup, and they said they'd gone through 12 different designs to figure out which was the best optimized for their aircraft.
There you go. And a lot comes into play in the prop design, especially with what you're trying to do. I've seen some three-bladed props.
Yeah, there's even a couple 4, and there's the one with a counter rotator.
Yeah,
I can't remember the team that one is on, but it was quite sophisticated.
That was University of Washington, Seattle that has the contra rotator with the, yeah, absolutely. Okay, engine is armed.
Okay, looking for some operability from the engine. The engine, oh, maybe being a little temperamental on the Rue Express here.
Good.
Flight control surface is checked out.
Is the fuse pushed in all the way? Yeah.
Oh. Seems to be a little bit of trouble out on the runway there. They've removed the fuse for the engine.
The prop seems like the engine's activated, but the prop's not spinning.
Yeah. Not sure if there's a problem with the radio control or if there's a computer on board. Ooh.
So you'll have to see if the throttle advances. Wait just a quick.
Let's see. So once again, you have to put a fuse on the plane for safety reasons to make sure that the engine is only working on the runway. And it seems like right when they put that fuse in to get that engine going, it just doesn't want to go.
The prop is twitching, but just
yeah.
won't fully rotate.
Yeah. Okay, checking the elevators, rudder.
All the other controls are working.
Yeah.
Doesn't seem to be a control box issue.
Yep.
Is he allowed to unplug the battery?
Absolutely not.
Okay.
No. You cannot work on the aircraft on the flight line. Any checks you have to do, you have to make it on. All you can do is come
Giving them some time to try to work through this before they
Yep.
There's no working on the aircraft.
Oh,
there we go.
There it goes. There it goes.
Wow.
Man, that thing's got some power.
Got up in a hurry.
Okay, turn 1 and turn 2. Once again, unlike mission 1, this is mission 2. Mission 2, you're carrying cargo. You got they have 3 ducks and 1 puck on board, which is our minimum requirements, but they got to keep that plane up in the air, flying the same track as mission 1 for about 5 minutes.
And the ducks are randomized, yes.
Yeah,
You can't
absolutely.
predict which duck you're going to get.
Yep.
All fairly lightweight, but still.
Yeah.
Different, maybe different, a little bit different balance.
Well,
Configuration.
Yep. Okay, coming through turn 3 and 4 here. Once again, crosswind really showing there.
You can hear one of the teammates there calling out the
Yep.
stats on that.
Yep. Now it's interesting because some teams have so they have a pilot and they have an observer up on the runway, and then they have the ground crew in back. Some teams have the observer calling the turns, and some teams have the ground crew. It's very, very interesting to see how different teams are going to approach problems similar to the plane. Okay. Okay, good turn. Turning around back onto the main straight. Once again, dealing with a little bit of a crosswind, almost dare I say a tailwind at this point.
Turn.
Okay. Okay, turning the plane. 360-degree loop here.
Do you know the mascot of the university?
I don't.
They're the Zips.
The Zips. All right.
And the mascot is Zippy the kangaroo.
Zippy the kangaroo. Let's go. Well, I tell you, when this thing took off, it hopped up into the air real quick.
Looking solid through that turn.
Turn.
Yep. Yep. Okay, doing the 360-degree turn, backstretch loop. It's negotiating the crosswind pretty well, actually.
Turn.
So I went to undergraduate at Ohio Wesleyan University.
Oh, yeah?
Also in Central Ohio. And got to Akron a few times. Obviously, the Football Hall of Fame located there.
Yeah.
It's really a fantastic opportunity for anybody who hasn't done it. If you like pro football, it's a fantastic place. And I was there at the time when they played a game at the stadium there during when they do the induction ceremony.
Yeah.
In Akron. And what a treat.
Oh, I
what
bet.
a treat. It was really a fantastic place to go visit.
All right, Rue Express doing its thing there.
Looking strong. You're at
Yep.
28. Turn.
Okay, doing the back loop.
One word to describe this mission set here is adroit. I think they're executing right on schedule here. It looks very firm.
Yeah, what I've been saying, Clay, is that, you know, the missions that are kind of the harder ones to commentate are the ones that are going the best. No news is good news.
405. Make sure it wasn't just victory coming out. It wasn't victory coming out.
Okay, look.
Aviation history in Ohio is so strong.
Absolutely.
Such a great heritage in the state of Ohio.
Yep, the Wright brothers.
Wright brothers, John Glenn, Ken Armstrong.
Absolutely.
Fantastic.
Absolutely.
440. Turn.
I tell you what, you get out to Wright-Patterson, you see the National Museum of the U.S. Air Force. Amazing museum.
I got to visit Wright-Pat last year.
Amazing.
My tour of different facilities.
Yep.
Great. We have a really great AAA section.
Oh yeah.
Down there.
Cool.
In that part of the state, down in the southern corner of the state.
Yep.
It's really great.
Yep. All right, here we go. Circling around. We still got a crosswind on the runway, so you're gonna have to dial in a little bit of rudder here for this landing. Feather in the throttle. Yep, looks clean. Oh, very nice. Very good. You Akron making it look easy. Taxiing back. Yeah, there we go. Woo!
I like it.
Nice. Oh.
Mark, stop.
Safety lesson.
You do not want to go near that thing when the prop is going.
Don't stand in front of that.
Yeah.
If you're goosing it.
Clear prop, right?
Yeah, clear the prop.
All right, plane is safe.
I have diffused. Okay, good.
All right. So that was the Rue Express flying real good for their
Nice
cargo
job.
mission. Good job, dude.
Finally took off.
Hey, there you go.
And so they're the one after this one that's coming out.
Okay.
You see the kangaroo, Zippy the kangaroo on the
Yep.
on the rudder.
Yep.
Zippy the kangaroo, yeah.
There you go. All right.
I like it.
Okay. Chris, who do we got next?
So back up on the flight line, coming up next is team number 35. They're coming from the University of New South Wales with their plane Tomater, and I don't know if I'm saying that right, but anyhow. And this is mission 1 for them.
Mission 1. Okay. So
Australia, maybe it's Tomater.
No, it wasn't like that. No, it was more
all right.
Tomater, like we talked.
Tomater?
All right.
All right.
All right.
Like the number on the back side.
Yeah. All right.
So if you look at their tail, they've got the Southern Cross on there.
Yeah.
Down to Australia.
Yep.
And you look up at the stars. to see
Constellations in the Southern
I was
Hemisphere.
down there last fall, and it was my first opportunity to go see the Southern Cross.
Is it awesome?
It's spectacular. The whole constellation set down there is different than we're used to.
Absolutely. Yep. Okay, so it's University of New South Wales with their plane Tomater.
So I believe this university has come the farthest.
Yeah.
Distance than any of the
New
other
South
schools.
Wales, that's a long way.
15,000 kilometers, roughly 9,300 miles from where we are here. That's a poke. It takes a bit to get here.
That's a long way.
Yeah.
It's a long way. What do you think? 16-hour flight?
Yeah, well, usually you got to fly Sydney. Well, for them, from South Wales, you got to get to Sydney first.
Yeah, right.
From I guess, Adelaide.
Yeah.
Where they are.
Yeah.
And then get to the West Coast and then fly here.
Jeez. Man, that plane's got some power.
It sure does.
All right. So this is mission 1 for them. So it's just a flight test. Oh, we got to watch that crosswind.
Oh.
Come on.
Recovery.
Come on. Oh, no.
Yeah, that crosswind really took.
It's going to get you. It's going to get you if you're not careful. But Clay, like I said, teams come from such a long way. You know, they'll bounce back. They're tough. Made it halfway around the world. You know, one little thing like this ain't going to stop them, I don't think.
No, absolutely. I think they're going to be back.
Yep.
Right on the run. Before you guys walk too far, something's going to say yeah, at this point.
Every vehicle is prepping here.
Yep.
Wasn't for lack of power.
No, that thing goosed it. Really went.
Yeah.
Try using the ball in your arm ears. Yeah, Don, this spot's not going to work for stuff like this.
Okay, we got a recovery truck being dispatched here. Yeah, it's a good ways away. Yep.
They gauge the line.
You know, it's like you were saying before. You know, it's design, build, fly. Sometimes it's not. But those are the best lessons, right? Those are the ones that are going to teach you.
Front shot was this dude doing a walkie-talkie. No, I know.
Just confirming for the broadcast, we are College Park, not to my camera.
So that was a production.
I need a truck. Okay, great. Thank you.
Just.
Okay, well, they recover that. Chris, who do we got up next?
Next is the team from the University of Maryland College Park. It's team number 36 with their plane Duck Force 1. And they are on mission 2 with a payload of 3 ducks and 1 puck.
There you go.
So when I hear it, I'll get one of the volunteers.
Okay, University of Maryland College Park, team number 36. Oh, second recovery truck has been dispatched.
Yeah. Oh my goodness. Yeah.
Team, got to get a picture.
Any guesses on the mascot for the university?
It's a tough one. I know, it's probably not here.
My youngest daughter, Laz.
Nope, don't have that one.
Clancy the Lion.
Clancy the Lion.
Yeah, Clancy the Lion. You know, it's a unique American phenomenon, by the way. They really have mascots. It's nice to see in Australia.
Yeah, there you go.
That. A lot of the schools don't have them in Europe, of course, but in other parts of the world. But some of these students, I think, have adopted their own personas around the airplanes, around some features to give them a new moniker. It's nice to see them.
Yeah, absolutely.
So, you know, I live outside of Washington, D.C., about 5 miles from College Park, Maryland.
All right.
I'm in Maryland, so nice to see the Terps here.
There you go.
They're getting ready here on the tarmac. Great program up there. Great engineering program. University of Maryland. I've run into their professors from time to time.
Oh,
in the
yeah.
DC region. Yeah, it's really nice to be able to talk with them and see the Terrapins here on the runway. So that looks like a fast plane too.
Yeah, very, very skinny fuselage, but really, really long.
Yep.
Oh, okay.
They get the both profile shots.
Yeah. I was gonna say. Oh yeah.
Maryland historically known, you know, for great lacrosse.
Yeah.
They've got some amazing both men's and women's lacrosse programs in But before, when they were at the ACC conference, they've had some stellar years. Won the national championship.
No big deal. No, it's pretty good.
It's a lot of fun to be able to go up to College Park and watch them play in person. Really amazing thing. And of course, basketball as well. Great teams, both men's and women's as well. So they're a competitive force in NCAA Division I.
You know, lacrosse, I think, just in general, while we have some downtime, really underrated sport. Underrated. It's fun. It's fun to watch.
Super fun to watch.
Right?
My little school, I went to Division III school. We had quite a team. We played for the National Division III championship a couple times.
There you go.
Super fun.
Yeah.
I had a couple friends that were on that team. This is 3 decades ago.
Yeah.
Maybe 4 decades ago, actually. But dating myself here. But it was a lot of fun to go out and watch them. I'm, of course, from upstate New York, which is another hotbed. So you got the Mid-Atlantic, the Boston area where you're from.
Oh, yeah. We love
then,
lacrosse.
Upstate New York, Central Southern. But, you know, lacrosse now is spread as a sport throughout the country.
Yeah.
Way more popular. It's one of the fastest growing sports in America. And as you say, just super fun to watch.
It is. It's really underrated, you know. I didn't play it in high school, you know, so I was like, this is the problem. Then I watched the game, and I'm like, I like this. This is great. It's just boom.
It's super fast.
Yep.
Very athletic. Speeds at a premium.
Yeah, real physical sport.
Very physical to face off. So yeah, it's a lot of fun to watch.
Yep. Now, once again, you know, if you're lacrosse, you're wondering what's going on. We did have a little bit of an anomaly down on the runway. Recovery crews are just clearing out, but we got another team ready to go. We got University of Maryland College Park getting teed up here for their flight. And because it's here, a plane's flying over and everyone is looking at it, including me.
Trying to figure out what that is.
It's like maybe a 717. I would say MD-90, but you don't see those much around nowadays.
No, I think that might be a very large private. Yeah.
Is that right? 717?
Yeah.
There you go.
Yes.
All right, way to go.
All right.
Okay.
Oh yeah. Okay. The cameraman's telling me that's the plane he used to fly here. All right. Nice. Yeah. The 717 was actually engineered by McDonnell Douglas. It ended up getting a Boeing nameplate because Boeing and McDonnell Douglas merged in 1997. That's where McDonnell Douglas was working with their MD program. They went to MD-80, MD-90, MD-95, and then that would have been the thing after that. And then they changed it to 717 when they merged with Boeing.
A few years ago, I was on a flight across Texas, actually going to the New Shepard launch.
All right.
Out of Dallas. And I got on an MD-90, and I didn't know how many were in service anymore. But there's still a few out there.
Oldie but a goodie.
Yeah.
It's a good plane.
Yeah,
Good plane
absolutely.
design.
The first launch I ever attended was a McDonnell Douglas Delta II down in Cape Canaveral, then Air Force Station, now Space Force Station. And it was a lot of fun to watch that shoot up. They used to carry, they were famous for carrying the Hughes built 376 satellites, which were the old spinner.
For stabilization, right?
Stabilized satellite. Smaller payload capacity was, the satellite was a little bit under 2 metric tons, but really a very reliable satellite, and one that could provide a lot of the communications and television traffic distribution across the United States back in that era, back in the 80s and 90s.
When he says Hughes, he means like Howard Hughes' company.
Hughes, exactly.
Not a lot of people know that. That Hughes, after Howard Hughes passed away, they pivoted way into satellites, and they made a ton of satellite hardware. They still do to this day.
They were the parent of DirecTV Corporation.
There you go.
Everybody knows DirecTV for the direct home satellite television. That came out of Hughes. They had two divisions, Hughes Space and Communications, and then Hughes Communications Inc., HCI and HSC. Hughes Communications Inc. was the one that spun out the DirecTV satellite business in around 1995 timeframe, and it was the fastest growing consumer product of all time in the United States, and they quickly got to 20 million subscribers. Now, the way the internet has gone these days and streaming, that business is in decline now, but for a time it was the best digital television in the U.S.
Oh yeah, absolutely.
It invented the digital recorder, the TiVo system.
That's right. I remember that.
Was a spin-out. A little bit off topic here, but we got some time to kill.
Yeah, right. There you go. I actually think Maryland College Park's ready to go.
All right. Take your time. Checking the flaps.
Yep. All flight control surfaces are good. Okay, put it in the arming system. Engine is on. There we go, a little bit of prop test there. Ground crews need to clear. Pilot's ready to go.
So jump 30 seconds, please.
Engine's on.
Wow. Need about 3 feet to get off the ground.
It's a lot of power to thrust a weight there. Okay. Negotiating the first turn. Second turn, very good. Now once again, this is a Mission 2 flight for them. They're carrying cargo.
Do we know how many ducks are on this one?
3 and 1.
3 and 1.
Yep.
Airplane's looking strong.
Okay. Flight's looking good. It's like we were saying before, no news is good news. She's cutting through the air real nice.
It's great.
Yep.
Back in the 70s, there was some programming on TV with the Godzilla genre.
Yeah.
And there was a giant flying, I don't know if it was a turtle or a tortoise or a terrapin, but it was called Chimera. You ever heard of this?
I haven't heard of it, but I know Chimera, yeah.
And you got in fights with Godzilla and some other
monsters
back in the day, and it had thrusters that would cut, the legs would retract, and then it would spin.
Yeah.
And thrusters in the air. So, you know, it just makes me think of this a little bit with the terrapin in the sky here.
Yeah.
Takes me back.
There you go.
Hey, look it up on the internet.
I got it.
You got it.
Got it. Sorry, we didn't have cable growing up. I had the rabbit ears just like everybody else did. All right.
This is beautiful.
Yeah, it's really good. Yeah, looking real good. The wind's actually changed. We're back to having a headwind.
Yeah, you're absolutely right. It's coming straight down the runway now.
Yep, wind's coming out of the north. Now what that's going to do is when you're on the main straight, like where they are now, your ground speed's going to get a little bit lower, but that didn't seem to be a problem.
No crosswind on the landing.
Yeah, exactly. Now it's just about modulating that throttle, make sure you get the right touchdown speed. Circling around for a landing here.
Very nice.
Great landing.
Proud on that one.
Yep.
Terps did well.
Yeah, absolutely. That's University of Maryland College Park.
So wait to unload to get to the truck.
Making it look easy.
Yeah.
Exactly.
Over there. Don't forget.
Okay, so as they exit the runway, I got Chris back with me.
Oh, I'm running around. How's it going? Yeah. So up next on the flight line is the Team 37 from the Institute Tecnológico de Buenos Aires flying their plane, the Condor. This is the plane that has 151 ducks and 4 pucks, and this is their first attempt at Mission 2.
All right, this is the Delta Wing plane.
I doubt I'll see you today, so
Hey guys. I think I mentioned EJ, the other contestants that are here have nicknamed this plane the Flying Dorito.
Yep.
Because it's in a giant triangular configuration. It's a blended wing or flying wing design.
Yeah.
And it is built for capacity.
Yep.
I toured with these guys and spent about 20 minutes talking to them about their design this morning. Their first time competing. Came all the way from Buenos Aires to compete here. They're super proud, and they're very innovative, let me put it that way, with
Yeah.
this design and what this thing looks like, and built for capacity.
Yeah, Clay, I think it's important that you mention it. It's, we were saying it's a delta wing, right? But it's not just that. This is it's a blended wing as
Yes,
well, meaning the
exactly.
fuselage and the wing are kind of one contiguous unit. And that, like you said, that affords you way more space inside of the wing area. You could put cargo in the wing compartment with this design.
And I'll tell the listeners here for this live cast that we're actually seeing this in real world aviation now. There's a couple of companies that are absolutely going down this path with future designs for commercial aircraft that would use this kind of approach.
Yep. Okay, there they go. We got a good rotation. There we go.
Something. Everybody's rooting for the
Yeah,
Dorito.
it's super cool.
And
Look at that thing.
The Condor it's a beautiful thing to watch.
Yeah.
Fan favorite.
That's super cool.
The crowd is hooting and hollering.
Yep. Look at that thing.
Oh boy. Now is that harder to control, you think, for the RC pilot?
I would say, yeah, probably. Now, I'm just getting word here from the studio that there's 130 on this.
130.
130. That's on the upper end of what we've heard. But yeah, I'd absolutely think that this thing is a little bit hard to control because the blended wing, you don't have elevators or ailerons, you have elevons.
Okay, elevons.
Elevons.
I don't think I knew that.
Combination of the two. So your pitch and roll are using very similar control surfaces. And once again, it's big trade-offs there.
But it looks very stable in flight.
Yeah, oh yeah, absolutely. Okay, making it through the turn. Once again, that thing has 130 rubber ducks. Now I know people think like, okay, rubber ducks, they want it. But 130, that's actually a lot of mass for a plane this size. Yeah. Gotta be careful losing a little bit of altitude there. One of the drawbacks of blended wing, you start to roll, you start to lose a ton of lift because most of the fuselage is generating your lift there.
Exactly.
Get up!
You hear exultations from the crowd behind us. They're really cheering this one on.
Yeah.
Get up! 151.
We're actually getting official word from the judges. That's 151 ducks total.
Not in a row.
Yeah, they seem like they got their ducks in a row right now, I'll tell you that. Oh, careful. That's what I mean.
Gain some altitude.
Yeah, when you get into that 360-degree turn, you keep the plane banked, you're going to lose a lot of lift. All right.
You gain in payload capacity, but you're going to lose a little bit in maneuverability.
Yeah, absolutely.
Trade-offs.
Absolutely, that's what this is all about.
Pretty to watch.
It is majestic flying through the air, dare I say. That thing's super cool.
Very pretty.
Get up! Okay, going through the more tricky section here, where they got to do that 360-degree turn. Oh, she really loses a lot of altitude there.
There's a little bit more crosswind now. If you watch the sock, it's really coming from our backs now. It's supposed to up the runway.
Yeah.
All right. I think the other big part of this competition is that camaraderie amongst the teams. You get a lot of cheering each other on, helping each other out. You know, in the history of this event, you hear all sorts of great stories about how the teams support one another.
I'll say it once, I'll say it again. I'm parroted what I've heard from when I've talked to astronauts that aerospace is a team sport.
Absolutely.
It really is.
We have so many historical moments in this event where planes have had mishaps, or team members haven't been able to come, or team members from one school are adopted by others and they support them. And so, wow, okay.
Oh.
This one's tight on the turn.
Yeah.
Gaining some altitude.
Yeah.
Roar from the crowd. Love it.
Saved it. Okay. Circling around.
This area's coming in for a landing.
Yeah. Come on. Oh, all right.
Whoa.
The crowd goes wild.
Fan favorite. The Condor is a fan favorite.
That's awesome.
Huge roar. Wow. That was something special.
Yes.
Think they're happy with that one?
I think they're very happy.
I think they're very happy. That was sick.
Well done.
Perfecto.
Tough on those turns on the crosswind there, yeah?
Battery is 3,300.
Oh,
we consume full battery.
Full battery.
Yeah, because you need a lot of power to get that thing going. But that was great.
Congratulations.
Good job.
That was a beautiful. And you hear the roar of the crowd. You're a fan favorite. People love Argentina. Yeah.
There you go. Buenos Aires breathing a sigh of relief there, and a lot of joy. A lot of joy on the flight line.
I think the most unique aircraft in this competition.
Absolutely.
From a design perspective.
Yep. Okay.
Nothing else like it.
Yeah, that's definitely a unique one. So as they get off the runway, Chris, who do we have next?
Up next, we've got Team 38 from Massachusetts Institute of Technology flying their plane, the Hungarian S-Tail. This is mission number 2 for them, and they're carrying a payload of 3 ducks and 1 puck.
Okay, MIT.
MIT on the runway.
Okay, so this is their cargo mission. This is mission 2 here. Mission 2 is where you fly around with the minimum requirement, 3 ducks, 1 puck. They've chosen for the minimum. Now, just because they're choosing minimum requirement here doesn't mean like, oh, that's all they could do. No, that means they might be able to score points somewhere else, or at least they're trying to score points somewhere else. They do seem to have a very nimble plane out there. It's very, very...
Yeah, looks very lightweight.
Yep. Okay, engine is armed. Okay, engine's on. Oh, that crosswind. There we go. Powering out. Get up there.
Okay.
Yeah, the crosswind.
Such a light aircraft.
Yeah.
A real impact.
Yeah.
Coming straight from the left to right on that.
Yep. Oh, even then, you got getting a little bit of side slip there, but go through 360-degree turn, looking good.
The winds are picking up behind our back here.
Yep. The wind started this morning, Clay. They started coming from the north. Now it's moved it was north-northwest. Now it's moving just kind of more northwest, straight up.
Yes, this plane taking a slightly lower altitude than some of the others.
Yeah.
Looking for clean air.
Yeah, you got to feel around a little bit.
MIT from your neck of the woods up there in Cambridge, Massachusetts.
Yeah, that's right.
Yeah.
Grew up down the street.
My brother works at MIT. I was sharing this with you yesterday.
Yeah.
My brother's been working at MIT for over 40 years, and he runs the facilities at the Plasma Fusion Center.
Oh, that's cool.
The magnetic laboratory that's there on campus in Cambridge.
Sure, that's no fun at all.
They're just trying to recreate the sun.
Yeah, no.
Nothing going on with that.
No.
He really enjoys working up there. Some of the most smartest people in the world.
Oh, yeah.
Working on really hard problems.
As we'd say up there, they're wicked smart.
Wicked smart, yeah.
Wicked smart, dude.
Yeah.
All right. Once they got up in the air, this flight's seeming real straight, really nominal.
Dan Hastings, our president, who you probably met on. Did you meet him on Thursday night? He was here.
Oh,
He's our elected president, and Dan is a professor emeritus at MIT.
Oh.
We've got quite a heritage at AIAA with the university. They're one of our strongest supporters.
Cool.
Not that I'm biased here.
No, me neither.
I love all these teams equally.
Yeah.
Yeah. Of course, they are the engineers. MIT.
Didn't see that one coming.
Yeah. Do you know their actual mascot?
Oh, you know what?
When you think of engineering, what do you think? What's nature's best engineer? Builder.
Ooh. You know, I should know this.
Damn it, you should know this one.
I'm gonna
I just gave you a hint.
No, it's not coming to me. What do you got? Oh yeah.
Beavers are the best
Yep.
engineers. So Tim the Beaver is MIT's mascot.
Yep.
And I think it's apropos of a university that really is built on engineering prowess.
That's good. I mean, speaking of engineering prowess, this thing is flying great.
It's beautiful. Beautiful backdrop. We've got cotton candy clouds in the sky here. The wind seems to have died down a bit.
Yeah.
It's a little bit lighter now.
Yep.
Better in light air, I think, this time. Go for speed.
1 minute.
Recommend you guys keep in your own time. There's 52 seconds remaining.
Okay. Yeah, you're right about the clouds. It's like postcard, something out of a postcard here.
Spectacular.
Yeah. Doing a low flyby, circling around, coming in for a landing. Yeah, right. Buzz the tower. Negative, Ghost Rider. The pattern is full. Okay, feather in the engine. There we go.
Beautiful.
Nice landing.
Wow.
Come on.
There we go.
Very nice.
Super.
Good stuff. Recovery crew's going out there to save the plane.
Pilot duck.
Well done.
Good job, dude.
Nice flight. Yeah. Another twin engine coming at us.
Yep. Yeah, we got a twin engine getting out on the runway. Chris, who is it?
This is Team 39. They're coming from Rochester Institute of Technology, and they are flying their plane, the Carbon Tiger. This is mission number 1, second attempt for this team.
Yeah, I remember.
They were here this morning.
Carbon Tiger. But so this is their second attempt today, right? So that's once again.
Nice flight.
Good job, dudes.
Congratulations.
Yes, sir. Okay. Bravo cuts on too? Yes, sir.
Oh yeah. Oh yeah, she's lean.
Yeah.
That's for sure.
Carbon Tiger.
Yeah. RIT's second attempt for the day, and that's the kind of stuff that we were talking about. You know, I was saying a little bit before. You know, it's like Rocky. It's not how hard you can hit. It's how much you can get hit, right? You know, they had a little bit of a problem this morning, but here they are back out on the runway, ready to go again.
Resilient, I think, right?
Absolutely.
Resilient teams. And again, it's something you look for when you're hiring the workforce for all the students out there. Where you look for resiliency. You want
Absolutely.
people that can adjust and improve through the process and be resilient as employees. And it's important.
And, you know, I know we're working with RC Planes, but I must say, this is not easy to do. Man. Oh. The nose, I think.
Put it down, put it down, put it down. Put it down, put it down. Put it down.
Oh, ref saying put it down.
Put it down.
Oh no.
There's a road down there.
RIT, not happy with the result, but the plane did come down. It's down there on the runway. It seems to be in one piece there, except for the one part that came off there.
Pickups that we can actually use.
They'll be back.
I did.
Okay, we're dispatching the recovery truck again.
I guess it is. I don't actually. Yeah.
So, while they're in recovery mode here, again, this is our 30th edition of Design Build Fly.
Yeah.
Over the years, and for our estimates, we've engaged in 20,000 students in this competition.
Not bad.
30 years. And it's just a lot of fun to be able to see this thing continue to grow and thrive. At AIAA, we have 264 student chaplains.
That's great.
Around the world. The vast majority of the 200 of those in the United States here. It's really a pleasure to be able to engage with students when I travel around the country, which I do quite frequently. I'm on the road almost every other week. I make a point when I go to a certain location to go and visit with the university.
That's good to know.
To meet the students, the leaders, to meet the faculty advisors, to talk to them about what AIAA does well, what can we do better, how do we engage, how do we communicate and educate the next generation of aerospace professionals. It's a huge piece about what we're trying to achieve from folks at headquarters. We have about 75 staff, EJ, and we spend a lot of time making sure that we're relevant across the entire aerospace career. Some of these aerospace, and by the way, we have aerospace engineers, mechanical engineers, electrical engineers, computer science, all across. I mean, even people, some of the teams I meet, business students, where they're the creatives. And if you ask them, well, why are you doing this? Why are you part of the AIAA University? Never met him. I love aerospace. I love space. I love rockets. I love planes.
Understand that.
And I'm bringing my acumen. I'm bringing my marketing acumen and my communication skills. Some of these kids are just good at getting money out of various sponsors or university programs.
It's part of the game.
That's their superpower.
It's part of the game.
I know how to raise money, and so it's really interesting to see that aerospace attracts not just with the hardcore engineering, but you get a lot of people from different perspectives that want to be a part of our industry, and we love that at AIAA. And we love to see these university students thriving in this environment and learning. And it's changing, by the way. It's rapidly changing over the course of time. Today that we're in a world, if I may, with digital engineering, digital thread engineering. You've got advanced computing power. You've got 3D printing, advanced manufacturing techniques. So the design cycles of everything that's happened has shrinked. That things are happening much quicker than they used to be in the old days. And the techniques that are used are really advancing.
And Clay, I'll speak to that. The whole new space industry, the whole commercial spaceflight industry. I can't tell you how many kids I talk to that are all part of startups, trying new tech, doing 3D printing with metal. It's great stuff, and it's really, really cool to see the AIAA, kind of encourage all that. That's good stuff.
We've had a tremendous influx of private capital coming to the marketplace. Not just by it's both air and space. Vertical flight. Some of these other systems I talked about, wing design, Suicide. I went out to see Boom. Out in Colorado, I got to fly their simulator. Didn't crash it, thank God. I've flown a few. So.
So. Like if you have
in this industry, in this new aerospace industry, it really has changed a lot. It's good stuff.
I always say it's not from my era. It's not your father's society anymore, institute anymore. It's something that's a completely different. When here's a fun fact for you. When I go and talk to the students, I say, "Where's your news from? What do you think the number one news is?"
I would say social media.
Instagram.
Insta.
Which is both interesting and a little frightening.
I'm telling you, I get most of my space news off of social media. Companies love posting about what they're doing, and the cool stuff that they make.
And it's a great medium. It's
Yeah.
a great medium. It's great for storytelling. But you know, we also want, you know, a lot of these engineering programs, you know, the students are writing advanced technical papers on incredible topics. Some of the student conferences I went to last year, some of the students' papers that won was, you know, thrust vector control for a nozzle.
Yep.
These kids are amazing, right?
Really smart.
Super smart, and being able to employ a lot of advanced technology. You have an interesting aircraft circling overhead here. What do you got?
It's a KC-46, if I'm looking at that right.
All right, so we got a tank.
Yep, that's right.
All right.
That's right. They are flying around out here, but it looks like the recovery teams are getting ready to clear. So I'm going to go over to Chris here. Chris is going to tell me who we have up next.
Up next, we've got our team number 40 from the University of Illinois Urbana-Champaign with their plane Quill. They're on their second attempt, or their first attempt of mission 2 with 3 ducks and 1 puck.
Okay. All right. University. Let's see.
University of Illinois Urbana-Champaign.
Yep. University of Illinois
So
Urbana-Champaign.
flying Illini. We have here. You know that, right? The Illini.
I actually don't. Fill me in.
We got to brush you up.
I'm striking out over here.
Brush you up. You know, University of Illinois is a Big Ten school.
Yep.
Great engineering program there, mechanical engineers. I met with this team earlier today, aerospace engineer, mechanical engineers, and Jason, who's their advisor, who's been doing this. I don't want to. I think he's OG. I think he might be 30 years.
Yeah.
In this, he's got a great team of aerospace engineers and mechanical engineers that are working on these projects. They're really a fantastic bunch, and we had along. He was the one who said, by the way, that it can be design, build, crash. He was the one that told
Yep.
us that. Yeah.
Yep.
So, interesting aircraft design. This one looks powerful as well.
So we got an above wing, yeah.
We got the 2 feet, the 2 wheels up front, and the tail dragger on the back.
Yeah. And not only that, they got their wheels in a fairing there. They got fairings on the wheels.
Yeah.
High wing design, long fuselage.
Looks like the old planes that were used for speed racing, right? And those covers on the.
Yep.
Really beautiful classic design.
Yep. Absolutely. So they're flying mission 2 here. This is their cargo flight.
Yeah.
Oh, look at that thing. Beautiful.
Oh, that's solid.
Yeah.
That's great.
Once again, no news is good news. That thing's
very much.
Oh yeah.
Left 1, 40. Third.
Some of these teams you have different people in the pilot seat, right?
Yep.
Some of them use professional pilots.
Yeah, they're
hired guns.
Yeah. I've noticed that.
Yeah.
Some of them are using a couple of the same pilots. Some of them bringing their pilots of their own. It looks like University of Illinois Urbana-Champaign I think they brought their own pilot over there. We still have that crosswind on the runway, but you wouldn't tell by looking at that thing.
Getting to see this aircraft up close, they spent a lot of time on the prop design.
Yeah.
You can see it's paid off.
Yeah, absolutely.
Really picture perfect in flight.
Putting in the work pays off in aerospace all the time.
It's a flawless flight.
Yeah.
Third.
Just turning through 1 and 2. Picturesque clouds in the background. Okay. once again, this is their cargo mission. This is mission 2 here. Mission 2 is where you have to move ducks and pucks around. They're moving the minimum requirement. We have 3 ducks, 1 puck on board. And once again, we're talking about trade-offs here. It's one of the things that this challenge is going to kind of foster. Do you go for more cargo? Do you go for better, bigger banner to pull? Do you go for ground missions, right? We'll see which strategy is the best one. But once again, with the light cargo load that they're carrying here, it's much easier to fly that plane through the air. The more ducks and the more pucks you put in this thing, the more it's going to change the flight characteristics of the vehicle. All right. Circling around. Okay. Nice touch. There we go. Oh. Perfect.
All right, look at that.
Very good.
Nice applause from the crowd.
Yep.
Well done.
Ian, wait. Ask. You're good.
See, the line I did very well in the NCAA tournament, men's basketball tournament this year as well.
Oh yeah. There you go.
Made a good shot.
How far did they get?
They got all the way to, was it the Elite 8, I believe.
That's pretty good.
I believe that's right.
That's pretty good. It's not easy to do.
No, they got at least a stop.
I'm not sure how far they got from there, but that's, I mean, even getting to the 8 is really, really good. That's not easy to do. Okay.
I pick them almost every.
There you go. There you go.
Usually great cars.
Good luck, guys.
Yeah, absolutely. Okay, as they exit the runway, Chris, who do we got next?
We've got team number 41 from the Ohio State University flying their plane Catfish 2.
Well done, guys. That was a great flight.
I was talking to the
Flawless.
team a little bit as they over here in the staging area. They're on mission 1. This is a 2-day build on this plane. They crashed their first plane. They built this plane in 2 days. 98% of this plane is made out of fiberboard, or what do you call it, like a particle board, fiberboard.
Really?
Yeah. And then we've got a carbon rod through the wings.
Did they built this here?
In 2 days. Not here, but on the, yeah. So
Okay.
they crashed their plane out about 2 days ago. And
Oh, wow.
Go to Home Depot and get some supplies.
Let's go. That's what I'm talking about.
That's
From the Ohio State.
Throttle cut is confirmed on.
Okay.
Left fuse in.
Fuse in, arming the engine.
Right fuse in. Okay. Can we do a slow prop test? Okay. Throttle cut off.
Now we got a twin engine design here from the Ohio State.
Ohio State University, Columbus, Ohio.
Yep.
Good.
You got this one.
Alright. Throttle cut off.
But Buckeyes. Oh. Okay. So once again, this was a 2-day build from them. They're doing mission 1. I love it. Definition of when life gives you lemons. Let's go. That thing's flying real good.
Yeah.
So if this is mission 1 for them, they got to do 3 laps on the course. Definitely got a lot of altitude up there.
Say it's way up there.
Yep.
Clean air.
Yep. Wow. Oh. Coming through 3 and 4. Uh-oh.
No crosswind.
Okay, yep. I mean, not gonna lie, it's kind of expected to make it out of poster board, but also for a poster board plane, that's flying great. But yeah, the benefit there is lightweight.
Now, have you talked to any of the teams about the single engine versus dual engine design choice that they make?
I did talk to one. I talked to Worcester Polytech.
Yeah.
I talked to WPI, and I asked them about the 2-engine design, and I said, "What were your expectations for driving something like that?" And they just turned to me and said, "Rule of cool." And I'm like, "Oh, hey, that's an expectation. There you go."
Like a P-38 light.
Yeah, absolutely. P-38 is one of my favorite planes.
So I was a kid, that was my coolest one.
Turbo supercharging.
Yeah.
Can't lose.
Lockheed Martin, if I'm not mistaken.
Yeah, it's a Kelly Johnson design.
Yeah.
He designed that when he was like 27. It's just, oh, all right. Well, you know what, Kelly Johnson? I made my bed today, so there you go.
And of course, here in Wichita, this is where they make the King Air.
Yeah, I love that plane.
Another great twin-engine design aircraft that's really a stalwart in the aviation world.
Yeah.
And there's still high demand for those aircraft.
No, they boogie. They're nice planes.
Yeah, really nice.
Real fast.
Well designed.
Yep.
Comfortable. I've only flown once in a King Air, but really a great aircraft.
Okay, coming in for a landing. Okay, come on. Yeah,
Wow.
all right.
Beautiful landing.
Yeah, greased it. Oh, little bit of wing touch, but no problem. The Ohio State coming in here.
The Ohio State University performing well.
2-day build, no big deal.
Yeah, no big deal. That's resilience.
Right? There you go. And that's what you're trying, that's the thing that you're trying to foster here, right, Clay?
Yeah. Somehow I can hear Hang On Sleepy in my ears.
Yep.
One of the most famous fight songs I think out there in college football.
Right. Okay. There we go. Cheers from the crowd.
Big cheer from the crowd.
Okay. As the Ohio State vacates the runway, Chris, back with us. Who do we got next?
Up next is Team 42 from the University of Oklahoma with their plane Foul Play. And this is mission 1 for this team.
Okay, so they're doing a flight test in foul play, spelling F-O-W-L.
Yeah, of course. I was going to ask.
A
little shaky on that.
I'm going to guess that their mascot might have something to do with chickens.
No. I mean, come on. You don't know the Sooners?
No.
University of Oklahoma?
No.
I think, Hunter Montgomery, who he's watching this, because Lyndon Montgomery's our CFO at AIAA. He's a Sooner. So, I mean, you can't, he's not going to like the chicken reference. I'm just
sorry, man.
Yeah. Good job, guys. The Oklahoma Sooners, also fantastic university. And Damon Wells, one of my great friends, engineer from that school. He's now the number 3 at the NRO, actually.
Really?
Yeah. Also went to MIT for his graduate degree, but he just taught. I teach a class at Georgetown University. He came and guest lectured the other night and did a great job. Yeah.
All right.
I love the paint job on this.
Yeah.
The Flying Tiger.
They got the shark tooth.
Yeah, fuselage looks great.
Yep. Twin engines. Oh, come on. Get up there.
Need some symmetry. There we go.
Okay. Foul plays in the air. Okay, so once again, they're on mission 1, so this is 3 laps of the course. Got to do a 360-degree turn there. You're playing in the background, we got another KC-46 floating around.
Yeah, that's a beauty.
Yep. Yeah, the KC-46 ain't bad either. Okay, coming around turn 3 to 4, completing lap 1, back onto the main straight. Now, have a pretty hefty crosswind here, but it's a crosswind, it's actually not too bad. It has changed since this morning. This morning, the winds were coming out of the north. Now it's switched to northwest, and now it's straight west.
Straight west.
Yep. Here we go, lap 2, 360-degree loop. Okay, moving on into lap 3 here.
Okay, lap 3. Nice clean 360-degree turn there.
Solid flight so far.
Yeah, absolutely. Okay, completing lap 3. Coming in for a landing right at the end of the lap. Hey, all right.
There you go.
Very good.
Impressive.
Yep. Even with that crosswind, greased that landing. Very good. Foul play back down on the runway. Okay, as the ground crews go out and recover that plane, Chris coming at me with another team. Who's up next?
Up next is Team 43 from the University of Colorado Springs, and their plane is the Duckinator. And this is mission 2, and their payload is 20 ducks and 4 pucks.
Wow, that's the beauty right there.
Oh yeah.
But really nice design.
And this is flight number 100.
Okay, we got flight number 100. Thank you, Chris. Yep. I like this plane.
This plane is one of the most handsome out there. If they had a good-looking plane design, I think this one would win.
Absolutely.
It's a beautiful plane.
There you go. Kind of.
It's a little bit like a Caravan, I think we were saying.
It's like a cross between a Caravan and a King Air. It's got a King Air tail, but a Caravan front.
That's right. That's right.
I like it.
Yeah.
This plane flies nice too.
It's a beauty.
Yep.
It's almost like they knew we were going to be flying in Wichita, Kansas, where they
yeah, right. You know, that's still kind of dawning on me. This is my first time out here. We're in a place where every one of those planes is made. I see those planes flying around all the time.
35% of the general aviation aircraft in the world are made right here in Wichita.
That's ridiculous.
It's got one of the largest manufacturing bases in the world here. Because there's so much general aviation that's done here.
You wouldn't know.
Supply chain.
It's awesome.
Yeah, it's really impressive.
This is my first time out in Kansas. I'm impressed.
No, they're very proud of their heritage, and this dates back, as I said earlier today, over 100 years from the beginnings, basically, of aviation in the United States, where you had Beechcraft and Cessna, Clyde Cessna.
Yep. I mean, you know, this was old. Boeing during World War II. They were making the B-29. This is one of the places where they made it.
Interesting.
That was very advanced for the time. This and Seattle were the only 2 places they ever made anything like that. It speaks to the manufacturing base that's here. You wouldn't know. Okay.
So yeah, Walter Beech, who's the founder of Beechcraft, along with his wife, Olive Ann Beech, founded that company. You know, he was originally in business with Clyde Cessna, and then split off, and they formed their own company, and obviously very successful with the Beechcraft line. And then Olive Ann Beech actually ended up leading that company for over 40 years. She was an incredible force.
That's impressive.
After he passed on, she led that company for decades after that.
That's impressive.
And she really is a phenomenal, and here, legendary here in the Wichita area. And they were just really a force here in employment and manufacturing. And he was, as it turns out, a barnstormer pilot when he first met her.
Really?
Yeah, and did a lot of flying competitions and barnstorming, and then they started a company together and started making airplanes.
It's great.
Yeah. Boy, that is very solid in flight.
We're sitting here talking about the history. The plane's just doing its thing back there. It speaks volumes to the design.
Yeah. I'd be interested in talking to these guys a little bit about that design and whether they did like a CAD sim on an actual GA plane or not, or if they just did this on their own. I wonder if they did some simulations to try to figure out what that design.
I'm gonna have to talk to them.
Yeah. But it's beautiful.
Yeah, and it's flying great.
If you didn't know it, right? You think of
Yeah, right, exactly.
You think it's like a real plane.
Right.
So I'm at a distance, yeah.
It's really nice.
It's like you know, Hollywood in the 80s. You know, they don't have computers. They made miniatures. That's what it looks like.
That's
What we're
exactly
looking
right.
at. It's great.
Boy, solid.
And the duck's got a nice window seat too.
Yeah. Yeah, it's cute. Yeah, they had posted a picture online with the duck, and he's looking out
Nice.
the front window.
That's awesome.
It's a great. The social media game for some of these schools is great.
Yeah, there you go.
They really have upped their game.
And it's like you were talking about before. That's so important.
So I was just in Colorado Springs for Space Foundation's Space Symposium event.
Nice.
There's something close to 14,000 people at this event. From all around the world.
That's
talking about space.
Yeah.
And it was fantastic. I want to thank Major General Heather Pringle for hosting me there.
Yep.
And she was amazing, and her team puts on really one of the premier events in the world for space professionals.
Yep.
Huge history there, obviously, with not only the Air Force Academy in Peterson and Space, we had Cheyenne Mountain and Space Command there.
Yep.
But they do a terrific job every year. I've been going to that event for 30 years, and it's one of my favorites.
I have to make it out there sometime.
Oh, it's beautiful. You know, you're at the Broadmoor Hotel at the base of Pikes Peak.
Whoa, okay.
You know, Rocky Mountains as your backdrop.
Beautiful.
It's just a spectacular place, but really a lot of work does get done there. It's a great venue for teams to meet. As I say, it's a marathon of meeting. I think I probably met with 40 different space agencies when I was there.
Crazy.
During the week.
I mean, Colorado Springs, another aerospace giant, right? We were talking about being an aerospace giant here. There's that place too. Oh, dealing with that crosswind.
Yep.
Come on, baby. Oh. Yeah, all right.
Right down the center line.
Yeah, they greased it.
Yeah.
Great.
Some fancy flying on the landing. Big roar from the crowd.
Wow. Definitely got to be happy with that flight. So as UCCS gets off the runway, Chris, you're back with us. Who do we got next?
We got Team 44, and this is mission 1 for that team. It's the team from Columbia, the country of Columbia, and the UPB is the institution they're at, and they're playing as Barracuda.
UPB, Columbia, Barracuda, another international team, right?
You got little Wilson sisters in your head right now?
Oh, yeah.
All right, you're feeling it. All right.
Yep. Kind of want to get the guitar out.
Little heart.
Yep,
I saw them
absolutely.
at Jazz Fest a couple years ago.
Nice.
Still rock.
Oh, yeah.
Just tell you right now,
No, they still got it. Absolutely.
Yep. A couple of Zeppelin covers.
No, that's what I was just about to say. They do a mean cover, Led Zeppelin.
Yep. And Nancy Wilson.
Yep.
All right, so you go this way. You hang out with him. Do you have a ground crew? Yeah. You have a ground crew? So you can help set up, but then you come over here.
Yes. Well done. Actually, you held that center line pretty good.
Fine, dude. Planes in one piece, dude. It's all that matters. Yep.
It looks solid in flight. Yeah.
We're talking with the pilot from the
and it
UCCS.
shifted, the wind shifted a bit this direction, just coming in.
Got a little crosswind going. Yep.
Yeah. What's your guys' mascot there?
It's a mountain lion.
The mountain lion. Well, that's apropos. Okay, makes sense. You got 2 ducks up front.
Two
right?
pilot ducks.
2 pilot ducks. I like that.
That's awesome.
So Columbia here.
Yep. All right, they're putting their plane out on the runway here. Let's see what they got. Let's see what the Barracuda can do.
You ever scuba dive?
I've snorkeled, not scuba dived.
My first scuba diving adventure ever. It was like a resort dive, and we go down and we're just diving off a beach into this coral reef. And the guy tells me before the dive, hey, you know, there's barracuda out here. Don't have any shiny things on there. If you see one, stay perfectly still.
Really?
Because they just sit there almost stationary in the water. They're moving a little bit.
Yeah.
But they go after the shiny metal thing.
Jeez.
You gotta watch it when you're diving with the barracudas.
Yeah. Okay.
Here we go.
All right. Barracuda powering down the runway. All right, circling around through turn 1 and turn 2. Doing the loop there. All right, flying down the backstretch. Pretty straight, pretty nominal there.
That was me.
Just cruising along there. Now we do still have that crosswind, but it is a crosswind, but it's died down a little bit. It's not too bad here. Should make flying pretty easy. We got honestly a perfect day for flying. Visibility's as far as the eye can see.
I just had to look this up, but it's the Universidad Pontificia Bolivariana. Am I saying that right there? My Spanish is a little
Universidad Pontificia Bolivariana.
Yeah, wow, UPB.
UPB.
It's a very large university in Colombia with the main campus in Medellin, founded in 1936.
Awesome. Now that's one of we have 2 Colombian teams here, right?
I think that's right. Yeah.
It's 1 of 2. Truly an international competition. Teams from 15 countries.
26,000 students. No mascot, so you don't even have to guess this time.
Okay.
Yeah. The engineering is one of their mainstays.
There you go. And it's actually showing with how this plane is flying. Real good. Okay, coming around. Okay, coming in for a landing. Perfectly aligned on the runway. Oh, very nice.
Nice flight.
Very nice. Almost no bounce. Perfect.
Yeah. Well done.
You know, one of my favorite things is when these planes touch down, or the ground crews out here and the pilots start jumping around. They're getting pumped about it. That's awesome. It's so good to see. I was trying to say this a little bit earlier. You know, I get it. These are RC planes. This is not easy to do.
No.
This is not a simple task. You know, you think about it. You make it fly around them. That's not easy when you're doing all the engineering from scratch. That's not an easy thing to do. These aren't kit planes that you throw together in the store. These are 100% homegrown designs.
With a unique mission set.
Absolutely. Yeah.
Absolutely.
That was me doing that. I couldn't explain that well.
All right. So as UPP comes off there, what do we got next, Chris?
So up next is Team 45 from Case Western Reserve University flying their plane Bathtub. And this is mission 2 for them, and they're got a payload of 12 ducks and 4 pucks.
12 ducks, 4 pucks for the Bathtub. Case Western Reserve University.
In Cleveland, Ohio. Another Ohio school.
Yeah, there you go.
Of aviation.
Yeah, my cameraman's from Ohio over there.
There you go. Love Case Western. It's a treasure up there in Cleveland. Really great technical school, great engineering program up there.
Yep.
Had a couple visits. One of my sons looked at that. He ended up not going there. He ended up going to Lafayette, but loved Case Western.
There you go.
A great campus.
Now they have a very interesting double main gear design there.
Yeah, four wheels.
Yeah.
You don't see that.
No, that's there's only been a few planes throughout history that have a gear design like that.
Well done, guys. Nice job.
Okay, here we go. The Bathtub's in the air. Okay.
You hear that a lot in reference, right? Like flying a bathtub.
Yeah, right.
Driving a bathtub.
Right.
Yeah. We actually have the bathtub.
Yeah, there you go.
I mean, it doesn't fly like a bathtub, that's for sure. It's flying great.
I think it's doing well.
Still a lot of teams that are flying. Thank viewers on YouTube and Twitch. Stream tomorrow will start at 8:30. Basically, just recap the day. We have way better weather, stuff like that.
Do we know how many, what our total number of flights?
We're over 100 flights here. We can ask. We'll I'll make sure we ask them when some stats are usually used. Yep. Wrap up should be pretty good here. 55 passengers. After the final flight. Okie dokie. Okay, and we're back. Just needed a quick hydration break there. We're back up. Watching more flights here on the flight line. I am EJ, the flight line commentator here with Clay Morey, the CEO of the AIAA. Clay, you still with us over here?
I'm still with you. I'm just enjoying this beautiful flight by Case Western Reserve University. The Spartans are really showing their stuff on this one.
Absolutely.
That plane is doing great.
Oh yeah.
Solid. The wind has definitely sat down a little bit here. Not as much of a breeze behind us across the runway. It's almost coming directly down the runway now, but it's definitely a softer air here as the sun starts to set behind us.
Yep, absolutely.
In southern Kansas here.
Mm-hmm.
In the banks of the Arkansas River.
Yep, absolutely. All right. Case Western Reserve University bringing her down for a landing here. Oh, a little bumpy, but she's okay.
All right, she's in all right.
Good. Yep, go good.
Okay.
I was skipping a jump at the end of that one, but all right.
There you go. Didn't Chuck Yeager say any landing you can walk away from?
Yeah, I think that's right. Yeah, I think that's right.
Okay. As they vacate the runway, we got Chris back with us. Chris, who do we got next?
We've got Team 46. They're coming from the Indian Institute of Technology, Kharagpur, in India. And their plane is Pushpak. And this is mission 2 for them, and they're carrying a payload of 20 ducks and 4 pucks.
All right.
It's a beautiful bronze wing design on this aircraft. It looks very slick.
Yeah.
We get that every time.
The leading edge is a little bit swept on the outside of the wings, too.
Yeah.
Real nice.
Came with the shrouds over the wheels there.
I like it.
All right.
We've one of 2 teams we have from India competing in this competition
Yep.
this year.
Absolutely.
You said, Chris, this is Jaipur?
Karapur.
Maybe performance thrust test?
Karapur. Okay.
Yeah. I have to go over there. I've asked him about 6 times to pronounce it for me. Karapur. Yeah.
All right, engine test is good. Engine is armed. Let's do this.
Looking good.
Good? You're good? Yep.
3, 2, 1.
Okay. She takes off once again. They are carrying 20 ducks, 4 pucks. This is mission 2 for them.
Okay.
So this is their cargo flight mission.
Solid coming out of that turn.
Absolutely.
You mentioned Chuck Yeager. Chuck Yeager plays a huge part in the history of AIAA.
Yep.
By flying the Bell X-1 aircraft that broke the sound barrier.
Yep.
And the engine that powered that, really rocket-powered plane, was built by a company that was made up of the founding members of the American Rocket Society.
All right.
The American Rocket Society was one of the 2 organizations that formed AIAA.
There you go.
Yeah, it's called Reaction Motors. Is the name of the company.
Yeah, that's right.
Yeah.
Reaction Motors.
So if you look at the redesign on our logo, which we did last year, and it depends. It's a little bit of a Rorschach test for whether you're an air or space person, because the aviation people I talk to always see it as the nose of an aircraft breaking the sound barriers and the shock wave coming.
Yeah.
If you're a space person, you tend to see it as a rocket launch. But
see, I'm greedy. I say, why not both?
It can be both.
Right.
Absolutely. That's how we think about it, because we're aerospace.
Yep.
But we love the design, and it really was a beautiful effort by our team to embrace the history of AIAA while we could refresh that brand and make it something that was a little bit more fun and exciting and up to date. The logo we had before had been in place since 1963 and was a great logo, but we thought it was time for something a little more tied to our history and a little bit, and that transition was really important for us, that we did that with and got the buy-in from all of our volunteers and members across the AIAA community. So we're really pleased with it. We rolled that out, EJ, at DBF last year. So
really?
That was our first big brand relaunch. We had hats for all the kids and stickers and water bottles, and we got just a tremendous reaction from the next generation of aerospace professionals. They loved it, and I think it's been quite a hit across the organization. So I hope that everybody out there understands that history piece of it and loves it as much as we do. We really think it's a fun design that's inspired by these amazing pioneers. By the way, that American Rocket Society, if you go back and look at the history of it, not just engineers, but also some science fiction writers in there. It was that magical era there of time where people were reading Jules Verne. They were thinking about going to space. This is even in the days of kind of Robert Goddard and the rocket engine, liquid rocket engine testing and things like that. And so it was really incredible. And you look at some of the pictures that they show of the tests that they were doing out in New Jersey of these liquid engines. And let's just say that the safety protocols were not what they would be today.
No, they kind of, sent it, to use modern terminology. We're talking about adapting with the times, right?
It's like three guys behind a little berm just ducking their heads when they were firing off these rockets. But it was a lot of fun, I think, back then.
Reminds me of October Sky, when they're going to launch the rocket. They just hide behind a piece of plywood.
What was that quote? Which one of you boys is Homer Hickam?
Yep, exactly.
A great movie.
Yeah, that's one of the reasons why I like space so much, October Sky. And the book Rocket Boys with it.
Well, this is just a beautiful flight here.
Yeah.
This guy's really solid design.
Yeah.
And I like that's what you're saying, a little sweep on the tips of those wings.
Yeah, the sweep on the wing will favor the speed there. This plane should go pretty fast, and it absolutely is. And that is one of the things, getting this thing done.
the beautiful reflection now with the sun setting behind us off the bronze color of the fuselage. And the wings.
Looks great.
It's gorgeous in flight.
Beautiful. All right, coming around. Timer's going off. Time to bring it on home.
You know, India as a country is ascendant in aerospace right now.
Yeah.
They've had some tremendous successes in the space end of the business, landing the Chandrayaan-3 lander on the lunar surface. They have the GSLV-3 program that they've been flying, and they're looking to build their own space station now. So
absolutely.
Amount of progress.
And capsule too, man-rated.
Yeah, the Gaganyaan system.
Yeah, that's a big deal. Oh, looks like they had a little bit of trouble with the gear.
Landing. Yeah. On that first hop, that back set of gear got caught up.
Recovery crew's going out there.
Crosswind got him.
Yep, and that's it's been, the wind has been a challenge here.
It really had picked up just in the last few seconds of the flight.
Absolutely. Okay. First thing the ground crew is going up there to do is safe the plane. So Chris, you're coming back to us here.
Back to you.
So we just had
the team from India, from the Indian Institute of Technology, Kharagpur, with their push puck, Team 46.
Okay, so as they go and recover their plane, who do we got coming out next?
We've got Team 47 coming up from Johns Hopkins University, flying Peking J, and this is mission 2 for them, and they've got a payload of 18 ducks and 3 pucks.
All right. Here we go. The Johns Hopkins plane looks to be carbon fiber. Am I seeing that right?
I think that's right.
Yeah. Very light. Okay. Ground crews getting the team ready. Okay, so once again, we are at the 2026 AIAA Design, Build, and Fly competition here in Wichita, Kansas. I am EJ, the flight line commentator, with Clay Morey here, the CEO of the AIAA. With me here, Clay.
It's been a treat to share this experience with you on a flight line today, EJ.
It's fun, man.
We've seen some amazing missions. These students are really showing their stuff today with the design.
Yep. Okay, flight control surface checkout. Arming the engine, fuse in. So we've actually, Clay, I was just hearing, we've had 86 flights just today. We're over 100 flights total easily.
Yeah.
That's great.
That's great, super.
Absolutely.
Yeah? Yeah. Who is your observer? Yeah. Okay. You know what you have to do?
Okay.
Ready?
Pilots ready? Here we go. Mission 2. All right. Johns Hopkins Peking J is up in the air. Once again, mission 2 for them. Cargo mission, moving ducks and pucks around. Okay, coming out of 3 and 4. Plane's flying great. Now that the winds have died down, really gets these planes to show their stuff. This is great.
Yeah, Johns Hopkins is located in Baltimore, Maryland, just north of where I live.
Yep.
One of the finest technical schools in the country.
I'd say so.
Known for their engineering and for their medical programs.
A lot of medical research gets done down there.
Also known for their lacrosse, by the way.
Yeah, all right, let's go.
Yeah. The Blue Jays are formidable as a lacrosse team.
All right. Doing the loop. I'd say the engineering prowess is on display here.
This is a very clean flight.
Yep.
A lot of control, a lot of power.
Yeah. And that's with cargo as well, making it look easy.
It really looks like a great design.
Yep.
You were saying carbon fiber maybe looks like the way to go for these tubes.
I would say so. I've seen all kinds of planes. I mean, we saw the Ohio State with a poster board design. I've seen 3D printed planes. I've seen carbon fiber.
Yeah, it's incredible.
It's good stuff.
I did a tour of the University of Stuttgart, which is one of our student chapters.
Cool.
In January.
Nice.
Their student rocket team, high-end rocket team, showed me their carbon fiber tank design that they had built.
Carbon fiber tank?
Yeah, they do compression wrapped, compression overwrapped pressure vessels, COPVs.
Oh, that kind of tank. Okay.
So they wind these things, with carbon.
Yep.
I asked the team, I said, how did you do this? And they said, well, it was too expensive to buy our own system, so we built one to wind the carbon.
There you go. Well, looks like coming in for a landing here. All right. Oh. Okay. There we go. On the ground, a little bit of wing touch, but down in one piece.
So yeah, I guess if you're an engineering student, you can't buy it, you're going to build it yourself. And they figured out how to wind these tanks. And this team is working, actually, there's only one team so far in the world, a student team, that has gone above the Kármán line.
Really?
It's 100 kilometers.
Yeah.
Only one team in the world, that's University of Southern California, has done a two-stage rocket that's actually gone above the Kármán.
That's impressive.
These guys in Stuttgart want to be the second team.
There you go.
So they're building a two-stage system now with a hybrid engine and motor to see if they can do that. So I was super impressed.
With those COPVs?
Yeah, with those COPVs.
Wow,
Yeah.
that's impressive. Okay. As Johns Hopkins exits the runway, Chris, you're back with us.
I'm back. So we got Team 48 from the University of Texas at Austin flying their plane Peacock, and this is mission number 2 for them. First attempt, and their payload is 3 ducks and 1 puck.
Okay, minimum requirements here for the cargo, but that doesn't mean that they ain't going to score some points.
All right, Longhorns in the chute.
There we go.
Hook 'em horns.
Yeah, that's how it is.
Their rival's coming up next.
Oh, really?
Texas A&M.
Oh,
right,
no.
Aggies right on the heels.
Yep.
All right. It's friendly. It's a friendly.
Yeah, of course. Chris disagrees. Okay, arming the engine.
Rudder here is swept back a little
Yeah.
bit on the design.
There we go. We got a tricycle overhead wing.
Overhead wing.
Yep. Okay. UT Austin takes to the skies for mission 2.
That looks tough right there. That's a great one. Nice turn.
Yeah. All right. Coming around turn 3 into turn 4. All right, she's looking good.
44.
Oh. Looks like we got some winds up there, Clay. Pushing the plane around a little bit.
A little bit at altitude, it's a little bit different.
Yeah, it's nice and calm down here on the surface. But even going up 100 feet, 30 meters, that'll really change things.
Again, on wind direction, it looks like it's coming kind of down the runway now.
Yep.
More, so less crosswind,
yep.
more headwind.
Yep.
You like how underneath the wings they have green and red there? You can kind of tell exactly.
Yeah. Yep. Oh yeah, they do.
See how they do?
37 seconds.
Yep. Absolutely.
Red right return, kind of like Bodie. Yeah. Red's on the right for sure.
Yep. Yep. Okay, doing 360-degree turn.
Firmly in control.
Yeah, that doesn't look like she's moving around at all now.
I'd like to
40
thank all the
seconds.
people that have tuned in for this live stream. During
Oh,
the course
absolutely.
of the day. Yes, this is our first time doing this at AIAA, but we were really thinking that this would be a great way to share the experience.
Yeah.
Other students with families, with team members that couldn't attend, with aerospace enthusiasts that love this event so much, and volunteers. So it's fantastic, and we appreciate the work you've been doing out here, EJ, with your colleagues, and great work by the teams to bring this home. And let me just say, the drone pilots, I think, have been doing a super job.
Oh yeah, he's good at what he does, and well, we'd like to thank you for having us, Clay. Absolutely, it's an honor and a pleasure to be here, and I know it's a privilege too.
41 seconds.
We really appreciate it.
I hope you're enjoying it as much as I had so much fun in Tucson last year that I couldn't wait to get out here to Wichita.
I love this. Like, I don't really have a better way to put that.
Yeah.
I love it. This is great.
It's super fun.
Yeah.
We also do, we partner with IREC on their rocket competition in the middle of Texas. We'll be doing that in June, and we again have about, I think, close to 2,000 students for that one.
That's awesome.
Teams, again, from all over the world. I think about 160 teams usually enter that event.
Yep.
And it's super fun to see the designs.
High-powered rocketry is extremely underrated as a hobby, let me put it that way.
John Langford is one of our past presidents. His family is also the folks behind Estes model rockets.
Oh, yeah, no big deal.
So I get to see him from time to time. And John just released, to coincide with Robert Goddard's at the 100-year anniversary of
liquid propulsion.
Liquid propulsion in the United States, and its first. They did an Estes rocket that mirrors that design, that kind of
the pendulum.
The very strange pendulum.
Yeah.
Design. And so they unveiled that at our SciTech event in January. Really interesting to see that, and we actually tested one off the other day outside our office.
Really?
We went and got a safe field. We flew it, and John showed up. He's also got a great company called Electra that's building a hybrid plane design.
Really?
Are you familiar with that?
No. What now, when you say hybrid, what type of hybrid are we talking about here?
They have electric motors, but also a gas generator engine in it. So, extremely efficient. You want to think about like a Prius in the air, but efficient design. But this blown wing effect with the engines. They have, I believe it's 8 engines that are 4 on each side of this plane. It's a 9-passenger, 10 overall, 1 pilot, 9-passenger aircraft. Extremely, they call it ultra short takeoff and landing.
Yeah.
So it can take off in football field side, actually less than a football.
That's impressive.
Yeah. So really could change the face of regional aviation when they bring this thing to market. They've got a lot of big plans for it, so it's a really interesting design.
Now, Clay, refresh my memory. Does the wing turn, the main wing turn on that design?
Does not.
No, it does not. Yep, coming in for a landing.
Nice smooth landing.
There we go. There we go. UT Austin nails it.
Way to go. Way to go, Longhorns.
Taxiing back.
Look at that. Showing off.
Yeah, that's impressive right there.
Well done. Solid design.
Okay. Chris, you were saying this UT Austin comes off the runway. Who's next?
We got Team 49 come from Texas A&M University College Station with their plane Aggie Bullet. And this is mission 2 for them, and they were carrying a payload of 42 ducks and 6 pucks.
42 ducks.
All right. All right, moving out.
He has it on the plane.
Okay. Now, when they go out there, out onto the runway, the teams are only allowed to have 3 people out there. You need an observer, you need a ground crew, and you need a pilot. Ground crew is going to arm the plane to get that engine ready to go because we don't want the engines live before the plane gets out onto the runway.
Okay, arming.
There we go.
Transparent fuselage there on the back side.
Yeah, you can actually see, you can see some of the ducks in there.
Absolutely.
All right, I got a window seat again. Okay, engines on. Okay, wind picked up just a little bit.
Yeah, just right at the taxi there, just kicked right in.
Gonna get a little bit of a gust. There we go, turning around.
Again with a crosswind here.
Yeah, it's intermittent, but when it's there, you know. Okay, doing the 360-degree turn there. Very nice. Once again, it's the cargo mission for Texas A&M College Station here. They're moving a pretty good amount of ducks there. We got 42 on board. Coming around
6
back.
pucks. Of course, the pucks are a lot heavier than the ducks.
Yeah, right, exactly.
Puck to duck ratio.
It has to be 3 to 1 per the rules.
Yeah.
And you don't kind of think about it, but like that's a lot of hockey pucks. That's a lot of extra mass on the fuselage, right?
You ever play any hockey up there in Boston?
I never played hockey. I played football, baseball, and basketball. Hockey is big up there.
The Bruins, of course.
Yeah, they did make it into the playoffs. I'm not sure how far they're going to go, but we'll see.
Two of my kids played hockey.
Oh yeah?
Through high school.
Nice.
One through high school, one through middle school, and loved it. Great sport.
It is. I got into hockey after high school, which is kind of a shame, but yeah, it's really fun to watch. Really good sport.
Good solid.
Yeah, this plane's flying very straight, very nominal.
The wind has picked up quite a bit now.
Yeah, we're starting to get that crosswind back again here. Let's see if that comes into play when they're flying around. Okay, turning around through 3 and 4.
All right.
Looks real good.
I don't know if those watching at home can see, but we have spotters on either ends of the runway here that have a flag system that they raise to let them know when the turn has been completed.
Mm-hmm. And I just got a good flag at that end of the runway, turning around through turns 1 and 2. Okay, doing the 360-degree turn again against picturesque Kansas sky. turning around here. Through 3 and 4.
They talked about the calm before the spawn. You put the calm after.
Yeah, right. Yeah, exactly.
Turn.
Got 3 more planes in the queue here.
Yeah. Coming around. So again, this is Texas A&M College Station on their second mission here. This is the cargo mission. They got 42 ducks on there, and I believe, what was it, Clay? Six pucks behind it.
Yeah, that's right. 6 or 7. Is it 6 or 7?
I think it was 6.
6, yeah.
All right, circling around. Okay, crosswind's starting to pick up. You're starting to see it. Plane's starting to slew a little bit. Bringing it in for a landing. 1 bounce. Oh, he saved it.
Yeah,
that was awesome.
Yeah, nice work. Nice work by the pilot. Big cheer for the crowd.
Yeah, that was great. Oh yeah, crowd goes wild.
I think they were on their haunches there when watching that flight. Yeah, they are. Look at that. There they are. They're on their haunches, right?
Yeah. Look at that.
Like the spirit right there. Right?
There you go. That's
nice
awesome. Nice save, man. That was great. That's awesome.
Right.
Okay, they've won best cheer, Clay. I think that was pretty good.
Spirit. They got a big crew here from College Station.
Yeah, absolutely. All right, we got Chris back with us here. So, Chris, before that, I'm gonna ask you, how many more teams have we got? We're getting a little late in the day.
We've got 4 teams staged right now, and depending on how things go at the time and how the flights go and a variety of factors, we may get to all of them or we may not. They will stop flights as long as they get in the air by 6 p.m. Central Time. That'll be the last flight that goes off. Right now we've got 4 teams out here, so may get through all 4. We'll get through the next, in my opinion, probably the next 3.
Okay. So who do we got up at the plate now?
Next is our team from Central Florida, University of Central Florida, flying their plane Albee, and this is mission 2 for them, and they are carrying a payload of 18 ducks and 2 pucks.
All right, UCF. Here we go.
Golden Knights.
The Golden Knights.
Here we go.
Their college football team has the best helmets. They had the helmets with the shuttle tiles.
Yeah,
That made my day.
The Space U.
Yeah.
They do the Space U every year. It's fantastic.
Absolutely.
Just down the beeline there from Kennedy Space Center and Cape Canaveral Space Center.
Oh, no.
Oh, dear. So this was second mission, so we had cargo on there.
Yeah, we had cargo on board.
The weight distribution.
Absolutely. Yeah. That's what I've been saying. It'll really bite you if you're not careful. All right. Unfortunate there, but they'll bounce back. Like you said, Space U.
Yep.
A little more resilient than that.
I think there was some ducks strewn across the tarmac there, unfortunately.
No. Okay. Well, okay, so as they go and recover, who's up next, Chris?
So we're bringing up Team 51 from Embry-Riddle Aeronautical University Prescott with their plane Hail Mary, and this is mission number 2 for them, and they're carrying a payload of 3 ducks and 1 puck.
Are we sure? It looks like Arizona.
It is not.
Okay.
Sorry to tell you no, but it is not.
I mean, the paint job looks like Arizona.
I've been talking to them, so I know it is.
Okay, very good.
Well, if they're the Prescott campus. That's Arizona.
Okay, there you go.
Because we have both Embry-Riddles competing in this. We have Daytona Beach and Prescott.
Absolutely, there you go. So not the Eagles in Florida there.
Nope.
Okay.
Nope.
You're there, you're good.
Again with the transparent fuselage.
Yeah.
You can see right through there.
Yep.
Embry-Riddle also a great AIAA student chapters, I should say. We love Embry-Riddle.
Yeah.
Got a couple of students intern with us at headquarters last year.
Really?
Oh yeah.
All right.
Did a fantastic job, Joe. Shout out to Joe if you're watching, Joe. Great job last year.
And while we're on the subject, everybody that's stuck around through the entire, we're getting a little late in the day, but if you stuck around with us through the entire YouTube stream on the AIAA YouTube channel or on my own Twitch channel, thank you very much for watching with us. We do appreciate it. Be sure to hit that like and subscribe. I don't say that lightly, right? It's not really what I'm about, but I'd say for content like this, for fun like this, and most importantly to encourage the students in what they do, probably a good idea to do.
Absolutely.
Okay.
All right, here we go, Embry-Riddle.
Engines are armed. Control surfaces checked out.
It's impressive nose design.
Yeah, it's in it like all integral into the nose there. That's really nice. I wonder how much analysis they did on the nose cone and the props with that configuration, right?
That's pretty key.
Yeah. Okay. Engines are on.
A lot of power.
You're Prescott in the air. Oh man, that crosswind. Oh man.
This plane is moving.
Yeah, she's quick.
Very fast.
Like I said, that prop of that nose cone doing work.
That's some advanced design.
Yep.
Wind has definitely picked up behind us, AJ.
Absolutely, yeah. Nasty crosswind. Oh man. Okay.
Wow.
Dude, that thing is booking.
That is moving. It's almost as fast as anything I've seen fly today.
Yeah. This is reminding me of one of the first flights we saw today with the University of Ljubljana.
Yeah,
their plane was.
Yeah, it was also really moving quick.
They were cutting through the sky just like this. Okay, coming around. Okay, there's the 360-degree turn again. Through the main straight, still booking.
Yeah, just really breathtaking.
Yeah.
Like you were saying, not your kid radio control plane. These
no,
really,
that's what I mean.
Really moving, advanced design,
yeah,
lightweight, high speed,
yeah,
precision flight.
It speaks to the prowess of these students, like we were saying before. This is fantastic. Look at that thing go.
Excellence in engineering.
Yeah, there you go. And Clay, I was speaking to it before. This is not easy to do. It's not easy to design a prop like that. It's not just like, oh, here we go. Here's a prop, here's some propellers. We're going to go really fast. And we're going to, be able to maneuver the plane without, and stay in one piece. That's not as easy as you might think. I actually do have a good amount of viewers on the Twitch side that are students at Embry-Riddle Prescott right now. So shout out to those guys.
Embry-Riddle Prescott, they came to play today.
They really did.
It's a very impressive mission.
Yeah.
I like that hold on the
on
the bank turn.
Yeah. Just aileron right back into the 360.
Some of these turns like ice skating, like you hit your triple Lutz or whatever.
I'm okay with that. I was calling it the backstretch loop. I mean, it's not a loop, but I just have turn 1 and turn 2 right now. And we call those ones down there, we call them hangar because they're closer to the hangars.
There you go.
Man, I'm just kind of awed by that plane.
I'm awestruck by it as well.
Yeah.
This plane really can move.
Okay. Gotta be a little careful with the crosswind now, though.
For landing.
Yep, here we go. Bringing it in. Greased it.
Huge round of applause for the audience.
Total 101. So we need to hit.
That's total. Okay. Cool. All right. Well, Chris, this is normally where I'd be asking you when the next flight is, but I think we might be done for the day.
This is it for today, and so we'll start off tomorrow morning at, I believe, around 9 a.m. Central Time, and we'll start off with Team 52 doing their first mission, so they'll be up first tomorrow.
Okay.
And that Team 52 is from California State, Long Beach.
There we go. All right. Well, let me get this back up in here like this. All right. So Clay, I think that's going to do it for day 2 for us. We're live on the camera over there. I think we're coming to the end here. I'd say this day was a little bit better than before.
It was an impressive day.
Yeah.
We got a lot of flights in today. What was the number?
We made 108 total.
108 total.
88 on the day.
88 on the day.
Very good.
This has been great. I want to thank all the volunteers that have come out here to help us with this. We have over 50 volunteers on site, my AIAA staff. There's a lot of work that goes into this thing.
Yep.
By the way, flight safety is paramount here. Hey, great flight. That was impressive. Thank you. Yeah. Beautiful design.
Yep.
Really, it takes a lot to put one of these things on, make sure that we do this safely, efficiently. Weather, always plays a role.
Yep, absolutely.
Really thanks to everyone that's been involved in making this a hugely successful day. The volunteers and the organizing committee do such an amazing job. Our 30th anniversary doing this. And so all shout out to all of them and their families and everyone that's watching, because this has been really an amazing day.
Yep. All right. It absolutely has. Now, we are going to start up at 8:30 tomorrow.
Okay.
8:30 tomorrow.
Yeah.
We still have another day of flying here. We have mission 2. Teams are going to do more cargo missions, and then we have the banner flights tomorrow. That should be
interesting.
That should be really fun.
Watching them pack those banners yesterday.
Yeah.
Some big banners out
That
there.
was cool. Yeah, absolutely.
See how they go.
So, oh wait, we're over there.
We're on the drone. All right, I love it.
All right. Hey, guys, while you're out there, like I said, if you want to make sure you want to be pinged when we go live, be sure to hit that bell over on YouTube. Make sure you know exactly when we go live. Tomorrow at 8:30 local time. That's going to put a wrap here on day 2. Be sure to like and subscribe. You're still over there. I said, where are you going? We're over here. What are you doing?
He's behind us now. Well, hey, and I'm AIAA Clay, the CEO of AIAA. It's been great to join you today, EJ.
Clay,
thanks.
Thanks. It was a pleasure having you here with me.
All right.
All right, guys. Hey, see you from Wichita. We'll see you tomorrow.